is the project management for geologists. Can you still see my screen, Nolene?
Can?
Okay. That bar had disappeared. So I'm quite happy and excited and looking forward to this. When the meetings committee thought about this, I was wondering how it would turn out. I think everyone can acknowledge it turned out quite well, looking at the program and the speakers. So I'd like to say thank you to the ladies who were responsible for organizing this. So firstly, Natalie and Fiona. So thank you very much for getting the speakers and the program together. Thank you to Nolene, the Vice President of the meetings, for all the hard work and the stressing. So I'm glad this happened. And as I said, I'm very excited about this. Thanks to Lali and Sally as well, who are supporting with hosting this event. So thank you very much to those people. So just in terms of events, the ones in white are obviously all the ones we've had, all save for the first one were virtual and we're quite successful. So thanks again to the meetings committee for organizing these and making sure they are well attended. Thanks again to the attendees for supporting these events and yes, spending your time with this. We acknowledge virtual events can be quite draining, but thank you for joining us. So today we are obviously on the project management for geologists. Upcoming, we've got the SAMESC workshop, and then to end of the year, we've obviously got the Technology Day and African Exploration Showcase. I think this is now in its 7th edition. Correct me if I'm wrong, Nolene. So looking forward to that. That's always a nice one to end of the year. So look out for. You would have seen the circulars already for SAMESC workshop and Tech Day. So looking forward to that too. Okay, and lastly, but not least, these events would not be possible without our sponsors. So firstly, our annual sponsors, GeoExplore Store and Maxwell Geoservices, MaxGeo. So thank you very much to our annual sponsors and our event partner, Colin Rice, who will be also be presenting after tea. So thank you for being the event partner. And with that, I will stop the sharing, and then we can get on with the program. Richard, can you try and get your presentation up? While he's getting it up, just a reminder, look out for the 2021 calendar. It will be out soon, the calendar of events. So look out for that too. Okay, there we go. So, what I also didn't mention, I'm looking forward to all of the speakers. I've come across. May you kindly mute yourself?
Don't worry.
Sorry, let me just mute. Okay, thank you. All right. Apologies for that. The speakers, a whole lot of them I have crossed paths with or come across in the past. And the first one is Richard Monchoi, who was a client, I think more than 10 years ago. I haven't seen him in like 8 years. We have crossed paths with him as well, and he will be talking to us on project management for dummies. And yeah, please go ahead, Richard. Thank you.
Thanks very much, Sifiso, and thanks very much to the GSSA team for putting together, as always, a great program. Jen Chair, thank you. So I thought we just sort of discuss the principles, high-level principles of basically geological project management, and just some things to think about when we're out in the field there and when you're busy with these exploration programs. So the strange thing is that many of today's project managers have not actually set career goals to become project managers. And you wouldn't actually consider yourself a project manager. You may consider yourself an exploration geologist or perhaps even a project geologist. But you all know that you must successfully manage projects to move ahead in your career. So clearly, you know, in today's world, project management has become a critical skill, not a career choice. So it's not like you sign up to university and do a course in project management. So we're just going to go through some of the sort of foundations of geological project management that will hopefully set the tone for the next 2 days of courses. So, and you can see what happens when you don't have effective project management. So let's just start at the mining project life cycle, which I'm sure you guys are all very familiar with. So typically you've got your concept, pre-discovery, discovery, take it through the feasibility stage, development, startup, and mining. And as geologists, we're all involved in really in this whole value curve. And you can see how the relative value of your projects increases, peaks at discovery, drops off, and in development, and then you get maximum peak during mining, and then obviously goes down to closure. So I've divided this into 3 sections. We've got exploration project management, which takes us through the concept, pre-discovery and discovery. Feasibility project management basically takes us through feasibility studies. And this is going to be an important concept in how we set up our projects at this stage to take us through a successful feasibility study, which then lines the project up for mining and ultimately closure. So the key is to gear up your exploration program to move your resource to reserve. Now, I'm sure you guys are all very familiar with the slide. So here we've got exploration results, typically at our discovery stage. We move into the resources, inferred, indicated, and measured. And what I really want to focus on today is, as geologists, how do we set up a program at this stage to move ourselves across into the reserves category, into the probable and proved, where we take into account the modifying factors, our usual mining, metallurgical, economic, marketing, legal, environmental, social, and governmental factors. I know myself as a geologist, I'm often guilty of ignoring these, and you think that your primary goal is just to prove up a resource. But you can really, we can talk about front-end loading the project later, but you can really add a lot of value to the project by doing some work at this stage, taking into account these factors, really at an inferred category, and move yourself into the reserves category. So if we look at feasibility studies, you've got, and we're very familiar with inferred resources, indicated resources, and measured resources. The study stage consists typically of 3 stages: scoping, pre-feasibility, and feasibility stage, before it goes into construction. So your resource stage at a scoping level should be an inferred. And you can see how your level of confidence in the geology, which is this orange line, increases throughout each stage of the project. And really, you've got your highest level of confidence, or it starts to peak during your pre-feasibility study. And as this peaks, the mining catches up and your project execution catches up. So you can see that your resource needs to really lead ahead of your mining and your project execution. So just to drill down into some of these stages of the feasibility studies. So really, a scoping study, which is the first part of the feasibility study, in order to conduct a scoping study, you should at the very least have an inferred resource, because your level of confidence in your inferred resource needs to talk to your scoping study. What is the purpose of a scoping study? Well, it's to determine what your project could be. So you develop a concept. Does it make economic sense? And what's really critical as an output of each stage, and each stage of your project, should be to define the next stage of the study. Okay, so really you're doing a high level, well, we've discovered gold at 1,000 meters. How much does it cost per ton to mine gold? Do we have a business case? So if the answer is yes, you then move forward to the next stage of the study. Now, before you go into this pre-feasibility study, you should at the very least have an indicated resource. Your mineral rights should be at a prospecting rights stage. And really, in a pre-feasibility study, you're going to be determining what it should be, okay? And really, these are what we call option studies. So here you're going to weigh up a whole bunch of options. Case A, case B, as I've listed here. You're really weighing up alternatives in order to maximize your NPV and IRR. And your project may have other other requirements. For example, in today's world, it's very much we're looking for lowest capital, quickest to revenue, etc. So it really is a trade-off about a bunch of options. Once you've got the correct trade-off, you move into a measured resource category and then start with the feasibility studies. And really a feasibility study is taking one option forward from your pre-feas into a feasibility study, examining this in a lot of detail, getting a certain degree of engineering behind it. In fact, a very high level of degree. Go out, get costing, and really you have a high level, you have a very detailed financial model, and where you can make a final investment decision, right? After investor review, and after this final investment decision, this is where the big money starts flowing. You move into construction, commission, operation, rehabilitation, and implement final land use. While you're going through this process, we need to think about how our mineral rights and what the legal tenure is going through this. We need a lot of detail in today's world to submit a mining right application. It triggers environmental authorizations, and really you need one option to take forward into this mining right application, and in order to obtain your mining rights. So let's just drill down into a little bit more detail on what we need to investigate our modifying factors. So at exploration stage, really the big thing that we're working on is an exploration model, and we're really just leading up to discovery, right? And so we haven't got a defined resource yet. And there's not much else we can really focus on at an exploration stage after discovery. After discovery, we need to start with, hopefully get a target resource. What do we want our resource to be? We can start thinking about resource variability. How consistent is the resource? How much infill drilling do we need to get this, to start moving this resource into an inferred resource? We can do basic geotech logging. I don't think we've really will have any input for mine design criteria. We'll have to start thinking about a production profile, and a capital payback period. For example, if we're exploring for something in the Northern Arctic, or in a really remote area, you need a fairly big resource to make that work. So there's no point going and looking for a really small deposit. So you do need to start thinking about some of the modifying factors at a target resource stage. And then we should always be thinking about the metallurgical aspects of things, or really the geometallurgy, as recovery plays such a massive role in project economics. Otherwise, the rest of the things will just process plant waste, infrastructure, marketing, legal, environmental will start to flow in due course. And at this stage, at a target resource stage or discovery stage, we can start scoping out the community issues. And these could be, if you're working in a war-torn area, obviously that's a non-starter. So, believe it or not, we are already thinking of these issues at a discovery or exploration stage. Also at exploration stage, you should at the very least have your access agreements in place with your local communities. As we move into scoping study, so we try to scope out what it could be. Think about, we need an inferred resource. We now need to start thinking about a reef cut definition. What are we actually going to mine? How are we going to mine this? Are we going to open pit? How does that affect dilution? And the reason we have to start thinking about this is because at this early stage in your study, in your inferred resource, the scoping study, you want to start doing some geotechnical test work. So, and the reason is because you need to, at the very least, think about, what are your basic mine design criteria? Do you need to, let's take the bushveld, for example, on Merensky UG2. What is your mining cut going to be? And remember that a resource is defined as something that can be as reasonable extractions of being mined. Well, what are those that mining criteria? So we often just benchmark it. If we're looking at UG2 or Merensky, we say, okay, cool, what a typical mining width is for conventional mining, 1 meter, 1.1 meter. and you can start doing your research on the back of that. We then move on to your production profile. So at this stage, we'll just benchmark your mine design criteria. And guys, I just want to close this door quickly, so give me a second. The dogs do not need help with the presentation. So the scoping study, we've got a conceptual production profile. The reason this is important is it helps with sizing of our process plant and our capital numbers going forward. So you might be looking at a coal mine where you've got a conceptual production profile of 100,000 tons a month. From the back of that, you can scope your wash plant. You've got estimated recoveries, and so you can benchmark your wash plant, your process plant, and you know from that you can more or less size your waste rock dumps, your tailings. You get a sense of infrastructure. Can you rail it? How much is it on a dollar per ton basis? Very important. What commodity prices you're going to use, and going forward on legal, you need to map out your process at this stage in order to tie up all the legal loose ends. In other words, how do you move your prospecting right at this stage into a mining right application, into a mining right, and an ability to ultimately take it to this level. At your scoping study, you should also be starting to scope out the environmental issues. And at this stage, you should also be online with all community issues. We then move on to pre-feasibility study. And when you enter your pre-feasibility study, you should have an indicated resource. At this stage, start thinking about your resource to reserve conversion. You don't necessarily, in fact, it's highly unlikely that you need to get your whole resource into reserve. And so we should, at this stage, understand your resource variability. How much of the resource do we now need to, how much infill drilling do we need to move our resource into reserve? Typically, it's a multiples of a capital payback. So you can start seeing now that you, at an inferred resource study, you need to know what the amount of capital is in order to move into this stage. So by understanding, by addressing all these points before you move into drilling an indicated resource, it just helps you successfully execute this pre-feasibility study. At a pre-feed stage, you should be doing detailed geotechnical test work, sending samples into the lab. You should be doing mine design criteria trade-offs. You should be doing production profile trade-offs, metallurgical trade-off studies with the laboratories, process plant trade-offs, infrastructure trade-offs, etc. And close towards the end of the pre-feasibility study, you should be submitting in your mining right application. And you also need a detailed pre-feasibility study with one option going forward to submit for the compilation of your environmental impact assessment. And you should also start thinking about your social labor plan at this stage. So you as a geologist don't necessarily have to execute all this work, but the work you do at this level feeds into this. So for example, ensure that when you are drilling for your indicated resource, make sure you've got enough core material to do your geotechnical test work. Make sure that you've got enough material to submit to the laboratories for metallurgical test work. Your engineer won't be responsible for getting this, the material. You as the geologist are responsible for getting this material. Furthermore, the material that you submit for met test working needs to reflect what you're going to mine, right? And what are you going to mine? Well, that comes out of your mine design criteria. So it's a bit of an iterative process, but you really need to start thinking about these things at these levels. Furthermore, you need to characterize your waste. And when you submit your environmental authorization, the EIA, Department of Water and Sanitation want to know what is the impact of that waste on the environment, and if it's benign, that can save you a lot of money in project execution. Department of Water Sanitation is part of your waste management license will typically assume the worst, ask for all these tailings dams and waste rock dams to be lined, and this comes at enormous cost. So by characterizing your waste at an early stage, you can really save a lot of time and money as you execute on a project. And of course, as we move into a feasibility study, we should be taking everything, one option going forward, detailed engineering for all these modifying factors. Marketing, we should start to think about an offtake agreement. It's tricky to get in place before you've made the final investment decision, but this is certainly going to be one of the requirements to sign off on a definitive feasibility study, or at least have a plan going forward, how to tie that up. So you need to know your product, and you need to know your market. During your feasibility studies, you should be tying up your mining right license, and so South Africa, as we all know, it takes quite a while. So we should be just tying up loose ends on that. Your mining right license should be well underway, if not already awarded. Your environmental authorization should be well underway, and you should have the community on board. So you can see how we've moved from a resource into a reserve, and what we need in order to make these decisions on what options, we need a financial model which shows the economic viability. So my point is, you need a plan to work through the process, and these steps logically follow each other. You cannot have geotech and mine design criteria without having a resource. Once you've got your geotech, you have your mine design criteria, the mining engineer can produce a production profile. On the back of that, they can do metallurgical test work, do your process plant design, they can do the waste design. On the back of that infrastructure, you know how much product you're going to produce. You've got sufficient information to submit your mining rights application, environmental authorization, which starts to tick that, and you've got your SLP in place, and you know what your impact on the community is going to be. So everything flows up from your resource. So let's just look at some sort of high-level points on each of these points. So in your resource, obviously your geological block model is essential, right? The guys cannot go forward with your mine design without this geological block model. And I've seen it so many times when the block model delays and you can't get your mine design criteria out, and that just delays a whole feasibility study. Geotech, I'm just reminding us all now, everyone forgets about it. Ensure sufficient material for geotech test work, especially if you're drilling underground stuff. Drill core is expensive, reef material is valuable. So plan on putting in those deflections or extra drill holes, etc., to get that material for your geotech test work. That'll go to the laboratory. It will be destroyed. You'll get it back in pieces, and possibly, if the pieces are big enough, you can possibly send some of this in for met test work. On your mine design criteria, ensure sufficient geotech test work to allow for proper mine design criteria. And only after you've got this mine design criteria can your mining engineer move on to the production profile. And this production profile drives your feasibility costing. Again, on the met side, ensure that you've got sufficient material and time for your metallurgical test work. This met test work takes ages, months and months to do. The labs always run behind schedule, and ensure that your material that you submit for the met test work is representative of what is going to be mined. The mine engineer is not going to submit the material, you have to submit it. On your process plant, your metallurgical test work feeds into your recovery, and the production profile feeds into the sizing of the process plant, and the recovery of your process plant plays a major role in the project economics. So it's really worthwhile getting this right and giving yourself time to optimize this metallurgical test work in order to help improve your project economics. Obviously, every mine produces waste, so ensure the availability of material for waste characterization. That's hanging wall material, that's footwall material, that's going to go into waste rock dumps. That's part of your water use and waste management license. And then make sure you get material back from the Mintech or whatever lab's doing your metallurgical test work. and so they can characterize what your tailings is going to, material is going to look like. Marketing, ensure that you've got a clear path to market. We're seeing it in South Africa with coal bed methane projects, stranded gas assets, etc. How do you get, there's no doubt the resources there, how do you get it to market? Look at the Waterberg coal field, for example. Commodity price forecasts. So just have a good sense on what your project flies at. I think always a good idea is to, does your project work at spot at today's prices? And then take off 20% and see what happens to your project. Infrastructure, don't forget to do soil geotech for your civil designs. While you're on site, get an excavator out there, get the geotech geologist out there, do some pits, and start to understand the soil geotech. That's the first thing engineers want to know is your civils are such a cost driver on your surface infrastructure. And this soil geotech is a huge driver for your civils. So it's important to budget for that. Start thinking about putting in your water use license. Where you're getting water from, how much water you're going to store, what is the impact of your mine, and you need a geological block model in order to do the geohydrology. So start thinking about the geohydrology and putting in a water use license. I've put it here. It could probably also go under legal. Under legal, make sure you've got sufficient information to convert your prospecting rights to mining rights. And the level of detail required by the DMRE is immense. So don't think that this is an easy process anymore. And you really need to front-end load your project to the scoping and pre-feasibility stage to get through the seemingly. Start thinking about local ownership criteria. This is obviously different for each legislative regime. For South Africa, for example, we've got Mining Charter 3. So this links into a social license to operate. As a geologist, you're typically on the front line. You're the one meeting with the communities. You're the one meeting with the farmers. We know that Mining Charter 3 requires a local community participation. So when you engaging with the community, keep this in mind. Don't forget your mining right application triggers detailed EIAs. So this is a lot of detail, and every decision has an economic impact on the project viability. So someone, if not yourself, should be running a high-level financial model, and this financial model will grow as your project advances. So with that in mind, let's just get into some high-level project management concepts. So typically, a project management has a specific scope, a product, which needs a sufficient level of definition for each stage of the mining cycle. So what are our results? We've got a schedule, a timeline in which to execute on this. So at a high level, we've got 7 years to convert our prospecting rights into a mining right or decide yay or nay. And then what resources drive this? Not mineral resources, but project resources, people, funds, for example, equipment, for example, drill rigs, lab allocation, specialists, permits, etc. So start thinking about these three major aspects of a project. So typical project life cycle consists of project initiation, planning, project execution, and project closure. So project initiation, we need a clear project definition. So I'm encouraging us all to think about defining a project at each stage and what are the clear outcomes of the project. And one of the clear outcomes of the project must be a project execution plan going forward. In other words, what are we going to do going next? Project planning, so detailed planning, how to execute the project. We move into project execution and then project closure. So 4 major steps to the project. So if we look at project initiation, we need to generate, evaluate, and frame the business need for the project. And we agree with our team and management to prepare a detailed project plan, and the outputs of this project plan must be rough estimates of budget, resources required, tasks to be performed, schedule, and approval to proceed. So what does this look like? Well, here's an example. It's a very basic Gantt chart done in Excel. Basically, project, the steps taken to execute this, and this project's divided into 3 projects. Project setup and ground acquisition, and at the end of the project, we've got a clear milestone of target generation and a project review decision to proceed. Phase 2, physical exploration, draw target definition. We've got a timeline, we've got a milestone there in red, and we've got sub-steps of that. And what's also associated with this is a budget. And in phase 3, phase 3, we're actually going to diamond drilling, and hopefully we have a intersection and then decision to proceed to the next stage of the project. Second stage of the project, planning. So this is detailed planning. So we need a detailed plan specifying the time required. Typically, this is a really detailed Gantt chart, the desired results, the work required, detailed costing and budgeting, and resources required. So this all leads to a project execution plan and associated schedule. So what does this detailed project execution plan and associated schedule look like? I'll say it's a bit messy. It didn't copy and paste too well out of Microsoft Project, but you've got a project start date, you've got planning, scoping study, geophysical interpretation, metallurgical test work, milestones, and each of these has a very detailed budget going through. And this was I think it was about a 200 line item feasibility project plan with subdivisions on drilling. I've got an indicated drilling, 5 rigs, 15 holes, measured drilling. And you can see on this, I've got total costing of this, timeline going forward, and some tasks are dependent on other tasks. And we've really started to think about all the different aspects of this, down to core yard workers, laborers, consulting mine engineers, community costs for community liaisons, vehicles, rentals, on-site accommodation, legal verification, etc., etc. So we really started to think about a detailed project and timeline. And what's always useful is to cash flow this. So you know when the you now know when the particular activity is going to occur and over how long and how much it's going to cost. So cash flow it all. We don't need to drill down into numbers at all, but just an example of a cash flow budget. So you've got your budget line items on the left here. These will be months going forward. You've got project milestones within your budget, and these may relate to financial drawdowns. There'll be a total at the end of each phase. So this red line is the end of this phase. In other words, a project milestone. There's another project milestone. So you don't go to your board and ask for all this cash up front. You ask for a small amount, and if successful, you then draw down the next phase of cash. And at the end of this milestone, you need to define with more detail what this next phase looks like. In this example, it's a pre-feasibility study, including drilling, and all those items we discussed earlier. So you draw down on this, and then you can adjust your budget slightly and move forward. And this approach also allows you to reduce the amount of contingency required, because you have more confidence going into the next phase, so you can reduce the contingency in your budget. So project execution, a key point of this really is now monitoring and control. You've got your team in place to do this. You guys aren't out there doing the drilling yourself. You've got drillers, but you need to monitor the drillers. So you get the drillers on site. You put in the support systems. Is there diesel available for them? Is there water? Are there core trays, etc.? Is there a core yard? In this case, it's a feasibility study. You have a steering committee, client feedback, decision registers, etc. Monitoring, controlling performance, monitor your cost, monitor your schedule, project results, project progress reports, and other communications. It's a very simple chart just showing what your actual revenue and what your planned revenue and then your forecast revenue. So you can see this budget in particular, they're running ahead of schedule and ahead of budget. So there's obviously a problem here. And so by monitoring this now, what can you change to bring this back on track? Final stage is project closure. So typically I finish the projects on time and on budget. Right, next project you get less time and less money. It sounds like our municipalities. So key aspects of project closure is assessing the project results, obtaining approvals to proceed to the next stage, closing your financial accounts and any reconciliations, final accepted and approved project results. For example, sign off on your geological model, sign off on your production profile, sign off on your mine design criteria, sign off on your assays, sign off on your metallurgical test work. Finally, accepted and approved forward working plan, guys. This is so key. What is our plan going into the next stage of the project? And also applying lessons learned from previous projects to similar efforts, to similar projects for the future. Don't be afraid of front-end loading the projects. This is always a tough one to get past management, and we're not sure whether the project will succeed or not. But a lot of project managers will argue that by front-end loading the project, front-end loading is the development of a detailed understanding of the project so as to minimize the number of changes during the later phase of the project. So if you do a scoping study, you can do a really cheap desktop study, or you can get in consultants and do a super expensive one. At the risk the project may not proceed, so you've lost money now, but if the project does succeed, typically these are the paths. You can have a project with good definition. A project that's well-defined and executed poorly will still end up better than a project that is poorly defined, that is executed well. So there's your ultimate value. What this chart doesn't show, however, is if you've front-end loaded your project and there's a no-go stage at this, you have of course lost time and cash and resources ahead of this. So this chart does assume that the project will execute through all stages. Key aspects of project management as well is risk identification, and I think we all subconsciously do this. So risk identification and mitigation takes place at all phases throughout the project. If this is managed well, then the risks profile should reduce as the project progresses through the life cycle. As these risk mitigation activities are fundamental part of the study phases. So proper project planning helps mitigate these risks. So let's look at some real examples. So if you're drilling in the bushveld, what are some risks? Well, off the top of my head, there's safety risks with driving at night, etc. There's community risks, community protests. There's community might be kicking you off there in a manner want you there. There's mining risks, it's deep underground. There's market risks with PGEs. There's capital risks, capital inflation. There's water risks, electricity risks. So by identifying these risks early in your project, you can start to mitigate these by during the scoping stage. Take another example in the Waterberg coal field. There's obviously market risk, there's logistics risks, there's water, lack of availability of water, funding risks, social risks, etc. Coal bed methane projects never quite took off in South Africa. There's the perception of fracking. There's a market, who do you sell your gas to, etc. There's regulations. So these are all sort of the project risks we need to think about. So I think we were well on time. Okay. So if we look at a real world study with this is the example of a platinum project with inadequate drilling. In other words, poor front-end loading led to not enough exploration drilling, led to incorrect definition of a resource used for pre-feasibility study. So for example, in September 2011, the pre-feasibility resource, you can see, went up to 700 meters, and that was the extent of your resource. And the engineers went and did a design on this and executed a whole pre-feasibility study. When we moved, the mine design would have chased the shallow bits of the mine first along the whole strike extent. When we did this bit, was sitting in the inferred resource. When we moved this into an indicated resource by doing infill drilling, the resource, for whatever reason, wasn't here. So we did get the resource a bit shallower, but you can see we lost a whole chunk of the resource. This had a massive impact on the feasibility study and the amount of engineering work that was required. So you can see that by doing inadequate drilling, we had to go back at a great cost, redo engineering studies. So there's definitely, this talks to the benefits of front-end loading your project. How do you, so motivate for your budget to to do adequate drilling, to define your resource, be confident on your resource, on the whole extent of your resource before taking it into feasibility study. Don't push your competent person too hard to move exploration results into inferred. This may come back to bite you, as example did here. So, so we're running a bit ahead of schedule here, but how to be a better project manager. So I really enjoyed this Far Side cartoon. Suddenly, a heated exchange took place between the king and the moat contractor. Clearly, the moat contractor is digging the moat inside the castle. Whose fault is this? And why did this happen? Well, this is obviously the result of a inadequate and poorly defined project definition. So someone didn't clearly define what was to be done when they gave the scope to the moat contractor. And this so frequently happens. Guys, if you front-end load your project by clearly defining the scope for your drillers, often the drillers are risk averse. And if you cannot clearly define your project, they're going to cost that risk into their rate per meter or the overall costing. So if you can, with confidence, detail to the driller exactly what he's going to have to drill, how many meters, how much overburden, how much casing, how many deflections, expected core recovery, etc. That allows the driller to mitigate his risk because you've got sufficient detail. And what that'll mean for you is ultimately cheaper drill rates. So the more planning you can do, the more information you have up ahead, the easier it is to execute your project. So just some sort of high level, how to be a better project manager. I think be a why person. Ask lots of questions. Why is it this? Why is it that? You know, don't limit yourself to a typical scope as a geologist. We deliver the resource and sign off. No, what are the impacts of the reef thickness? What are the impacts of the amount of alteration in our reef? And think about the impacts of all the geology. Remember that our resource drives the rest of the process going forward. So as frontline guys on the ground, we need to think about what we can do to convert that resource and extract as much information of the resource to help better understand our modifying factors going forward. Be a can-do person. Yes, let's try, do as much as we can on the ground, get as much information as possible out of the drilling and whatever information we have. Think about the big picture. How does our drilling plan relate into our overall feasibility and project plan, taken right through to mining and ultimately taken through to closure? And when you're drilling, think about water losses, water gains, etc. Start to get an understanding of the hydrogeology, and think about the geology, as this is going to have impacts on the tailings dam placement. This is going to impact on water management, mine water balances, etc., etc. Think in detail, and again, this goes to our point of front-end loading. Don't be afraid to drill down into detail on all aspects, and ask the drillers, ask your core loggers, etc. Really details about what they're doing, and manage upwards and downwards. Ask your management for more detail about what they need and how can you assist there. Assume cautiously. This one goes without saying. Be very careful of just making assumptions. In that previous example, we just assumed the reef was there, so we assumed the reef would be there, and that really came back to bite us. So assume cautiously. A massive part of project management is people management. View people as allies, not adversaries. You need a team, and this relates to point 10. You're going to be leading people. we're all, as you advance your career, you're going to move from, not sure how many juniors in here, move from junior geologist, exploration geologist, and into senior geologists, and hopefully and maybe progress your career more. And so you're going to always have teams below you and with you. So work with your team, view them as allies. I didn't know what was the important part of the sentence to highlight, so I highlighted the whole thing. Say what you mean and mean what you say. This is always so important. Guys, get your point across clearly. Think before you say something and articulate what you mean. Don't leave anything to any ambiguous statements, etc. And say what you mean. If you don't mean it, don't say it. Respect other people. That goes without saying. Acknowledge good performance. Let's get your team to work together and acknowledge members of your team. Raise them up. And lastly, obviously be a manager, and very importantly, be a leader. So I think that's the end of my presentation. Sorry, we're a little bit ahead of schedule there. Can I hand over to Sifiso for questions?
Sure. So thanks again, Richard, for a well-illustrated presentation. Geez, I wish I had learned some of those things when I started out, and and thanks for putting all your project management experience and all the lessons learned into that. So no, that was great to set the scene as well for the day. So much appreciated for that. We will then allow some time for questions. We have a bit of time. So thanks, Richard, for keeping time and giving us a bit more time. So in order to do that, you can go click on the participants pane and then find the raise hand function. If you can't find your hand, you can unmute yourself. Then I will give you an opportunity to ask your question. So the first question was from KB on the chat, Richard, around at what phase or stage do you consider hydrogeology factors, because sometimes they are overlooked. So I don't know if you want to just go back to that slide on the feasibility study stages, because there's a whole thing. Is it a conceptual stage, scoping, or at what stage do you think you should start considering that?
Yeah, so we look at this slide, or I think, yeah, let's look at this slide over here.
Perfect. Yeah.
Yeah, that's a tricky one, and the hydrogeology is expensive. But let me just say that you need to have the hydrogeology almost work backwards. But you need to have, there's some things you need for the hydrogeologies is at the very least a geological model, and as well as an understanding of a rough understanding of where your mining is going to be and impact on the hydrogeology, as well as where your tailings are going to be in your waste dump. Those are probably the three aspects that ultimately affect your hydrogeology the most. So really you want that before you go into your pre-feed. It's a tricky one because you probably you haven't selected one option going forward at the end of your scoping study. So you would need it during a pre-feasibility study and factor it into your drilling. And you would do it at the tail end of your drilling, assuming it's an underground mine. But while you've got your drawings on site, you typically need to do packet testing, or in fact, you can get a percussion rig on site. So you would do it somewhere along the line of a pre-feasibility study stage. That's the high-level answer. Because you would need to know more or less where your mine is going to be, more or less where your tailings dam is going to be, and you also need an input into your EIA, so you can't leave it to this stage. Feasibility study is too late, so you need to do some detailed hydrogeology work at the end of or in the middle to the end of a pre-feasibility study.
Thanks, Richard. KB, happy with that, or you'd like to shed some light? KB, I've also come across in the past as well. He was also a client like Richard, but from your project management, any thoughts? Are you happy with that?
Yeah, thanks, Fiso. Thanks, Richard. I think hydrogeology should be considered at like as you consider geotech, because hydrogeology, let's say for open pit, it affects the slope stability as much as even underground. It affects the ground stability as well. So they need to be considered at the same time, at the same magnitude. The other thing, hydrogeology affects your plant performance as well, because depending on where you are, the water will determine the productivity at the plant as well. So those shouldn't be left at a very late stage. As soon as you discover your target, consider your hydrogeology, your geotech, and yeah, all those things. Because if you leave it until too late, you might be having a very good resource, but you can't mine it. Thank you.
Agreed. It's a great point, KB. So, I mean, effectively what you're saying is let's front end, bring that forward and try front end load of projects. And I think you're right. It will save time and effort later, because just hearing you speak, I think bringing in a pre-fee stage might be a little bit too late to get in your EIA, etc.
All right. Go for it.
No, I said the risk, of course, is that you do the hydrogeologic study in the wrong place. Your mine design changes at a pre-feasibility stage. So if you've done a whole lot of work on detailed hydrogeological studies at a scoping phase or inferred phase, I guess it depends on the how defined your model is. Thanks, Visual.
Great stuff. Thank you. Thanks, gents. I'll just go down now the hands that are up. So the first one is Ines. What is your question? Please unmute yourself and shoot.
Hi, Rich. Thanks for the presentation. Can you hear me?
Okay, yes.
So when I just started working with you guys, you sent me to Rwanda for the cassiterite coltan exploration, and maybe you can just, I remember nothing was going according to plan. And I gave you a call in the middle of the first week just saying, Richard, nothing is working. And you just had one sentence for me. You said, Ines, just remember, things can always get worse. And maybe you can just elaborate on, for the rest of the guys here, why you said that, especially when things aren't going according to your plan.
Yeah, that's true. People often think the statement's thrown around that things can't get any worse. That's probably one of the worst things to say, is that when things can't get any worse, actually that's typically when they do get worse, because bad decisions are made, you're panicking, etc. So when things aren't going to plan, sometimes a good idea is just to stop, sit down and just think about things for a little while and just reassess the situation. Because Ennis is right, when things can't get worse, yes, they can. And they typically do get worse because you're making poor decisions under stress. So just stop, evaluate the situation, take stock, and start to make proper decisions in a calm, collected state.
Good stuff. Thanks. Christo, you've got 2 comments or questions on the chat. Do you want to just unmute yourself so you ask them all at once, if you don't mind? Are you able to unmute yourself and ask the questions you have on the chat there, Christo? Christo Low?
Hello?
Yes, we can hear you. Yes, we can.
Can you just rephrase your question? I can't hear you clearly. So I've been just looking at the presentations and looking at some of the comments and trying to figure out what the speaker is talking about. But it looks quite clear. That's how I also would like to ask if the presentation can be made available again to me for me to review it.
Yes, you were a bit inaudible there, Christo, but I got your second one. Yes, where we do have permissions from the speakers, we will share the recordings. So with the audio and the video. So we will share that. What I was referring to was the questions and. Okay, go ahead.
Was there a specific question made up to me?
Oh, yeah, your audio.
Sorry.
Yeah, your audio is not too good. Okay, I see why you posted on the chat. Richard, do you see the questions? There's the one about PASA and the impact of CBM's gas extraction on groundwater resources. But I think that's
no, sorry, just remind me how to get to the questions again.
Click on the chat icon at the bottom there.
Sorry, I've just
okay, let me read it out while you're getting that. I noticed PASA sometimes disregards impact of CBM's conventional and conventional gas extraction on groundwater resources. Remember, DWS and DEA and other related institutions consider surface water and groundwater and even ocean as a vital resource, no matter what the natural quality of that water resource, because inevitably it can be used in one form or another. According to my knowledge, the geohydrology must form part of the crux of any geological commodity, especially in South Africa. So it needs to run concurrently with any project that runs geological investigations and management thereof. So I guess it was just affirming or answering some of the earlier questions about geohydrology. Yeah. All right.
I agree with that. And that's almost ties into our understanding of the legal and regulatory framework. And under CBM now, I had it, I think, as a risk is a regulatory and these are really, really tricky issues to deal with. And you've got multiple regulatory authorities licensing the same thing. So I completely agree with the statement, yeah.
All right, and I think other people on the chat also concur. Michelle Lowe's comment as well about this, the phase and how early during the project it should come, and Katutselo as well. So let me just go back. We still have a bit of time, a few more minutes. Back to the guys who have their hands up. Marius, have you got a question? Unmute yourself.
Hi, Richard. Thanks for the talk. I don't know. Maybe Graham Duncan will touch on this a little bit later. My question is, would you say there's any significant difference in structuring the flow of your project management in African countries with a little bit higher jurisdiction? Perhaps front-end loading your project more, or changes in cash flow. Can you maybe give some insight on or tips for project management in, for example, some African countries?
Sure. Yeah. Hi, Morris. Great point. I'm probably not the best person to answer this question. My experience is mostly in South Africa, but the obvious answer is, the higher the risk regime, the more front-end loading the projects you need to do. And that's then address. So think about, well, what are the risks? I think your project flow would probably just really would have to revert to more front-end loading. I don't know if anyone else wants to comment on that.
Is Graham on? Oh, okay. Please go ahead.
Sorry. Hi, Richard. It's Guy. My question was exactly to address that about the front-end loading. A lot of times people don't look after their samples once they've drilled them. Further on down the line, you may want to do another metallurgical study, or you might find that geological logging initially was not up to standard and you need to revisit the core or the drill chips. And if they weren't stored properly and you haven't put in the budget to store your samples properly, you can lose out a lot. And that, I think, is also a real risk. But it obviously incurs a lot of cost up front.
Yeah, it's a great point, Guy, and it's always tough because you want to look at these projects and sort of at minimum cost get in and out, and test the viability. So there's often a lot of resistance, and perhaps rightly so, from shareholders, from funders, etc., to front end load the project because it's just additional costs on, and it's made even trickier. I mean, as we all know, exploration projects, whatever the statistics are, 1 in 100 or 1 in 1,000 are likely to succeed. So why would you spend extra money up front if the project's unlikely to succeed on an exploration side. So this is the trade-off between front-end loaded projects in a perfect world. We'd all run on blue chip company budgets, but we don't. So it's often easy to sit here in forums and say let's front-end load the project, but when it comes down to rands and cents or dollars, you want to make every exploration dollar go into the ground and improve your chances of discovery. So you're not necessarily always incentivized to front-end load a project.
Yeah.
But again, I think it's analysis for risk.
All right, great. Thanks, gents. And yeah, maybe Graham later on, just in terms of the remote side of things, can maybe address those as well. Colin, you had your hand up. I assume it was also on the hydrogeo side. Go for it.
Hi, Sifiso. Thanks. Thanks, Richard. It's good to see you again. Thanks for a great talk. It was very, very interesting for a non-geologist. I just want to make two quick comments. The first one, I think, is that a lot of the hydro work can be done during the exploration phase. It means getting contractors to understand what they need to do. Sometimes that's not so easy, but I think it can be done. I think it's been done in a number of places with quite a good deal of success. The second point I'd make is that you touched on it, and I mean it's central to the whole project management. Is that your drilling is going to be a very important part of the project that you're involved in, that you're managing, and the beginning and the end of your ability to manage that project is the tender document, the contract. And I've been involved in many cases where the contract stinks. It's terrible. The tender document was shockingly badly put together. They didn't identify risk. It was terrible, and it becomes a nightmare for the project manager. So I would say that really has to be carefully managed right up at the front of the project. But thanks again, Richard, for a great talk.
That's a great point, Colin, and hopefully someone will delve into more details, maybe yourself later on that. I mean, there's just so many important aspects. So I'll drop off there.
Great. Thanks, Colin. Thank you, young man. And then speaking of another young man, Thomas, our Vice President, please shoot your question.
Good morning, Richard, and thank you for the presentation. And good morning to everybody. Richard, there's a slide that you showed the budget where the expenses are running ahead of the budget. I just wanted to know, wouldn't that be the case whereby you are running ahead of your, where you are running ahead of the schedule, where you will have that sort of a crap?
That's a great point, Thomas. And yes, that could be the scenario. But you've now raised an issue. It's highlighted an issue by monitoring your project execution. You've picked this up as an issue, and it may be a positive, it may be a negative issue. Are you running ahead of budget because your project's running ahead of schedule, or so you need to at least it's highlighted an issue, and you now need to delve, get to the bottom of that.
Thanks.
All right, thanks. And then we'll just take the last two. Carlo, sorry, you've had your hand up for a while.
Okay, good morning, Richard and guys. Thanks very much for that presentation. Richard, I just want to know from you, quick one, in terms of South Africa, a prospecting right application, and then also it seems like water issues could be an issue there. Do you have some experience on that? All the issues involved with just applying right at the start for prospecting right application? Thank you.
Colin, no, I haven't done a prospecting right application for a couple of years now. And I know that the legislative regime has changed. We're familiar with mining right applications, but I don't know. And maybe someone else on this forum is more suited to answer a question. And I'd be very interested to hear the answer too, to be honest.
All right, there was another comment from Yolandi. Sorry, continue.
Apologies for that. I work directly with water use licenses. I'm actually doing groundwater specialist inputs on water use licenses and integrated water resource management. So I have like a fair idea on what is needed for when it comes to authorization and licensing. I have like a fair idea what the different institutions need. Maybe
Crystal,
environmental affairs, maybe DMR, and water and
sorry,
sanitation.
Crystal.
Yes, you may.
Yeah, you are inaudible. What we'll do during tea time, if Richard and some of the guys are available, we can carry on the subject. But yeah, your audio, you are inaudible, as I mentioned. So hopefully we will sort that out just before tea time.
Okay, it's fine.
Can
I'll
we
keep
leave it
on.
to them?
I'll raise comments.
I'll
type
give.
out.
Okay. Yeah. Sorry, Mark, we have to get back on. So please, if you can just hold on to your question till tea time if you can. Alternatively, you can post it on the chat in the meantime, and then we'll hopefully address just to get back to schedule. Just a reminder, yeah, thank you. Just a reminder, thank you again, Richard, much appreciated. Just a reminder, everyone, please, for those who joined late, please rename yourself so that we don't mistaken you for a Zoom bomber. So to do that, go and click on participants, go next to your own name, click more, and then rename yourself so that we can identify you and confirm attendance. And so you can get presentations and that sort of thing. So there's a who are we, why 9? So we need to know who are we. So please rename yourself. And thanks for those who have maintained the housekeeping. So thanks again, Richard. On to our next talk. Our next speaker is Azwi, who also crossed paths with more than 10 years ago. He was working for an opposing consulting company at the time in Limpopo when we were doing chrome and PG exploration. So he's got a lot of experience in terms of stakeholder engagement. And today he'll be talking on stakeholder engagement for geological exploration activities. So go ahead, Azwi Mfelebongwe. Thank you.
Good morning, everyone. My topic is a very simple one, but it's one of the greatest challenge for mining industry. Just to give you a background of when did I start to have an interest in community issues. Some years back, we were driving to work and we sort of survived an attack by the community who were against the operation of the mine because they had some grievances. And that's when from that time I started to have an interest in the studies of why would community oppose mining industries? Because
sorry, Azwi, sorry, my apologies. Your audio keeps disappearing, so I'm not sure whether it's the distance or the mic. Can you maybe just try and adjust? Oh, and now we can see your video. Continue.
Okay, thank you.
Okay, that's better.
Am I audible now?
Yes, that's better. Go for it. Thank you.
Okay, thank you very much. I was just giving you a background that some years back, as a graduate geologist, on our way driving to work, we sort of survived an attack by the community who were striking against the mining companies. And, you know, as I grew up, I always view the mining industry as a tool for the development of the communities. And that's when I started to develop an interest as to why would community be against the mining industry, because the mining industry is a source of employment of opportunities for people. So like I said, my topic is a very simple one. I'm going to speak about the rural community and other stakeholder engagement for geological exploration. Is just 10% of the work that I have done while I was doing my dissertation in mining industry, corporate social responsibility projects. We are all aware that we are living in a time where communities around the world are always against the mining industry. And in most of the time, this confrontation becomes very terrible in a way that sometimes we can have people who get killed. Recently this morning, I was reading an article in the Mining Weekly where I read about some confrontation that happened at one of Exaro mining operation, where one of the community members was shot dead when they sort of entered the mine to put forward their grievances. So this just tells us the importance of stakeholder engagement in the mining industry, and also the importance of taking along the community with you in every step that you take along the way. In my introduction, we all aware that developing and operating mine require many years of work. We sort of move from exploration where we discover our deposit. And when we have discovered our deposit, we move to feasibility and planning. And this is the stage where a decision of economic feasibility of the project is taken. And it's a stage where the decision whether mining will take place or not will be taken. And then we move to operation where mining will take place. And then lastly, the decommissioning, where we need to return the land to the original state. In reality, most of the time, mining companies would prefer to engage with the communities, starting from the feasibility studies and planning. And we sort of ignore community engagement during exploration phase. And exploration phase, I want to argue in this presentation that the exploration phase is one of the critical stages that we can use to start engaging with the communities and start to understand the community, start to understand all the stakeholders that will be working with them should the project become successful. So earning a social license is very critical to project planning and mining greatest challenge today. A social license is a continual acceptance by the different stakeholders, especially the communities where the exploration is taking place. The community and other stakeholders engagement is increasing in value. In most of the cases, if we tend to ignore the community and other stakeholders, we have got cases where communities have stopped exploration projects because there was not proper engagement that has taken place. And therefore, early engagement can really help to reduce community protests. It can really help to be at peace with all stakeholders, especially the communities in the surrounding areas. And the community engagement can also inform decision, the project decision, because if we make decisions also not knowing what is in the interest of the community, it can be dangerous at the end of the day. It can also reduce business risk. We have got cases where communities, because of some of misunderstanding that the communities can have, they can even ban a drill rig and company vehicles because they sort of not understand what is happening in the project that is being undertaken in their village. And therefore, in South Africa, we have got MP RDA of 2000, especially section 12 and 16, which really put a lot of measures which is used to protect the interest of communities and other stakeholders that are involved. Just to go through something that Richard have already went through, we've got different activities that happen under geological exploration. We have got reconnaissance, where we are just doing a regional evaluation. And in this activity here, usually you will not be in contact with the community because you can do this as a form of desktop studies. But when you move to prospecting, because you will also need to get a prospecting right, that's where you need to start to interact with the communities. And communities would like to know how will they benefit from the exploration that you are undertaking. And then that will be followed by general exploration, which will be done, and the successful results from the general exploration can lead to a detailed exploration. What is the purpose of this presentation that I want to make today is we are all aware that the exploration and mining projects are rapidly increasing in rural communities. And exploration phase is the first exposure that the community have with the mining sector or mining companies or exploration companies because of the activities of the geologists who will be working in the area. And the arrival of the exploration drill rigs in community usually cause a lot of misunderstanding. I once had a discussion in my household survey that I was doing in one of the villages, where one of the community members believed that the mining have already started mining long time ago with their small machines. It's just a misunderstanding because usually when the drill rig arrive at the community, they assume that this is the beginning of mining operations. Therefore, mining or exploration companies need to do a lot of awareness, a lot of explanation to the communities to understand what goes into the exploration project. Because a poorly managed relation can lead to a conflict. And this conflict can also escalate to the other stages of the mining or mining cycle. So there's a need to manage a conflict from the beginning. And I believe if we really need to manage the conflict that can arise in the mining industry, the conflict that can even come when the mining industry or the mining start with the operation, is when we start with the engagement with the community from the exploration phase. These are the questions that I would like us to answer by the end of this presentation. Is it possible to start with stakeholder engagement during exploration project or exploration stage? And who are the stakeholders that we need to engage as a geologist or as a company? And why do we need stakeholder engagement in exploration project? Why in exploration and not in the construction phase? And how to develop and maintain a sound relation with the stakeholders and geologists' role in the stakeholder engagement. The engagement from the beginning, is it possible? Exploration project comes with a lot of uncertainties. And according to Allen and Eggett, he said between 500 and 1,000 grassroots exploration projects will result in 100 targets, and 10 of which can qualify as a development project, and one will become a producing mine. So in other words, not all exploration projects will lead to a mine development. Because of this, there is a fear in the mining industry that if we engage early with the community, it can raise expectation which will be unlikely fulfilled should projects prove not to be economical. However, early engagement is necessary not only when we are sure of what we'll be getting at the end of the exploration, but we can start with the early engagement and we can strengthen that engagement once the prospective deposit has been identified and the consideration is being given to mine. The other reason that the mining companies will always give will be the exploration companies depend on equity markets. In other words, in most of the cases, especially if it's not a well-established company that are already mining somewhere else, they might not have a lot of resources to start with the engagement process, because in many cases, communities will start to make a lot of demands because they believe the land is theirs. So it's a challenge for many companies because they don't have any resources or money to sort of start some of the projects that can appease the communities and other stakeholders in that area. Who are the stakeholders that are so important that we need to consult during the exploration phase? We have got the host communities. In South Africa, if you are doing a project, especially the mining project, you are expected that you need to consult with the host communities. These are the communities who are mostly affected by the project or exploration project that you will be undertaking. They are the people who have got a lot of expectations from the project. And they are also people who can be affected if the mine is to be opened in their area, because the social life will also be affected. We also have landowners, and in most of the cases, we will be dealing with the traditional leaders, who in most of the cases, if you want to work, you need to make consultation with them, you need to bring them along and make sure that they understand the process, the stages of your project. The traditional authority, like I've mentioned, for example, in the studies that I've been undertaking in the Northwest Province, most of the villages, they fall under tribal councils. We have got Wakhatla tribal councils, we have got Wakung tribal councils. Those are the councils that are responsible for whatever is happening in their land. So it's also very much important that you keep in touch with them and they are properly informed of the project stages and everything that will be undertaken. Land claimants and lawful occupier. It can happen sometimes that you can be doing an exploration in a farm that is owned by Mr. John, and that land might be under claimants, or maybe there's other communities who are really claiming that that land belongs to them. So in that case, you need to engage the owner of the title deed together with the claimants of the land. In most of the cases, the government will always be pro-mining, they always support the mining. So we also need to make sure that we keep in touch with all departments in the government, Department of Land Affairs. If your project will affect the agriculture, you need to keep in touch with the Department of Agriculture, and also not to forget the local municipality, who will also give you the list of people that you will need to keep in touch with during the process of your exploration. The stakeholder engagement process. This is what one will need to do, because it is the participation of members and the community and stakeholders in assessing, planning, implementation, and evaluating the solution to the problem that affect them. There's a saying that says, nothing for us without us, which simply says, everything that concerns the communities, we cannot do them without involving them. The first stage in the process is we need to do a stakeholder analysis and engagement planning, where we identify a range of stakeholders and identify all affected communities and how they will be affected by the project that will be undertaken. For example, if we will be doing exploration, sometimes we'll be drilling in a village, and we might be at some point forced to drill in somebody's yard. There are times wherein we might be forced to drill in somebody's farm. So we need to do a stakeholder analysis and have an engagement with them and plan so that they will be able to know how will they be affected even before the project resumes. The disclosure of information is also very important. The communities and other stakeholders need to know the purpose the nature and the scale of the project that is being undertaken. And we also need to know the duration of the proposed project activities. If we're going to do the geological mapping in the area, we need to let the community know. If we're going to do the trenching in the area, we need the community to know, and also give them the time frame as to when will this activity be undertaken. Any risk to and potential impact on such communities need to be communicated. It should not come as a surprise. I remember of an accident that once happened in one of the communities where an exploration company was doing some trenching, and one of the cow fell in the trench, and it sort of caused a lot of problem in the community. So such things need to be communicated in time, and we also need to put measures in place that communities might not be affected. Their cows cannot fail on our trenches. Consultation, the stakeholder must be allowed to express their views. In many cases, mining companies are sort of not giving enough opportunity to the communities to air out their views, and also so that when we know what the fears that community have, then we can also know which mitigation measures we will be putting in place. Participation in a culturally and appropriate manner. As I've already mentioned, especially in the rural areas, most of the villages are under tribal councils. They are ruled by chiefs and kings. There are a lot of indigenous people who are involved, and they've got a lot of knowledge of what is happening in their village. They are the people who even know the areas that they consider a sacred place. One would not want to peg a borehole in a sacred place. So if you go and peg a borehole in a sacred place, that's when we will start to have a very bad relationship with the community from the start. And this conflict can escalate to the other stages. So it's very much important to not only engage with the people who sort of knowing what is happening, but we also need to engage with indigenous people, because they've got information that will be very useful for us as we undertake our project. Why is community and stakeholder engagement necessary? Engagement is important to inform project decision and also to reduce a risk. Exploration is a community-first exposure with the mining sector. When communities see the drill rigs in their community, it is the first exposure that they will have with the mining sector. And because of the activities of the geology in the area, they might be drilling in the area, they might be doing the mapping. So this is the first exposure that the community will have with the mining industry. And it presents an opportunity where an exploration company can build a relationship with the communities and other stakeholders. And it's very essential in earning a social license to operate, because without a social license to operate, you will not be able to proceed with the next stages of your project. And if we are managing the conflict from the beginning, right start when the exploration starts, we will be able to avoid this conflict to escalate to the other stages, because social conflict can really jeopardize the continuity and the performance of exploration projects. So we need to have an opportunity to prepare strategies and plans to address concerns and the interests of the stakeholders. And the right opportunity that we have, we can only do that during exploration and not wait until we are at the construction phase. Just to summarize what I've mentioned already, it is important that we identify our host and our affected communities. It might not only include the community where you are drilling, it might also include the community that are surrounding the community where you are based. We also need to develop a community profile. Some companies will go there and do some socio-economic studies, because once you develop a community profile, you will be able to know of the community needs. You will be able to know where, if you are to come and mine, what will be the risk that will be involved. We also need to conduct a risk assessment. One of the risk assessment that is very useful these days is to do a perception risk assessment, where you'll be trying to understand the subjective view of the communities about the project that is to take place, so that you'll be able to know how do they view the project and what do they really think they will benefit and what are their fears. The last one, you will need to identify and map all your stakeholders. This is where one need not to make any mistake and exclude some of the stakeholders, because we need to make sure that everyone is on board, because there are cases wherein you might exclude one, thinking it's not that important, find that that person has got a lot of influence in the community. I will give you an example where I was undertaking a project in one of the village, and I needed to do a household survey for my research. And I got one of the community structure. I met with them and I asked for permission, they allowed me. And during the process of doing household survey, we were approached by the other community leaders who were asking us who gave us permission. And when we mentioned, they told us that no, those people are no longer in charge, we are the one in charge. So in other words, what I'm trying to explain here is, sometimes when you are doing exploration project, you might find yourself in a situation where you have got two structures in the area that sort of have power, and once you only ask for permission from one, the other one might stop you from proceeding with the project. I just want to share you a case study that I did at Moses Kotane local municipality. This was a purposive sampling of two communities. The name of the communities is Lidach and Mushawe communities. These communities existed before the mining operations began. In other words, these communities have witnessed the execution of exploration project to mining because they were there. In the past, these communities have experienced a violent protest against mining companies in the area. And there were also some time wherein the mining operations were stopped because communities were not happy with how mining companies are handling their grievances. Let me start with the Lidach community. This is a very highly populated village with a population of more than 20,000. It falls under Bakubungwa Rateo Traditional Council. The economic activities in this area are mainly mining and eco-tourism. The eco-tourism include Sun City. This community, they host a mine that is called Bakubung, and also another mine that is called Maseve Platinum Mine. Those are the mines that are mining in the area. They started with operation between 2016 and 2017, and Bakubung Barateo Traditional Councils were allocated 33% of shares in the Bakubung Platinum Mine. These shares were at later stage sold so that they can be used to develop some communities. And there were a lot of politics around this issue, that the money that they got from the shares, no one could point out how the money was used in the community. The second community is a small village with a population of 2,000 plus or minus 2,750. It falls under Bakhataba Hafela Traditional Council. This is the first community that settled on the land that is currently occupied by Pilanesberg Platinum Mine. As you know, Moshabe is under Bakhataba Hafela Traditional Council, and they were granted 26% of ownership on behalf of 32 villages that falls under them. The communities in this village have witnessed the exploration taking place. They've witnessed all the stages until current stages of operation and mining. They believe the distribution of the benefits is skewed in favor of other villages. And they also wanted to negotiate directly with the mine because they believe they are not benefiting from the mine. The method and the techniques that we were using in this case study was, the research was anchored in a stakeholder engagement theory, which mainly say a project will only be successful if all stakeholders are involved. I have done and reviewed an academic literature related to exploration in the area. I went and read the mining company sustainability reports, which usually outline what the mining companies are doing for the communities where they are operating. I've done a household survey in Lidak and Moshabe just to get understanding of how do they view mining industry, and if they were consulted, what level of consultation was done during exploration phase. I've done the key informant interview with the community leaders and also municipality official. The last technique was just an observation and informal conversation. What did we ask the respondents? We asked the respondents about their past experience with the mineral exploration companies, now active mines, to understand, do they understand what geological exploration entails and what sort of relationship exploration companies have with communities and other stakeholders? And what benefit do they expect? This is the response that we got. There's a lack of awareness of what is geological exploration, and communities always confuse geological exploration with mining. This is where the problem comes. And because, like I've mentioned earlier, when communities see a drill rig coming to the village, to them, the company is already making money. In other words, the companies are not willing to engage early and invest time to build a relationship. Many companies are trying hard in the area. Sometimes they will do some focus group with the communities in the area, because communities need to know what exploration entails, and also they need to know the uncertainties of the exploration. They need to understand that exploration will not always translate to mining. And once they understand this, that's when they will be able to also tell others, and they will not be able to stop some of the projects prematurely, because the problem that we have these days is immediately when the drill rig arrives at the communities, communities will start putting demands on the table. Engagement is done with tribal councils and municipalities. Most of the respondents were concerned that in many cases, the exploration companies, instead of engaging directly with the communities, they are engaging with the tribal councils, and this information is not filtering down to the communities. And every time when we have got protests in the villages or communities, these are the people who are the ones who are venting their angers against the company, simply because there are some of the information that have been communicated with the tribal councils, simply because they are the ones who have got authority in the village. But unfortunately, some of the information are not filtering down to the communities, who are the ones who can really stop the project from continuing. Communities really want to engage with the exploration companies directly and not through the tribal councils or not through the municipalities. So as a recommendation, it is very much important that as much as we can engage with the tribal councils, as much as we can engage with the chiefs, as much as we can engage with the IDP managers at the municipalities, we also need to engage with the communities on the ground. And this can be done through focus group. This can be done by asking some slot in the community radio where you can explain to the communities how exploration project will be undertaken and what are the expectations, so that communities are brought in board and understand the basic knowledge of exploration and what it entails. Mineral resources are transferable, but you cannot transfer trust. In one of the area, communities sort of felt betrayed simply because another company came and did exploration. And in the process of doing exploration, they brought the community on board and they explained everything to the community. But the company decided to sell the project to the other company. And remember, the trust was vested in the previous company, and now the new company is taking over. It is sort of like the new company now will have to start from afresh because the trust is not there. So mineral resources can be transferred from one company to another, but it is very much difficult now to transfer trust from one to the other. The benefits accrued from the engagement in the area, we have noted that some companies in the area have done fairly well, especially the companies that are well established, because in the process when they were doing exploration, they had already started taking some of the students, giving them bursaries, taking them to varsities, taking them to colleges, so that they are preparing their future employees. They were doing this simply because they are already operating mines in the other area and they have got resources to do that. This is not something that a junior company or a small company can do. So it is only possible for a well-established mining companies. One of the good development that we have seen on the ground was some of the exploration companies, drilling companies, were sort of hiring locals in the area, especially as an assistant. And this really helped mining companies to get a social license to operate in the area, because they are seeing some of their community members working in the drill sites. But one of the challenges here is in one of the villages where communities wanted more of their people to be employed by the drilling contractors, and only to find that in their communities, they don't have people who have got experience in the drilling, And at the end of the day, they only had to hire assistants. Those are some of the complex issues that I believe some of the people who are working in the exploration project management might have encountered. What should be done to really make sure that we have a good relationship with the community when we do exploration? We need to start early engagement during exploration, and we need to start with an awareness in the community so that they know what exploration entails. Do not overpromise to acquire social license. Some of the protests that we see today are as a result of over-promising to the communities and over-promising some of the things that we will not be able to achieve. It is important to bring the communities on your side, but we need to avoid over-promising because communities, they don't easily forget. If you told them that we will create jobs for everyone, when the mines start operating, they expect everyone who's unemployed to be employed by the mine. Engage with openness and honesty. We need to be open with the community. We need to be honest. At some point, it is also important that we can also share a bit of the expenses that we are experiencing of exploration and also explain to them that this is just an exploration. This is what we are spending and we are not getting anything for now. We will only be getting return if the exploration becomes successful. Building a relationship with the communities is not always something that requires transaction. I think this is one of the mistakes that most of the time we sort of make because we think the only way to make a relationship with the community is when we give the money. And some of these exploration companies sometimes will end up sort of building a relation and doing some transaction to a small number of allies just to get a social license and to finish the project. And forgetting that at the end of the day, we still need to come back and continue with the project. And we cannot live in a time wherein it will be like you're bribing community leaders all the time. There's also a need to maintain a dialogue even in times of inactivity. You will go to a community and do an exploration. For example, you can go there and do a general exploration and start, if it's a junior company, start sourcing funds to go for a detailed exploration. It is still important that you keep in touch with the community so that they need to know at what stage the exploration is and when are you coming back to continue with the work that you have started. In my conclusion, I want to say the all technical criteria to move exploration project from discovery to exploration can be met, but without social acceptance, mining will always be disrupted continuously. We don't need to wait until construction phase to start with the engagement. We can start with the engagement during exploration stage. Get to know the community, get to know the leadership of the community, communicate with them, let's know their plight and how do they view us, what is their need, and build a good relationship with them. And use an exploration stage to create an effective engagement strategies that will not really have to cost us a lot in future. And we can start with small investment in the community to build trust. Like I said, some of the mining companies in the area where I was doing my studies, they've started with a small community investment in the communities where they funded some youth to go and do some artisan certificate, to go and study at universities. And by doing that, they are preparing their future employees. We need to avoid engaging with one stakeholder only. We need to avoid engaging with only tribal councils. We need to make sure that we also engage with everyone so that we don't really exclude some of the people who can also stop our project from continuing. It's very much important that we understand the politics of the area. We need to understand the politics of the village. Most of us who have worked in the Northwest Province, we are aware of the politics, especially in the tribal councils, where some of the communities want to secede from the tribal councils. They now want to negotiate straight with the mining companies. We need to understand these politics, but we don't need to get involved. Because once we get involved, once we start favoring who is right, who is wrong, that's when we're gonna get things wrong. And lastly, we need to be patient and willing to answer questions. Most of the time, communities will always have a lot of questions that they want to know about our exploration projects. So when they ask, we need to be willing to answer the question. We need to answer everything and make sure that they understand everything that we are doing. Thank you very much.
Thanks, Azimpelele, for that very informative talk. And as you put it, rapport with the various stakeholders is critical and important for any project. And speaking of your last point there, being patient and be willing to answer questions, we want to open the floor to questions. So as we previously did, go to participants and then click on the raise hand. If you can't find your hand, unmute yourself, then we'll give an opportunity. But I'll start it off. I'll give Mark a chance because he had been having his hand up since the first talk. And just Mark, if you can, I mean, you had that whole thing about sustainable mining, and then I think you're probably linking it to the also the social license to operate. So please go ahead.
Thank you so much for giving me this opportunity to express my thoughts. Very, very, very good presentation. I concur with a lot of what has been said on this presentation. And I think the one thing that I just wanted to outline is that given my little experience on the field, it's like coming to someone's yard and realizing that they have gold. You won't just, expect them to be welcoming if you just step right in and go and do your business and then walk out. After all, I think the approach in the manner in which we do things is very, very important. To realize first and foremost that we are human beings and we are dealing with other human beings. So if, for example, you come from South Africa and you go to Central Africa and you decide you want to do exploration there, know that the territories are different, the lifestyles is different, the culture is different, the approach will also be different. And that's where your patience comes in. And especially when you're dealing with people, they come from different backgrounds, different ways and approach of doing things. So it's very, very important. And I think that's why it's very important to have these things in exploration, is that once it's dealt with properly, that type of information can be easily led to the environmental team, who can then continue to do a follow-up on what has been laid. And a lot of times, as you've mentioned, is that the crack in the foundation comes when the exploration, maybe our inexperience in community engagement, do a very poor work. You see the whole house tumbling down. And again, I think when you're honest with people, even if they will not get much out of it, but if you're honest from the get-go, you may get a lot more support and direction. And it could even be a simple thing between a community member or someone that is a nobody, for lack of a better word, telling you, oh, we've always known that there's gold in that river, and then that could change, that small piece of detail can change a whole lot in your exploration project. In terms of giving it direction and a lead and so forth. So that's in that.
Thanks, Mark. Any comment, Azif, before I move on to the next question?
Thanks. I think what is important, like what he was mentioning, is the foundation is very much important. So if we can build a good foundation, it can really help us to sort of manage all other stages and will bring along the communities. Thanks a lot for your contribution. It's really helpful. Thank you.
Yeah, and I mean, just to add, I mean, like we've had chiefs who are some of the best prospectors and have the context of the area, and can find where there's things that for you as an exploration geologist would be difficult to find. And just in terms of territories as well, I mean, I've been to projects where they went down rigs. Like in the Northwest, I know about that cow incident as you was talking about in Limpopo. And just to add to Steph's comment about in Central Africa, I mean, in the DRC, we had to give gifts to the chief the whole time and to buy goodwill. So whether that was monetary or groceries. So it's important in the different territories and the approaches, as Mark put it. And yeah, the politics as well. Griff had a comment about the Game of Thrones as well to manage that. There was another question just in relation to the institutional stakeholders. I think that was from Christo. So about the various authorizations, permits, and rights needed. So the question is for the project manager and the custodians regulating the project manager. How does the project manager, whether geologist, hydrogeologist, ensure that all relevant institution mandates are met with respect to legislature, regulations, and laws? Anyone willing to give that a go? Azwi first.
Okay, you see, it's good that in well-established companies, big companies, they do have officers who really deal with that. For example, in big companies, we have got social performance officers who can really assist you in communicating with the community. So as a geologist, you will still be involved. But for a junior company, you will need to be an economic geologist and be a social geologist as well, and also make sure that you consult with the communities. In other words, you might also be involved from all stages of prospecting, application of prospecting rights, and also giving back the report to the DMR and all those sort of stuff. That's what the junior companies will do. But for bigger companies, they've got social performance officers, they've got legal people who can also be assisting you as a geology team.
Great, thank you. I'll go back to the hands up. KB, go for it.
Okay, thank you, Azwi. That's very important. Your presentation is really by the book. The tricky part that I've encountered over the years is that when you start exploration, you engage, you find the landowners. The problem that we have encountered is as soon as you get to stages where you do feasibility studies, you will find that there are those opportunists. Now you will find that the land that was owned by A is no longer owned by A, it's owned by Z, which is a tycoon somewhere, who have bought areas, land around the proposed mining areas. How do we deal with that?
It's a very tricky one, but I think it's also important that you need to do some research there, because sometimes you might think that maybe you really have a real owner of the land, and find that you just find somebody who have just hijacked the land. But in the area of Bahata, I think it's a very challenging one, because you will have community members who can even give you some of the history, tells you how their grandfathers have bought this land, but at the end of the day, they cannot really give you a permission to continue with your studies. So there are some of the cases where you need to try and please both parties, which is a bit difficult to do, especially if you know that both of them, they've got a power to stop your project. But I mean, it's sometimes we need to validate. We need to validate who really owns this land or who really need to be consulted. But I must confess, it's one of the challenging parts always when you are doing explorations.
Well, thank you. Mpho, you've got your hand up.
Yes, good morning. Thanks for the recognition. I just want to quickly maybe touch on the presentation that we had a look at just now. With regards to the stakeholder engagement, obviously my understanding and belief and from my previous training is that before you can actually have the actual stakeholders, you need to have a way for you to identify them, and you don't only identify stakeholders within the area of activity, for example, within the community, but your stakeholders could be as well, including whoever's funding the project and what is their interest and influence. And also, for example, the institutional stakeholders such as DMR will also come into play. So my question really is, from my understanding and my background training is that from the PMBOK, there are steps that are outlined to say, okay, this is what you need to do for you to be able to identify your stakeholders. And once you're able to identify your stakeholders, then you are able to prioritize them to say, okay, the highest priority will be given to this, and this is the form of engagement, so that then we make sure that we are all in par in terms of the project itself. So in this regard, do we have sort of like a list? I might have missed it in the presentation, but I just want to find out if ever maybe, do we have sort of like a list which states in terms of how do you go about identifying your stakeholders, and possibly from there, how do you then prioritize and make sure that the correct priority is given to the right stakeholders? Because in the event whereby you ignore one guy just because you thought, nah, he was not significant, and then he causes a upheaval, you can derail the whole project. So yeah, that's my question really. Thanks.
Thanks for your comment. I do agree with you that when we speak about the stakeholders, although we really need to concentrate on the most affected part, for example, the host communities, we sometimes have to include the labor sending areas. We might also have to include some of the people who previously been owning the land. I'll give an example, although I don't want to mention the mine name. There's a mine that is operating, and what happened is pre-1994, during apartheid period, the people who were staying there were moved from that area, and now they settled in another village very far away from the mine. And when the mine was being developed, of course, there was another community that developed around the mine, and they felt that now they are the ones who need to be consulted more than those ones who were taken out of the land. So what the mine has been dealing with is although those communities are very far away from the mine, they are the communities who used to own the land. They've lost a lot of things when they were moved out during apartheid period. So those are the communities that will be consulted first, because they were affected by the project, even though it was done during the apartheid. But what usually happened, but I saw there's a presentation that will be coming through for prospecting permits and everything. Because when you have applied for prospecting permits in a particular area, it might be covering farms, it might be covering the villages, it might be maybe covering some of the government properties. So you need to go and to the deeds, you might need to go to CIPRO and get the contacts or information for all those people who will be affected by your project. And of course, you also need to consider the adjacent communities. For example, if I am drilling in a farm and I got a right, I got permission to drill in a particular farm, and I'm not going to touch the other farm that are surrounding it. Those other farms that are surrounding the farm where I'm drilling will be affected. They've got animals, there will be a lot of noise, there will be a lot of things that happen. So I still need to consult them, even if I'm not going to be drilling on their farm. But who's going to be an important person to consult first? I'm going to consult the owner of the farm where I'm going to put my exploration camp there. But I will also need to sort of expand and also consult the surrounding farmers so that they can also get the permission, because sometimes when I drive to that farm, I will also pass through them. So their cows, probably they might come to the exploration site where I'm drilling. So I will need to know who is first to consult and sort of rate them going downward. But what I've seen from my experience is, in many cases, I know with farming communities, it's much easier to do that consultation. But with communities, I think if we can do anything with that communities, usually it's going to be very difficult. So in traditional communities, it's something that you need to ask. You need to go to the traditional councils, and traditional councils will take you down to the communities. So you need to communicate through traditional council and go into the communities, not only stop from traditional councils, because if you stop from traditional council, you might get okayed from traditional council, and communities that don't know what is happening, and then when you start your drilling rigs, then they can ban your drill rig. So it's one of the things that you need to write down in the list all the stakeholders involved, and also sort of rate them, who is important more than who.
All right, thanks. Yeah, the prioritization is critical. So thanks again, Azi, for that presentation. If you don't mind stopping sharing, and then as you referred, the person who knows a lot about prospecting and mining rights is our next speaker, Krishna. So can you stop the sharing? And then if Krishna, you can then start sharing after as we stops the sharing. There's that button on top there. Yeah, thank you. Krishna, welcome. Krishna, I know as well. We did the GDE adverts together while she was still at the DME at the time. I had no doing with the speakers on the program. It was all Natalie and Fiona. It's just because it's such a small industry that I've come across most actually of the speakers between today and tomorrow. Krishna will be talking today on the importance of land tenure for mining and prospecting projects. Go for it, Krishna.
Thank you, Sophie. So if you can maybe just say, do you hear me? Unfortunately, I don't use Zoom that often.
Loud and clear. Continue.
Okay, thank you. Yes, so thank you very much for this opportunity to share some information today with you. I maybe should just say that I'm not a lawyer, so if you've got very difficult lawyer questions, I'll try and assist you. But I've got a lot of experience. I was at the Department of Mineral Resources for about 22 years, and I'm currently in my current position for 8 years. So I've been dealing with prospecting and mining rights and also surface rights for some time. So I thought today in my presentation, I would like to share some experiences with you, and hopefully you can learn something from it. And then in terms of being a prospect, being involved in geology, as a geologist, I mean, you won't necessarily be involved in everything that I will share with you today, but for me it's important that you've got the background and that you know what is involved, and then if you need assistance, that you know who to contact and where to get assistance from where required. And then also, I think, you know, when people become managers, you know, it's important that you know the legal aspects and that you're aware of all of that. And then maybe for interest's sake, I also need to share with you, my manager is the group geologist for Royal Bafokeng Platinum. So you might also run into a situation where one day you're actually responsible for mining and prospecting rights. So by looking at the starting of the presentation, I think the first, the topic is to look at the importance of legal tenure, and maybe just to understand what does tenure mean. And in terms of this definition, it says it's a right, term, or mode of holding or occupying something of value for a period of time. And that is exactly what's happening when you apply for either a prospecting right or a mining right. you actually get something of value and you get it for a period of time. And we'll go into, I've got a table to show you of all the different rights, and then we can also look at that in more detail. So today, if I talk about tenure, we'll look at your right to either prospect or to mine. And then on the other hand, we'll look at your right to use the land. I think previously, and I actually agree with Ashwi, land use and occupants of lands has become more and more important nowadays. Previously, mineral right holders, or if you had a mine, you just went onto the property and you started with your business and you carried on without taking care of the people on the land. Nowadays, it has become more and more important. And if you look at the importance of legal tenure, obviously, if you don't have your legal tenure, you just can't continue with any project. You can't start with any prospecting. You can't continue with your prospecting, or if you've got a mining right, you might be in a position where you can't continue with your mining. So it's very important that you know what to do, when to do it, and to have your prospecting and your surface rights in place that you can continue with your mining. So if we look on your right to prospect or mine, so the main legislation applicable to that is obviously the MPRDA, which was referred to previously. Then you've got your National Environmental Management Act, and there's also related legislation with that goes with the MPRDA. Obviously your National Water Act, and then your Mine Health and Safety Act. And I often tell people, when you speak about the mine and they say they stopped the mine, everyone normally refers to the Mine Health and Safety Act to say that there's a Section 54, you've stopped now, you can't continue mining. But what's actually important is that the MPRDA is actually the legislation that gives you your right to mine or to prospect. And the MPRDA is the legislation that can actually cancel that right to mine or to prospect. So it's very important in that sense that you then comply with the MPRDA so that you can keep your right and your permits to continue with your activities. Then on the other hand, we look at your right to use the land. We look there at land ownership. So either you buy the land, you the landowner yourself, or if you doing your activities on other person's land, you need to enter into a lease with that person. And then we'll also quickly look at the Spatial Planning and Land Use Management Act and the requirements in terms of that act, and the municipal bylaws that is part of the Splumau Act. Before we then start going into more detail into the MPRDA, I thought it's just for interest's sake, we need to look at a bit of the history of the mineral industry in South Africa. There at the bottom is, I've just put in a document that I will share with you. It's a historical perspective on the economics of the ownership of mineral rights ownership. That was drawn up by two professors at Wits University, Professor Kaywood and Minute. And it just gives a bit of history on the minerals industry and how it evolved over time. And they actually say that it started in South Africa in 1652. And at that time, when you look at the mineral legislation and what was in place, it was actually referred to the Dutch Roman legislation. And then when you looked at land, at that point of time, it was the determination was that if you own the land, you also own the fruits of the land. So you own the land and you own the mineral rights and you own everything with the land. And then further on, it was then overlaid by some other legislation like the English, the British legislation. And then in that paper, if you read that paper, these two professors, they say it's a complex legal system. And I think if you start reading the paper, you'll understand the complexities that arose over time. And it then went into dual private and state-owned mineral right ownership. So you had cases where the state then said, although you the landowner, we own the minerals, and we will decide, and especially that was more applicable to precious metals, we will then decide who can mine that, and we will provide you with leases, and you will have to pay royalties to the state. And so this evolved over time, and it changed over time. And then you had this concept about you've got either a right to mine or to prospect versus a mineral right. And at some point of time, on the land, the mineral rights were severed from the land. So you had a separate mineral right holder of that land, and then you had an owner of the land. So it wasn't the case anymore as in the old Dutch regime where you had the mineral rights and the land. So you might have the land, somebody else had the mineral rights. That mineral rights were actually registered on title deeds, and then it was traded. So you could buy mineral rights if you're interested in a property and you want to continue with your mining there. There's also cases where the state then actually kept the mineral rights and they sold the land, and they talk about alienated state land. And then you also had to, if you want to mine on that specific land, you had to have an agreement and leases with the state to actually mine that, and then you had to pay royalties. So just before the MPRDA came into operation, we had the Minerals Act, and at that time it was then in a position where they actually changed the legislation, and it all went back to private owned mineral rights, where people then own the mineral rights, and then anyone who wants to mine on a specific area, you either have to own the mineral rights yourself, or you had to have an agreement with somebody else who owned the mineral rights that you can mine there. And so obviously what happened at that time is that a lot of the bigger companies, they started buying up mineral rights, and nowadays they call it hoarding minerals. So there were a lot of land and minerals kept by companies, but it was never mined. So it was just lying there. It was their assets, and it wasn't mined. So with the implementation of the MPRDA, it was implemented on the 1st of April 2004. So obviously before that there was a lot of negotiation, and because of this complex legal system, one can understand that it took some time before this act was actually implemented on the 1st of April 2004. There was one amendment on the 7th of June 2013, and then the second amendment was referred back to Parliament. And I'll talk a bit more now about the MPRDA and its principles. So if we look at the MPRDA, the principles, and then this is the objects of the MPRDA contained in Section 2 of the Act and the preamble. And then so the big shift from the Minerals Act to the MPRDA was in terms of this mineral right ownership. And then the MPRDA says that the mineral and the petroleum resources belong to the nation. So it's no longer privately owned mineral rights. It actually belongs to the nation, and it doesn't belong to the state. It belongs to all the people of South Africa. So the mineral wealth of South Africa belongs to the people. And the state is then only the custodian of that mineral resources. And if we look at the definition of custodian, we say, so they take care of it, they look after the mineral rights on behalf of the nation. And then also a function then as the status custodian is that they grant and they issue rights to prospect and to mine. So although nowadays sometimes we still talk about a mineral right, there is actually no more mineral rights. It is only now a right to mine or a right to prospect, and that you get from the state. You apply and you get that from the state. Then in terms of the MPRDA, another important aspect is your security of tenure, and I'll talk a lot about security of tenure going further in this presentation as well. For me, that is the backbone of the MPRDA. And then also in terms of if you look at the importance, if you don't have that security of tenure, you don't have your right. So everything goes back to the security of your tenure. Then also the MPRDA, in terms of its objects, it was to allow equitable access. So like I said, with the Minerals Act, there was a lot of hoarding of minerals. Now with the MPRDA, it's open. The minerals belong to anyone. So anyone can decide, look at an area and decide to apply for any mineral and any right that they are interested in. It's no longer, you don't need to have be an owner of a mineral right. So it opened up, it made it's equitable access. It expanded opportunity. It must expand opportunities for historically disadvantaged South Africa, women and the community, getting back to Ashwi's presentation. So we must expand to the community, give them also access to the minerals. And then it must also contribute to economic growth, sustainable development and employment. And then it must also look after the socio-economic development of the operating area. So that's the area in which you then get your prospecting and your mining rights. So that must be in a sense that it then also impacts on that surrounding community and that it has got a socio-economic impact on that community. Then if we go further and we look at the legal nature of the rights, and that is, and maybe before I go there, I just want to mention in terms of Section 4 of the Act, it also says any reasonable interpretation which is consistent with the objects of the Act must be preferred. So in any event where you read the Act, everything goes back to that objects of the Act, and everything must be consistent with the objects of the Act. Then looking at the legal nature of rights, a mining and a prospecting right is then a limited real right in terms of the minerals and the land. So what does that mean? It's a real right because like a property, you also register your prospecting and your mining right at the Mining, Mineral and Petroleum Registration Titles Office, so that it becomes a real right. It can't be taken away from you. It's registered, and it's limited in the sense that you are not like a landowner. You've got other rights. In this case, it's limited in terms of the minerals and the land on where you do your mining and your prospecting activities. And then it also gives you a right to enter the land and bring to the land any equipment, plant, and machinery. It gives to you a right to prospect or explore for your own account. So it is you determine how you're going to mine, how are you going to prospect, and if in any profits that arise from that is for your own account, so you get those profits. And it says they specifically have underlined that which right has been granted for the mineral. So if you look here at the bottom, I've just taken a view of the type of minerals. This is in the MPRDA regulations. So when you actually apply for a mining or a prospecting right, you have to identify which of these minerals do you apply for. Interesting enough, I've specifically included this because you'll see there at the third row, there's all minerals. So at one stage, when I was just started when I was at the DMR, there were some applications for all minerals, and it was actually granted until at some point of time they said, but if you want to apply for all minerals, then when you do a prospecting work program, you have to then indicate how are you going to prospect for all minerals, which is actually not practical. And also when you mine, how, if you have to now include like 50, 60, 80 minerals in a work program, you have to describe what is the resource and what is the reserves and how are you going to mine each mineral. So although it's still on this list, I don't think the DMR allow you anymore to apply for all minerals. And then going back to the top, then the right also gives you, you can carry out any activity incidental to your right. So in most cases that relates then to your, where you have to build certain infrastructure so that you can complete and do your mining activity. Yes, that's what I want to share there. Then the next slide, I'm just looking a bit at the kinds of types of rights that you can apply for. And I've mentioned it, and I've noted it is mineral related. So the MPRDA is then mineral and petroleum. So there's also rights that you can apply for petroleum. So these are only the mineral related rights that you can apply for. You'll see the second one there is a prospecting right. we normally talk about an exploration right, but in the MPRDA, exploration right is specifically for petroleum and not for minerals. So the first right or application that you can do is for a reconnaissance permission. You will note there that it says there permission and not right. So a permission is not a limited real right, like I've explained earlier on. It's a permission, so you don't have the same security of tenure for a permission. A reconnaissance permission is specifically there to search for minerals by means of geological or geophysical surveys. You're not allowed to do any invasive activities, and I've mentioned there it's got no security of tenure. So you might apply for a reconnaissance permission, and then somebody else can on that same area apply for a prospecting right, and they can be granted a prospecting right, because a reconnaissance permission doesn't allow you, and it doesn't give you exclusive right to apply for a prospecting right, and you don't have that security of tenure. It's also only granted for 1 year and it's not renewable. So in my time that I was employed at the DMR, there was no person that actually applied for a reconnaissance permission. So most of the people then start and apply for a prospecting right. And normally what you do in your prospecting work program, which you then submit with your prospecting right application, your reconnaissance work, your desktop work, your geological, geophysical work that you do is then included maybe as a phase 1 and 2 in your prospecting work program and in your application for a prospecting right. Then in terms of your prospecting right, you may not dispose of minerals unless you have a Section 20 permission. So Section 20 refers to bulk sampling, so that is specifically applicable to diamonds. So you have to provide for detail in terms of your bulk sampling that you intend doing, and then you can apply together with your prospecting right for a Section 20 permission. So your prospecting right is valid for 5 years, and you can renew it once for 3 years, so you can get a prospecting right maximum of 8 years. Many people often ask me, so after 8 years now your prospecting right expires. What do you do because you haven't completed your prospecting? You want to apply for a mining right, but now obviously as soon as your right expire, you lose your security of tenure, which is very important, and I'll talk about that a bit more now. But then your right has expired, so can you apply for a new prospecting right? In my view, you can. The law doesn't say the same applicant can apply for another prospecting right. The only thing is that because now the 8 years expired, so then you have to, the day that your right expire, the next day you can apply for another prospecting right. Obviously, then you go through the whole application process. And at that point of time, anyone else can also apply for a prospecting right on the same area, because you don't have that security of tenure anymore. So currently, with the current law as it is, in the first 5 years, you've got exclusive right to apply for a renewal. And then when you get your renewal in that same period, you've got the exclusive right to apply for a mining right. So in my view, if I need to advise anyone, the best is to always try and keep your security of tenure. And maybe then when you apply for a mining right in that period, that you then look at certain areas where you're not sure if you haven't done all your exploration, that you rather then indicate it as inferred resources, and you include that into your mining right application in your mining work program. There was also cases where I assisted some companies where they had like 4 prospecting rights adjacent to one another, and obviously when you start doing your drilling activities and your prospecting activities, you find that you might only concentrate on one area, and that is maybe within 2 prospecting rights, and then there's 2 other prospecting rights which you don't really do any drilling. The law is very specific. It says if you've got a right, you must optimally prospect in accordance with your prospecting work program. it also goes back to the use it or lose it principle. So if you don't use your prospecting right, you know, you might lose it, that the right can be cancelled. So in that case, for me, it is better rather to have then one prospecting right, and then that company actually consolidated their 4 prospecting rights into one prospecting right, so that they can ensure that they don't lose their prospecting rights. Then the third one is your retention permit. And the retention permit is when you've done your prospecting activities, your 8 years is gone. Because the market is as such, you can't apply for a mining right at that time. You can then apply for a retention permit. This goes back to the use it or lose it principle. So government wants you to use your prospecting right when you have it. So in this case, you can get a retention permit for 3 years, but you will see it's very expensive. It's about a 5,000 Rand per hectare that you have to pay for this retention permit. Then once again, a retention permit is not a right. It's not like a prospecting right. It's a permit. So you don't have the same security. Although you've got security of tenure on it, you don't have the same limited real right because it's not registered. So you don't have the limited real rights that you have with a prospecting right. Then a mining permit is more for small scale operations. So, and it does not exceed 5 hectares. The law, with the amendment, it changed. It said you can only have 1 mining permit, and it may not be applied for the same or adjacent land. So at one stage, you had people that apply for 5 mining permits, and the main reason for that is that they don't want to apply for a mining right, because if you apply for a mining right, you've got responsibility, and you have to apply or submit a social and labor plan, and you've got all that additional responsibility, and they try to circumvent that by mining permits, which now with the law no longer is allowed. So you can also get your mining permit only for a maximum of 5 years. Then your mining right is then that follows normally after your prospecting right. You can get your mining rights for 30 years, and it's renewable for further periods each, which may not exceed 30 years. So you can get it then for another 30 years, and you need to mine after that, you can get it for another 30 years. Then I've just thought maybe if we just look at the application process and where you as geologists start. So normally you look at the geology, you start at the geology and you determine the area and where you want to prospect. So where's your interest? Following that, one then needs to look at what is the land parcels that is associated with that area that you're interested in. For me, this is actually where everything should start. It is very important that you then understand exactly which area are impacted on, that you know what is the farm names, what is the portions, maybe also a bit of advice. Previously, with the Minerals Act, you had to apply for a full farm portion and a full area. For instance, there up to there, that you had to apply for full farm portions and areas. With the MPRDA, it works on a coordinated system. So you actually decide then and you coordinate and you only apply for the area that you're interested in. And then your next layers that comes up, and this is just an example, it's not everything, is then where you've got your water, and this is a river and tributaries, and you've got your Eskom power lines, and you've got your communities, and you've got your roads. So this is then where the environmental part kicks in. You know, how are you going to be impacted on from an environmental point of view? How are you going to be impacted on from a social point of view? And then in terms of your application, you then determine where are you going to apply for. And because the Mine Health and Safety Act, we previously referred to the Mine Health and Safety Act and the Environmental the National Environmental Management Act. So because that is also now impacting your application, if you decide to take a big area like that, I've seen people that just go randomly and they just apply for big areas without looking at the geology and their real need. But the important, the thing that you need to understand is that if you apply for a bigger area, you are responsible in terms of mine health and safety and environment for that area that you actually apply for. Maybe just to give you a bit of a case study, when I was working at the DMR, there was cases where there was obviously underground mining in the big mines that had a big mining area. There were two smaller mines that also had areas and that was overlapping with the bigger area of the mine. And in one instance, it happened that there was a pit, and then it was done about 10 to 20 years ago. It filled up with water, and then one of the community's children actually swam in that pit and they drowned. And then the DMR had to decide, so who's the responsible party? And it was quite difficult because now you have these overlapping applications. And then obviously the person who had the mining right, the first person that had the mining right, were then kept responsible. So it's very important that you limit yourself to the area that you actually need, and not get this vast areas, because if there's an incident like that, you might be held responsible. And then also from that point of view, it is important that you also then determine what is all the impacts on the land, and then also specifically the land ownership, so that when you start with your consultation, that you then consult with the landowners, and then also look and do a bit of due diligence about what is on the property. There might be restrictions on that land which you need to be aware of. Yeah, I've just included for you the application process, and it's not the full application process, it's just for a bit of discussion purposes. So normally when you apply for a mining or a prospecting right, the law then says when you apply, you have to submit certain documents with your application. So it depends on for what right you apply, what documents you submit. And at that same time, with the change in NEMA, you also have to submit your NEMA environmental authorization application at that same time. And then this is both submitted to the DMR, and currently they still have what we call the SAMRAD system. So you submit your applications on the SAMRAD system, you identify your area, you submit upload all the documents that you have to, and then you also submit your environmental authorization. The DMR then evaluates your application, and they must either accept or they must reject your application. So at this point of time, the law then says they must accept your application if there's no person having the same application for the same minerals and land for the same minerals and land. Otherwise, they must accept the application. Unfortunately, in this process, what I've seen happen nowadays is that the environmental process continues, and you will get a letter to say, we received your EIA, you must continue with your consultation, but at that time, the acceptance and the rejection was not yet done. So you might get people starting with this process on the environmental side, and they continue quite far along the line. And only then when the DMR evaluates, they see there's another person with a right for the same minerals on the same land, and then they reject the application. And by rejecting the application, automatically you'll also have to reject the environmental authorization, and it might be already far along the way. We had a case specifically where we saw in the newspapers, and we were consulted on environment, and we saw that there was applicants applying for the same minerals that we have. And then obviously, even if, although the application was not even accepted or rejected, so we've already done, there's Section 10 notice that you sent to DMR that needs to go to REMDEX. So we've already at that time, we've done an objection to say you can't accept this application because we've already have a right for that same minerals. So obviously after the DMR then accept and reject your application, anyone can appeal that. So if you are affected party and you think it should not have been accepted, you can appeal it, or if you're an applicant and it's been rejected, you can also appeal it. Then there's also a process of Section 10, and that is in terms of the consultation that everyone it must be made known that there's an application. Then you as a landowner can maybe object against that application, or anyone who's interested and affected party may object against the application. And then the DMR is in the process where they evaluate your application. You've got either a prospecting or mining work program that you submitted, or your social and labor plan, your mine health and safety ability, your BEE and your empowerment. They evaluate. Normally in terms of administrative justice, they must come back to you after they've evaluated that and they find that you maybe need to submit additional information before they make a decision. And then after that, they then actually either grant or they refuse. And then at that time, you can again appeal the decision. Either you or any other third party can appeal the decision. On the other hand, the environmental authorization is then considered, and then they might decide to issue the environmental authorization. Or to refuse, and in most cases when they decide to refuse the environmental authorization, your mining or prospecting right will also not be granted. Then if we just look a bit at land considerations, so what I've referred to earlier on, you need to do your due diligence, you need to know who's the landowner, what title deed restrictions is there. The other day we saw one of the title deeds, it said you're only allowed to build one house on that property. You also need to determine what is the current land use, how are your activities impacting on the current land use, is there any servitudes or encumbrances on the property, the municipal spatial development framework, what is the requirement in terms of the municipality. So you need to do that due diligence, because that is also going to impact if you can actually use the land. And then also in terms of land, there's a specific section in the MPRDA, section 54. So you might get to a point where you've done all your due diligence, you got your right, and now when you want to get access to the land, that they refuse you access to the land. So in terms of this section 54, you can inform the regional manager that the landowner is refusing you access to the land. The DMR must then facilitate an agreement between you and the landowner, and then they must also guide you on maybe compensation, so that you and the landowner can come to an agreement on compensation. And if that is not achieved, then the matter can go to arbitration. And ultimately, it can also lead to the expropriation of the land. Or if the regional manager determines that the applicant does not want to settle with the landowner, he can also prohibit you to do your mining or your prospecting activities. This section is also applicable to a landowner, so it's not where you as a right holder get or refuse to access the land. It is also that if you come onto the land, the landowner can then do a section 54 application to get compensation from you. And then we look at SPLUMA, that is the Spatial Planning and Land Use Management Act. It was implemented on the 1st of July. This act specifically regulates land use, and it determines that a municipality must adopt a single land use scheme for its entire area. So previously it was more on town planning, now it covers the full area. And then your land may only be used for purposes permitted by your land use scheme. This law also then provides for penalties, imprisonment, or a fine if you do not comply with the land use scheme. And then from the municipality side, they can also get a court order to interdict you, or they can get you to demolish certain structures, or other remedial measures can be taken if you actually then continue on a specific land and you haven't rezoned it for the purpose that you want to use it for. So in our case, it will be for mining, and I've just put the list in the act here that you can actually, the purposes that you can use it for. It's either agricultural, business, commercial, and then I've just highlighted mining as well. So we as a mining company, we determine then specifically, you maybe have a mine that is underground, so you only need certain areas of your mining rights area for infrastructure, so you determine those areas, and then you apply to the municipality to change the land use to mining and quarrying to allow you to perform your activities on that land. Then in terms of your risks and your challenges, so for me, the main one, like I've said before, security of tenure. That will impact you before you even apply and during your operational phase. Then in terms of your post phase, it will be your rehabilitation. You need to rehabilitate the area. You need to get your closure. Then in terms of your pre and operational phase, you require investment and debt facilities, and investors, to get investment is very difficult if you don't have security of tenure. So it goes back to, I've got my prospecting right, I've got the exclusive right to apply for a mining right, and I need to use that so that I can get the required investment and debt for doing all my activities. And then time, it should actually be in the middle there. It impacts everything, and somebody was talking about that, and it takes time to get all these rights in place, to especially where you've already got a mining right, and you maybe need to you want to expand and you want to do a different activity, and you need an additional environmental authorization. This takes time. So nowadays, we, from our side, allow between 2 to 3 years time to get your mineral and your surface rights, your leases, and everything that you need to be on the land in place. Then also, I've talked a bit about overlapping rights. I don't think we've got enough time that I can go into too much detail into that. But that is something that we experience nowadays as seem to be an impact on us. And then the overlapping rights is sometimes where we've got a case now where there's a prospecting right granted over our mining right for different minerals. We had a case at one point of time in terms of surface rights where there was a tailings dam of a different company that was built on our mining rights area, where we actually doing underground mining. Yes, so I think for that, you actually start to look at and have systems in place that you can manage that, because it will have a big impact on you, and it might have a risk, and it might again impact on your security of tenure. And then the next one is your compliance. So it's very important that you have a system in place so that you, in terms of your prospecting work program, for instance, you need once a year, you need to submit your progress reports. You need to pay your prospecting fees. So you need to have a system in place to ensure that you comply at all time with all the requirements of your rights, so that you can actually keep your rights and you don't run into a situation where you lose your security of tenure. Then on the post side, there might be latent impacts that will have a risk, like water, and that's normally environmental impacts, and tailings and dump management. You might need to have systems in place to manage that. Then the next one is the stakeholder engagement, and I think the previous speaker has given you a lot of information on that and the risks associated with that. Then obviously also the next one, compensation. So if you need to enter into certain leases, or you need to buy property, you know, you need to beforehand in your project phase, you need to think about that and provide for that. And then also operational phase, I've added the sterilization of minerals. And there we've got cases recently where we've got a mining right. You get different, because you know, sometimes it depends on the area where you operate. You might have a lot of landowners. In our case, one of the landowners decided that they want to build a water park. They never consulted with us. And then afterwards we found that it's actually on an area where there's the minerals are quite shallow, so you need to guard against sterilizing your minerals. So yes, that is in a nutshell that I want to share with you today. I think from my side, maybe just to end and say that for me, I think it's important that you have systems in place and that you are able to manage this, because at the end of the day, you don't want to have your legals having an impact on your project and that you can't continue. Thank you.
Sorry, I couldn't find the mute button. Thank you very much, Krishna, for that very informative talk. We will allow questions. Sorry, Marius, we leave it for normally at the end. I know you had your hand up for quite a bit, so please go ahead with your question.
No problem, Sophie. No, I know I had to wait until the end. Thanks, Krishna. Very insightful. We spoke the other day about, you know, the SAMRAD system being flawed and outdated. And like you mentioned, Section 2 and 3 in the Act states that, you know, me as a citizen of South Africa actually also own the mineral wealth of the country belongs to partly to me as a citizen. And if you look at Section 30 of the Act with regards to disclosure of information, don't I, as a citizen and basically as an owner of all the minerals, have the right to all information regarding every single prospecting and mining right, you know, who it belongs to, which minerals are applied for in South Africa? Because at the moment we don't have access to that, and that it can lead to, like you rightly mentioned, some conflict in applications, and, you know, going through a lot of administration or admin to apply for a right, and then you end up finding out, no, there's already someone owning a prospecting or mining right in the area because of the SAMRAD system being outdated. You know, how do we go about getting hold of that? To my opinion, it's public information. You know, how do we go about to getting hold of that public information and you know, making it public and for everyone, all investors having access to that? Can you maybe give some tips, you know, how to engage with the DMR to not just get information on an application basis on a specific area, but the entire country?
Yes, Maurice, that is correct. Yes, unfortunately, when they introduced the SAMRAD system, the idea was that everyone could get access to it. But unfortunately, there were so many people that tried to access the system that it actually couldn't manage all the inquiries. And then they decided, no, they're going to close the system. I've read in the media the other day that they actually plan to replace the system. So hopefully within the next year or two, we might get a new system that is more accessible and that where you can get that information. So currently the only way to go is that if you are an interested and affected party or you're a landowner, you can apply for access to information. In terms, there's two access to information applications that you can submit. The one is where you don't have to pay because you are directly impacted or affected by it. You can just get the information, but unfortunately you have to still do a form for that. And then on the other hand is where you then at the head office in Pretoria have to submit an application and you pay for it and you go through the full access to information process. Unfortunately, at this point of time, it also takes a bit of time. So even if you supply access to information directly at the regional office, you know, you have to wait for a while. Thank you.
All right, thanks, Krishna. And yeah, you're quite right. During the Joburg Indaba about 2 weeks ago, there were discussions that the system will be upgraded and improved. I'll let Richard ask his question. I know he had earlier questions around the unspecified and then when does the time take, and thanks for updating on the chat about rights, but go ahead, Richard.
Thanks. Yeah, that is one question. What is the DMR's intention between unspecified and all minerals? Although I don't think anyone would put in a prospecting right application now for unspecified. That's question one. And the second question is the timelines on EIAs and the submission for an EIA. My understanding is that you can get an extension for the timelines. They're quite tight. Is there a mechanism where you can get a second extension that you're aware of? Thanks.
Okay. Yes. So for the first one, unspecified, I must say, I also don't know why they initially included that. When I was at the DMR, we never received any application for unspecified, and I think they maybe just put it in there if there is any new minerals that nobody is aware of ever and you want to apply for that. But definitely all minerals, I think they will not accept an application unless, like I say, you then touch on everything, every aspect, every method that you apply for prospecting for every mineral that you then want to apply for. And then the second question, sorry, just I can't remember now. What did you ask?
It was on the timelines of the EIAs. So the EIA timeline is quite tight, as you're probably aware.
Yes.
I think there's a mechanism to get one extension. Is there a mechanism to get a second extension?
As far as I know, not. And in my experience, they're quite tight on those time frames. And I've seen applications for environmental authorizations being refused because people haven't submitted the information in time. So as far as I know there's a lady talking tomorrow, Yolandi, about environmental management. Maybe she will have more information, but as far as I know, there's only one extension.
Thanks, Krishna, and great talk, by the way. Thank you.
Thank you.
Thank you. And Ines, you had a question around interested and affected parties during the EIA process. So please go ahead with your question. Please elaborate, Ines.
Can you hear me?
Your volume is a bit low, but yeah, give it a try.
Oh.
That was a bit, yes, that's better. Go for it.
Krishna, just a question on if you are the prospecting right holder and or mining right holder. According to me, you'd be interested in affected party, right? Even though you're not the landowner. So if a big developer comes and wants to develop a project, do they need to notify you as an interested and affected party? That's the one question. And then how do they go about finding you? Because like Marius said, the information is not that obvious. It's not like you can go to a website and find who the mineral rights holder would be.
Yes, that is true. They have to consult you because you've got your right there. So you definitely are interested in affected party. There's also a provision in the MPRDA section 53. So if you want to do any development outside of a town planning scheme, where there's a township, you have to go the route of section 53, and that is also done through the DMR. So if they want to do any development, then they send the application to the DMR, and I know that the DMR then also sends it to the mine survey section, and they then determine if there is mining rights or there is shallowly undermined areas. But unfortunately, I know with the Section 53s, it also takes some time, and I don't know if developers always wait to get that back from the DMR, you know, that they can continue with the development.
Thank you.
Okay, Carlo, you've got your hand up.
Hi, Krishna. Thanks very much for that very insightful presentation. I just have two questions. Basically, so when you apply for a prospecting right, do you first need to apply for the prospecting right and then thereafter you have to apply for a rezoning? Let's say, for instance, you want to do drilling on an area, it's a prospecting right, but do you first have to apply for the prospecting right and then apply to the local municipality or district municipality for the rezoning of the area? That's the first question. Secondly, I assume that the municipalities have a right to refuse to rezone these areas. Thank you very much.
Yes, that is correct, and it's quite a contentious issue. At this stage with prospecting, at one stage we were together with the Minerals Council looking at a guideline for the municipalities, because unfortunately all the municipalities also don't apply this land applications in the same way. So the proposal was that when you do prospecting, that you don't necessarily just inform the municipality, but you don't necessarily do a land use change application, because prospecting is only a temporary activity, and only when you start with your mining activities, you know, that you then do a rezoning application to zone your area, your mining area for mining and quarrying. Yes, so if the municipality then actually refuse your application, and maybe also something to mention is that when you do a land use application, that there's also consultation required, and you might also get people objecting to that. So they can object to your mining right application, and they can also object to your land use application, your rezoning application. So the municipality might get to a point where they actually then refuse your application. And obviously, if you don't have that, you can't commence with your mining activities. So the only route then that you can take is, in terms of SPLUMA, there's an appeal route. You can appeal the decision, or otherwise you'll have to take further legal action.
Right, thank you. Carmany, you had your hand up earlier, so I'm not sure if it's relating to the comment you put on the chat.
No, it was just for the comment that I put in the chat, Sophie, so thanks.
Okay. All right, great. Thank you. Thanks for that. We'll go to Kgothatso.
Thank you so much. Firstly, I'd just like to say, Krishna, thank you for a very informative and enlightening presentation. My question is with regards to Section 27 with issuing of mining permits. I deal specifically with artisanal miners and small-scale miners, and to some extent junior miners. So in some cases, you find that communities want to mine artisanally, but they have a large area in which they would like to mine. So they would like to have mining permits, but have mining permits of adjacent farm and mine it from a community basis. Is that possible? Because I heard you allude to the fact that you know, they would they would have to apply for a complete mine right. That's the comment or question I had rather. Thank you.
Yes, that is correct. Previously, they did allow, and people did have more than one mining permit, but I understand the situation, you know, especially for small-scale miners, and you've got all this commitments in terms of the environment and financial provision and so on. It becomes very difficult for them. I know at the DMR, and there's a small-scale mining directorate. I don't know how operational they still are. But my suggestion would be that you would maybe at one stage need to get into discussion with them and maybe bounce it off them. You know, how can one assist these small scale miners going forward?
Okay, thank you. Then Guy, go ahead.
Hi, thank you, Krista. That was also very informative. My question is kind of like the previous one, but it's more about, is there something, I guess, protecting the DMR or the environment from, say, one individual or a single company being the main shareholder or main owner of other companies that each own a permit? And you know, they might use that as a way of getting away from the environmental commitments and so on that you would need on a larger mining operation. Is there something that prevents people from being the owner of, or the main owner of, multiple permits in one place?
Yes, I think that's a good point, and I don't know if the DMR necessarily look at that. I think they more look on the applicant. But I mean, they don't necessarily look at who's the shareholder or the owner of that. So it can happen that they just have different companies and then they still apply for more mining permits within the same area.
Yeah, what I mean is they can get huge tonnage without
yes
the responsibility, which is
yes
dangerous.
Yes. So for me, the mining permit was actually there for is actually there for small scale mining, and you should actually be able to complete it within, I think it's the first 2 years, and the times to renew is just there if the market changes, you know, so that you can't do what you do, but it's actually not there to do big scale mining, but unfortunately people use it for that. And the only way that the DMR will circumvent that if they just do more compliance inspections, because that's when you will start picking it up.
Okay.
All right, thank you. I'll take one last question from Liberty. Is it possible for a general person, whether SA resident or not, to acquire a mining claim in South Africa? I assume in this jurisdiction we don't necessarily use claim, but can you answer relating to permits, possibly, Krishna?
Yes, yeah. Anyone can apply for either a prospecting right or a mining permit. You know, even if you're not a South African citizen, the only requirement is in terms of the ownership, that you must have at least 30% ownership by HTSAs.
Perfect, thank you. And yeah, thank you again for that. Sorry, I'm just looking at the chat. There was one final comment from Yolandi. Yolandi, do you want to, you had a few questions. Do you want, I'm giving you an opportunity before we go to T?
Yes, sorry, Krishna, I just wanted to add, I know you've mentioned me a few times. Regarding the previous guy's question for the permits. So according to the MPRDA, you're not allowed to apply for a permit on the same piece of land for the same mineral. So if you have a different company, let's say you call it Company A, and Company A has applied for a mining permit for granite, and now Company B wants to go in on the same piece of land for the same mineral, you're not allowed to do that. So because it's on the same property. If it's an adjacent property and it doesn't overlap each other, then yes, you can. But if it's on the same property, same mineral, then you're not allowed to do it. But that's only for permits.
Yes, in terms of that, it is then, because a permit is a coordinated area. So if you on the same property, your right or your permit is issued in terms of your area. So you apply for 5 hectares for, say, maybe coal. Somebody else can next to you, and a different company can apply for a different right, also for coal, but it's a different area because it's according to that coordinated area. So it's not necessarily about a farm or a portion, it's about your coordinated area. So you can't have more than one right for the same mineral and the same land in terms of the area.
Yeah, so for permits, basically you can't overlap each other, because then who goes in first? So DMR needs to make that separation where literally who goes in first. So Krishna, between me and you, I don't know if that actually answers the previous guy's question.
Yes.
Yeah, thank you, ladies. I think it did. And thank you again, Krishna, for that informative talk. If you are able to stay online, that would be great. We will open the floor up so everyone can unmute themselves and show their videos for the duration of the tea time. So I'd like again to say thank you to the speakers on the first session. That wraps up session 1. So we will move on to tea time. So I'm wearing my Begitele fedora again, just as a reminder to everyone to please stay safe and please stay online for the, if you can, for the duration of the tea time. And you can chat to our speakers, so Richard, Azwi, and Krishna as well, for any questions that we hadn't addressed throughout the session. So you are welcome to do that, and you can show your videos and unmute yourself. And thanks again for the discipline with regards to the housekeeping and renaming. Everyone has renamed themselves. There was just one person, I think it was Bita. So if you can rename yourself, it's name and surname, so we don't mistake you for a Zoom bomber and we can identify you and confirm your attendance. So thank you with that. Everyone can go grab their cup of coffees. Unfortunately, we can't offer you muffins or biscuits or anything like that. But yeah, please stay online if you can. And yeah, thanks again to everyone. Thanks, Nat. Christo, have you sorted out your audio? You can now ask your questions if you are audible now. You had quite a few questions and comments, so let's give it a try. So it's free for all, but orderly, please. Let's give it a try, Christo.
Hi, can you hear me now?
Yes, that's better.
Does it sound a bit better?
Yes, it is.
Apologies for that. Thank you for the good presentations from the various presenters. It seems very well, although I feel there are certain aspects missing. I noticed that most of the authorization or rights that are focused on is mostly with respect to mineral rights. But in I've noticed that most of the geologists or the consulting companies tend to forget that in order to obtain these licenses, still needs to be run parallel with other authorizations needed, such as an authorization, environmental authorization, or a record of decision making, or a water use license. And in most cases, it's imperative that these things run parallel with each other in order to avoid silos or gaps or duplication of information. And I feel maybe next time, if a course like this can be offered, that the consultants or the specialists involved may get a specialist that is well in tune with the water use licensing processes, as well as the environmental authorizations, knowing that there are site-specific activities, and well, in the end, we are chasing certain commodities, but at the same time, it has an impact on the environment as well as the community. Thank you.
Thanks,
So
that's a good comment. Look, what we might have a day focusing on licenses. We had one, I think it was 2016. Lena, the other ladies can correct me if I'm wrong, where we focus on that and the various licenses from water use and so on. But thank you for that comment. It is noted.
Okay, thank you.
Thanks. Any other questions while we have the speakers during tea time? Please go ahead. Oh, sorry, I didn't tell everyone we'll reconvene at 11:15, but I'm sure everyone has read the program. So we still have another 7 minutes to go bake your muffins and make your tea and coffee. Any other questions, comments? Krishna, you unmuted yourself. Any other thoughts?
I'm thinking.
No, I'm not putting on you on the spot. Yeah, go ahead.
Sorry, maybe what I forgot to share is that in terms of the MPRDA, the government is not prescriptive on what you submit, and so when you apply for a prospecting or mining right, you compile the application, you decide how are you going to prospect, or you decide how are you going to mine. So the government is not prescriptive to say you should mine so many tons per year and so forth. But at the end of the day, when that right is granted, you are then kept to what you actually committed. So, and then because going back to what I said about the government or the minerals belonging to the nation and the government being the custodian, so they must ensure now that you said you're going to do so many tons and you're going to contribute this to the SLP and you're going to pay this royalties and so forth. So they then keep you to what you actually said. And you find many cases where people overcommit. And then at the end of the day, they get Section 93 orders to say, you know, you're not doing what you're supposed to do, but it's something that they've actually put there themselves. So for me, it's very important when you go through these processes that you determine exactly, you know, I think that first speaker, when he talked about the project management and and all the work that you do before pre-feasibility is very important, because that is the information that actually goes into your application.
Thanks for that, Krishna. I'll go to Kamini and then Guy. You've unmuted yourselves. Kamini, anything to add?
I just wanted to say, like, as Krishna said about overcommitting.
Kamini, sorry, your audio, your volume is low. Maybe get closer or turn it up, your mic.
Can you hear me now?
Yeah, it's a bit better. Let's give it a try.
Also, overcommitting, as Krishna said, in some cases, when you get your mining right, there's certain issues that you can't start right away because of maybe electricity supply, you haven't gotten your water use license yet, or certain issues. But you still have to keep to your commitment in your SLP of your local economic development. And that commitment you're keeping up with without making any income onto your mine. So also just know when you're committing to those things for the first few years, keep in consideration that you might not be operating, but that requirement is still there for your mining right.
No, thanks, Kamini. Guy, do you have a comment?
I meant to be muted, sorry.
No, not a problem. Look, I had said it is open for any other comments or questions, so no problem with that.
Okay.
Gia had so I'm diverting a bit. Gia had a question about the whole Kolobeni case. I think it was addressed to Azwi. Anything to add on that controversy there, Azwi? Are you still on? Yes, you are. You are on mute? Or maybe he's going to make his coffee. Oh, there you are. Go for it.
Am I audible? Okay. Yeah, I think that one was one of a very big, challenging one. But I mean, when I try to really read throughout what could have happened there, we seem to be forcing community in things that they're not interested in. In other words, we're taking decisions here for the community. So I think in that case there, whoever was responsible for engagement, I really don't think there was a basic consultations or engagement that was done. Because by the time engagement was done, already they wanted to start mining, and there were already a lot of activities that were already taking place there. So already communities will think that you are taking them for a ride, because consultation should not be done just for the sake of doing it. It should be done in an honest way, And we must really show the community that we care about them and we understand their concern, and not doing it just for legal purpose. So I think that's where the problem was, because I could see also the DMR was so much involved there, and they're sort of enforcing this to the community. And we can't do that. We need to get an input from the community, and we really need to take a step. Even if it takes a year for us to get a permission from the community, we need to be patient and engage with the community. I think that's where the problem was. But I think we can talk on and on, but I think that's the basic thing. We failed in the basic communication with the communities there. Thank you.
Thanks. As we're still around tomorrow again, so Kia, you can engage with Azwi again on this matter tomorrow. I'm gonna go on mute. Colin has got his presentation up already. Are you gonna put it in slideshow mode, Colin? I'm gonna hand over back to Nat and Fiona, who will take care of the next sessions. Thank you, ladies.
Thanks so much, Sifiso. That was very nice to have you with us today. And thanks for the great job you did sharing that session. So next up we have Colin Rice. He doesn't need much of an introduction. If you're in the mining industry, you've probably come across Colin before. But today he's going to talk to us a bit more about the legal aspects of drilling, of exploration drilling. Not so much the actual drilling bits, but thank you, Colin. Over to you. If you just need to put your presentation in presentation mode. And unmute yourself.
Give me 1 sec.
No problem.
Is that now in presentation mode?
Not yet.
Let me try again. Let me just do something quickly here. Bear with me 1 sec.
No problem.
Is that better? No, it's not. Give me 1 sec. Yet. Sorry, guys.
No problem.
Did this the other day as well.
There we go. Perfect.
Are we in presentation mode? Great.
Yes.
Excellent. Thank you, Natalie. Thank you, Becky, for chairing the previous session there. Thanks very much, guys, for having me. It's great to be with you. I saw on the participants list there's a lot of names there I've recognized from the old days. I hope you all are keeping well in these difficult times. I was asked to do a little presentation today and one tomorrow on some legal aspects of exploration drilling. And so what we're going to do today, I'm going to talk about what I've called legal aspects of exploration drilling. And here I'm focusing very much on drilling as opposed to some of the things that Krista spoke about earlier, and some of the earlier stage project issues that Richard spoke about earlier. My focus is going to be specifically on the drilling aspect of it. So basically what we're going to kind of explore is the law and exploration drilling. What laws affect what we do on a drilling project? In every country in the world, there are laws or regulations that govern the way that you operate. In most countries, it will be an occupational health and safety type act. But in some countries, the law is silent. There is absolutely no mention whatsoever of drilling or exploration or anything that talks even about mining. And that makes it very, very difficult for us. And unfortunately, for you guys as project geologists, as geos who are going to be in charge of an exploration project, it is absolutely essential that you have a really good understanding of the laws that affect what you're doing. For two reasons. Number one, you must work within the law. And number two, don't get caught up in the consequences, because in some countries, the consequences are horrendous. In this country, they are pretty strict. The consequences of falling foul of the law can be pretty bad. So what I want to try and do today in a very, very short time, this presentation and the one tomorrow are basically extracts of our legal aspects course that we do on one of our certificate programs. So I've tried to condense it and get as much into this hour as I possibly can. So all we can do really is to give you an overview of the laws and try and maybe highlight for you where you've got to go and do a little bit more work, do a little bit more research to make sure that you cover your butt when you start your project. So first I'm going to look at the laws that are applicable to exploration drilling. Then we're going to talk about the Mine Health and Safety Act, because that's the most important act that affects what we do. And I'm going to talk about, just to give it the perspective, because if you understand the perspective, where it comes from, the origins of the Mine Health and Safety Act, you have a better understanding of it. So we'll talk about that. Then we're going to talk about some of the sections of the Act that are applicable to exploration drilling. And then we will talk a little bit about the regulations of the Act that are applicable to exploration drilling. This will all make sense as we progress through it. So to start with, let's look at the laws. In South Africa, all work, doesn't matter where you work, a shop, a factory, a hotel, a restaurant, makes no difference. Every bit of work, all work-related activities are regulated by the Occupational Health and Safety Act, what we call OSHA in South Africa. And it follows, therefore, the drilling activities, exploration activities too, must comply fully with OSHA. But the problem is that OSHA was not written for mining or drilling activities. It was written for factories and shops and offices. And so there's nothing there that really addresses mining or really addresses drilling. There's some sections that do, and what we've got to do is we've got to extract those sections, make sense of them, interpret them in the right way, and then apply them. I'm not going to spend any time talking about the Occupational Health and Safety Act because it doesn't really have any direct, it's kind of superseded by the Mine Health and Safety Act in a drilling context. There are a number of other laws as well, acts of parliament that govern or have an impact on exploration drilling. The MPRDA, Krishna spoke very, very eloquently about that just now, a fantastic presentation. Then we have the Mine Health and Safety Act, the Employment Equity Act, environmental acts, conditions of employment, and so on. All of these have an impact on you as an exploration drilling project manager. And it's important that you understand what these are. We cannot possibly talk about all of these in the course of 1 hour. So I want to focus on the Mine Health and Safety Act. Just to put some of this in perspective, Krishna spoke just now about the MPRDA. And all I want to say about the MPRDA is that the MPRDA is there to monitor and to issue permits for prospecting and for mining. That's all I'm going to say about it. But one important thing here that we just want to talk about very quickly. In the MPRDA, prospecting is defined as intentionally searching for any mineral by any means which disturbs the surface of the earth. I've paraphrased. So it's any intentional activity aimed at searching for a mineral which disturbs the surface of the earth. It then goes on and it defines a mineral as any substance excluding water, but including sandstone, rock, gravel, clay, as well as soil other than topsoil. So what's very important here, what I want you just to understand here, it's purely of interest at this point in time, is that water is not considered a mineral. And so when we drill for water, it is not considered prospecting. So therefore, any activity searching for a mineral can only be done in terms of a prospecting permit issued under the MPRDA. Water does not require a permit in terms of the MPRDA. And that's important. I want you just to remember that. We'll chat about that in a little while. The act that we are most interested in, the act that affects exploration drilling, it governs what we do, is the Mine Health and Safety Act. And currently it's the Mine Health and Safety Act number 29 of 1996. And to put this in perspective, to convince you that this act does govern exploration activities, all we've got to do is to look at one of the definitions of the act. And in the definitions of section 102 of the act, a mine is defined as any borehole or exploration in the earth made for the purpose of searching for or winning a mineral. So it's pretty clear then that by definition, an exploration borehole is a mine, and therefore it is regulated by the Mine Health and Safety Act. It's as simple as that. An exploration borehole is deemed to be a mine, and therefore it is regulated by the Mine Health and Safety Act. So there's two main pieces of legislation we've got to be concerned with: OSHA and the Mine Health and Safety Act. As I said, OSHA, there are parts of it that apply to exploration drilling, but we can't talk about them in the little short while we have available today. But most of those provisions are covered in the Mine Health and Safety Act in any event. Okay, so let's look now at the origins and structure of the Mine Health and Safety Act. As I said, if you understand where it comes from, why it was developed, how it was developed, it will help you understand why it's so important and why we hold it in such high regard in the industry. Back in 1911, the Mines and Works Act number 12 was promulgated, and that act regulated mining activities. Those were back in the dark days. Safiso was still at school in those days. That legislation remained in force until 1956, a very, very long time, of over 40 years, that same piece of legislation to be in effect. And it was then repealed and replaced by the Mines and Works Act 27 of 1956. That act remained in force until 1991, when the Minerals Act of 1991 was promulgated. Through those times, South Africa had one of the worst safety records in the world of any major mining company. I'll show you some statistics just now. But we had a shocking fatality rate, very high injury rate, and many non-government organizations, trade unions such as NUM, lobbied government over many years to improve the levels of safety in our mines. And in 1993, the Minister of Mineral and Energy Affairs appointed what became known as the Leon Commission. And the Leon Commission set about investigating conditions of health and safety on our mines. The Leon Commission it's a very interesting document to read their report. It's a very lengthy document. But I've just put here some of the findings that came out of the Leon Commission of Inquiry. They estimated, based on submissions they got, that 69,000 mine workers died in the first 93 years of the century. 99% of them were in underground mines. Gold mines accounted for 86% of all reported injuries and 73% of all fatalities. 1.54 mine workers were killed and 26 were injured for every 1,000 underground miners working in South Africa. And out of a survey of 19 other countries, we had the 6th highest fatality rate. And so there was obviously serious problems with our mining industry and with our levels of safety and our attitudes to safety. And as a direct result of the work that the Leon Commission did, the Mine Health and Safety Act that we currently work with was promulgated in 1996. And it has been lauded around the world as being some of the finest mining legislation in the world. And I want to talk today, just very briefly, about the Act, give you a little bit of a flavor of what it's trying to do and how it does it, and hopefully encourage you to learn more and more about the Act. When we look at the structure of the Mine Health and Safety Act, this is the Mine Health and Safety Act. This is mine. In my bookcase behind me here, I have got probably 7 or 8 previous versions of this. You won't believe me, but I read this at night in bed. The plot is fantastic. The characters are terrible, but it's a good book to read. And it's I encourage you all to get a copy of it and read it because it has such a big impact on your lives. In terms of the structure of the Mine Health and Safety Act, it's composed of 8 chapters and 106 sections. And each chapter deals with a different aspect of mining legislation. And we certainly not going to go through that, but I'll show you some of the sections just now, just to show you how the thing is structured. So please remember, it's got 8 chapters and 106 sections in the Mine Health and Safety Act. Then at the back of the Act are what are called schedules. It's not too much importance now, but the schedules deal with certain aspects of mining regulation. And then what's very important, part of the Act are 2 sets of regulations. And we'll talk about those just now in a little bit of detail. So essentially, what I want you to try and remember here, guys, is the Mine Health and Safety Act is composed of 3 parts. It's the Act itself, those 8 chapters and the 106 sections. Then we have the regulations of the Mine Health and Safety Act. And then we have the Mines and Works regulations. And I'll explain to you where those come from just now. So please bear that in mind. There are 3 parts to it. And if you look at, you can't really see clearly where you are, but in my book here, I've got 3 tabs that divide the Mine Health and Safety Act into those different parts. That'll make some more sense just now. Again, just to give you a flavor of what this Act is trying to do. The very first statement in the Act is the purpose of the Act. I want to spend 2 minutes just going through this, because if you understand this, you will understand what the Act is trying to do and why some of the regulations are written the way that they're written. First of all, it's there to provide for the protection of health and safety of employees and other persons at mines. And we all know that the other persons would be visitors, consultants, the communities that are affected by mining, and the general environment around the mine. So it's there to promote a culture of health and safety. This is a word that we hear so often with mining companies. They talk about their safety culture, and that's what the Mine Health and Safety Act is trying to develop. It is there to provide for the enforcement of health and safety measures. They're not asking you to work in a safe way. They're going to force you to work in a safe way, and the penalties are quite dramatic in some cases. It's there to provide for monitoring, inspections, investigations, and inquiries. In a very rude way, in the old days, we used to bury the dead. We just used to, nobody knew about them. You don't do that now. Every incident, every accident is reported. It's investigated, reported on, so that we have no repeats. Very important part of what the Act is trying to do. It is there to try and promote training and human resource development, has a big emphasis on training. And very importantly, it is there to regulate the employers and the employees' duties to identify hazards and eliminate, control, and minimize risk. I'll show you just now exactly what that means and why that is so important here. And most importantly, what sets our Mine Health and Safety Act apart from so many other pieces of mining legislation in the world is that it entrenches the right to refuse to work in dangerous conditions. Part of the Act, one of the sections, we'll talk about it just now, it entrenches the right to refuse to work in dangerous situations. And that's what sets our Act apart. Now, those purposes or those statements are included in Section 1 of the Mine Health and Safety Act. In the very first section on page 1, page 2, in fact, of the Mine Health and Safety Act are the objects of the Act, and that sets out the objectives. Okay, so that's where it comes from. It comes, many people will tell you that the Mine Health and Safety Act was born out of the blood of many, many people who were injured and killed in our mines. And it is there. It's really good legislation. It's very sensible. And if you understand it correctly, you apply it correctly, it makes wonderful sense. Let's have a look now at the sections of the Act that are applicable to exploration drilling. Now, guys, all I can do here is show you a couple. I want to try and give you a flavor for how we would approach this analysis. We cannot possibly go into all the detail. This little summary we're doing here is a 4-day course we do on legal aspects of exploration drilling, where we go into it in a great amount of detail. All I want to do is give you a little flavor of how you would maybe go and do some more investigation of your own. So let's look at the sections that are applicable to the Mine Health and Safety Act. If you get a copy of the Mine Health and Safety Act and you look at the index, the contents, and you flick through it, you will see that there are 8 chapters and there are 106 sections. And each section has got a different title and it deals with a different aspect of safety on a mine. Not all of these apply to an exploration drilling operation. That's the key. This act was written for mining. It was not written for drilling. So the challenge for us is that we have to extract from this act what applies to exploration drilling. The word drilling appears 13 times in the Mine Health and Safety. The Mine Health and Safety Act, my version of the Mine Health and Safety Act, is about 540 pages long. And the word drilling appears 13 times in the Act. Once it appears in the definition of prospecting, and in the other 12 times, it is in reference to drilling what are called shot holes, what we would call blast holes. So there's no reference whatsoever anywhere in the Act to exploration. It was not written, exploration was not envisaged by the guys who drafted this legislation. So it becomes very difficult for us. And it's an exercise I've been doing over years and years and years, and one that you as an exploration geologist are going to have to do for yourselves. What we've got to do, we've got to look at the Act, we've got to read it, just like I do in bed at night. And you've got to identify the sections, identify the provisions and the regulations that apply to what we do. You've got to interpret them, extract them, and then apply them to what you do. And I'll try and give you some examples just now of what I mean by that. It's not as though this is a step-by-step guide on how to run a drill site or how to run a drilling operation from a safety point of view. We've got to do a lot of interpretation. This is where a lot of the problems come with mines and contractors. They have big problems with mines in terms of interpretation of these different requirements. So let's get into some of these sections that apply to us. And before I do that, I want to just go back to section 102 of the Act, where we have some definitions. Please, guys, this one little section here, this one definition, I love it because I think it gives you a really, really good flavor, a really good indication of how clever this legislation is. It is the definition of an owner. Who is the owner of a mine? And the definition says, in relation to a mine, the owner is the holder of a prospecting permit or mining authorization issued under the MPRDA. Perfect sense. So the oak who's got that permit or the mining authorization, he is the owner. Part 2 says, if a prospecting permit or mining authorization does not exist, then it is the person for whom the activities are undertaken. So in other words, if you're mining illegally, or if you've said, oh, these laws in South Africa are far too onerous, we're not going to do this, we're just going to go and start mining, or we're going to start drilling anyway, you are deemed to be the owner. And please bear in mind, guys, a borehole is a mine. So you would then be the owner of that mine. And then 3 says, very, very important, if neither 1 or 2 is applicable, in other words, if the drilling or the mining is not being done legally or illegally, then the owner is the last person who worked the mine or that person's successor in title. So if I was a mine owner and I passed away and I left the mine to my son then becomes the owner of that mine. If I leave behind liabilities in terms of the Act, then my son would inherit those liabilities. And that's what's important. It's beautiful legislation because it covers all of those aspects. And if you think, whenever I do these lectures, I always talk about probably the biggest potential environmental problem in Johannesburg now is acid mine drainage. And that was caused many, many years ago. The guys that caused that spent their millions many years ago. They're all living in Switzerland or London or New York. And we now are living with that problem. And it's a huge problem for South Africa, the rehabilitation of those old mines. So please bear this in mind. The owner of a mine is the person who owns a prospecting permit if it's a legal operation. Please bear that in mind. Okay, two more definitions that are very, very important. The employer in the Act, it talks all the time about the employer. And the employer is the owner. And you'll see exactly what I mean by this in a minute. And then the last one I want to talk about is an employee. And an employee is any person who is employed or working at a mine. So if you work for Anglo American or for Bafokeng Platinum, wherever it happens to be, you are an employee. If I come to do some consulting work for you or to come and do a survey, or whatever the case happens to be, if I'm a consultant coming to work there, I am still an employee of the mine because I'm working at the mine. And therefore, my duties, which I'll talk about shortly, are exactly the same as an employee's duties. And the employer's responsibilities to me are exactly the same as his responsibilities to a guy who's on his payroll. Three very important definitions there I want you to please bear in mind. Now, as I said, there are 106 sections in the Mine Health and Safety Act. And certainly not all of them apply to exploration drilling. So what I've done, I've extracted what I believe applies to exploration drilling. And there's, I think, 15 of them, I can't remember. But there's only a few of them that have direct implication for an exploration drilling operation. And I've kind of combine these into 6 groups because they all kind of make sense. We can't possibly talk about all of these 6 groups. I'm just going to talk about 2 of them because I want to just give you a flavor for what they mean. So what I want to talk about quickly is section 5 and section 11. And then I want to talk quickly about section 22 and 23. And then finally, just a quick little flip at section 54 and 55. So let's look at before we go to section 5, I beg your pardon, I want to just quickly talk about section 2. In tomorrow's presentation, we talk about the legal appointment structure in terms of the Mine Health and Safety Act. And we'll talk in detail about sections 2, 3, 4, and 7 tomorrow. All I want to do today is just talk quickly about 2 because it gives you a bit of perspective. Now, please, guys, excuse me, I've got to read some of this because you just have to. If you get yourselves a copy of the Mine Health and Safety Act, you can have a good read of this at your leisure as well. But all I want to do is just read the first part of section 2. The title of section 2 says the employer to ensure safety. Now, who is the employer? The employer is the owner. Now, think carefully about Anglo American. Probably everybody on this conference call, on the Zoom call, is directly or indirectly a shareholder of Anglo American. Because if you've got a pension scheme or insurance policy, or you own some unit trust, you probably own a bit of Anglo American. So Anglo American is owned by thousands of different people, different shareholders. But the employer or the owner must ensure safety. So the Act says the employer of every mine that is being worked must ensure as far as reasonably practicable that the mine is designed, constructed, and equipped to provide conditions for safe operation and a healthy working environment. So from the design phase to the construction phase to the equipping of the mine, the owner must make sure that that mine is operated, it's designed, equipped to ensure a safe and healthy work environment. Then you go to B. The employer of every mine that is being worked must ensure, as far as is reasonably practicable, that the mine is commissioned, operated, maintained, and decommissioned in such a way that employees can perform their work without endangering the health and safety of themselves or any other person. Now, if you combine A and B, what it's telling you is that the employer, the owner, from the design phase to the decommissioning phase, so that entire life cycle of the mine, he's got to ensure that the mine operates in a healthy and safe way, and that no employees or people who may be affected by the mine are injured. I've paraphrased, obviously, but it's an all-encompassing requirement. And Section 2 defines what this act is all about. The employer is totally responsible from the beginning to the end of that mine for every aspect of it. It then goes on, and this is where it becomes even more onerous. Subsection 2 says, the employer of a mine that is not being worked, but in respect of which a closure certificate in terms of the MPRDA has not been issued, must take reasonable steps to continuously prevent injuries, ill health, loss of life, or damage of any kind from occurring at or because of the mine. Now, in South Africa, Krishna would know a great deal more about this than I do, but once you shut down a mine, you rehabilitate it, you go back to the DMR and you apply for a mine closure certificate. And what that means is that liability for that mine now transfers to the state. But the state doesn't want that liability, so therefore they don't issue closure certificates. So all of these abandoned mines that are now being overrun by illegal miners, technically, it's going to be a very interesting court case one day when it gets to court. Technically, the owners of those mines, the previous owners, are still liable and potentially could be sued for any damage or injury or loss that is caused because of that mine being there. And it begs the question, how does somebody who shut down a mine 15 years ago ensure that nobody gets access to that mine again? Do you put armed guards? Is a fence with a no entry sign enough? It'll be a very interesting debate in court one of these days. Very quickly, there was a term that we saw there called reasonably practicable. This is very important for a project geo to understand. So I want to just spend 2 minutes talking about this quickly. Again, if we go to section 102 of the Act, where we have our definitions, it defines reasonably practicable as being practical, having regard to the severity and the scope of the hazard, of knowledge available about the hazard, the availability of means to mitigate that hazard, and the costs and benefits of removing or mitigating that hazard. Let me give you an example of what I mean. In an exploration project, let's say, for example, you're drilling in Mpumalanga on a farmer's mealie field. It is reasonable, and it is a legal requirement that you barricade your drill site. At the entrance to the drill site, you would have a locked gate, a gate that was lockable, I should say, and you'll have signboards indicating all sorts of bits of information. And that would be quite reasonable, and you do that. If you were drilling on the top of a hill in Tabazimbi a while ago, I did some work up there a few years ago, it took 45 minutes to get up this hill. Nobody in their right mind would go up there apart from a driller. And nobody but a geologist would send them up there anyway. But it took us 45 minutes to get up there. Drilling on the side of a hill like that, we had a work area that was a little bit wider than my desk. It is just not practical to have a barricade. Not a steel barricade, that's for sure. Not a fence type barricade. Not even that danger tape that some mines allow on their sites. It's just not practical. So you've got to be practical in the way that you apply these requirements. And that is, again, where it creates some sort of gray areas where a lot of problems occur in the exploration industry. One other quick thing I want to talk about here. Tomorrow we talk about this in a lot of detail. Section 2A is incredibly important because Section 2A says the Chief Executive Officer is charged with certain functions. Every Chief Executive Officer must take reasonable steps to ensure that the functions of the employer, as contemplated in this Act, are properly performed. So, paraphrased, what that is saying, the Act recognizes that the employer the owner. Employer owner is the same word, same meaning. The owner of a mine may be thousands of shareholders all over the world. They cannot possibly be responsible for what happens on that mine. And so the CEO is deemed to be the owner's representative. And it is the CEO who carries total responsibility for that mine. Anything that goes wrong, it is his head on the block. He is the guy that will potentially ultimately land up in court. And please bear that in mind. We'll talk in a lot of detail about that tomorrow, but just bear that in mind. The CEO is the owner's representative. So wherever in this little bit of work we're going to do now, we look at some of these sections. Where we see the word employer, think CEO. So for example, if you work for Anglo American, think of Mark Cutifani. And if you think of the ex-CEO of Rio Tinto, who did something quite silly or allowed something quite silly to happen in Australia recently, he's no longer CEO of Rio Tinto. So please bear that in mind. The CEO is the owner's representative. Okay, so now let's have a look at some of these sections. I'm going to go through this fairly quickly, but there's two here I want to just focus on because it's of particular relevance to a project geo, to a geo looking after a project. Section 5 of the Mine Health and Safety Act says, the employer must maintain a healthy and safe mine environment. As far as is reasonably practicable, every employer must provide and maintain a working environment that is safe and without risk to health of employees. Subsection 2, as far as is reasonably practicable, every employer must identify the hazards and assess the risks to which persons who are not employees may be exposed, and ensure that persons who are not employees, but who may be affected by the activities, are not exposed to any hazards. So who are not employees? That's the community, that's visitors, people who don't get directly paid by the mine or indirectly paid by the mine as perhaps a consultant would. So generally speaking, what you're talking about here are the community. So section 5, very important, says that the mine, the employer, the owner, the CEO, must make sure that non-employees are not affected by the activities of the mine. And guys, if you know anything about health and safety, you will know that the process of identifying hazards and assessing risks is called a risk assessment. So to paraphrase section 5 says, the mine, the CEO, must do a risk assessment for all the hazards to which non-employees, the community, may be exposed. Very, very important. One of the key things there, one of the most important parts of section 5, is to take care of visitors. And so this is why whenever you go to a drill site, you've got to do a visitor's induction. I've been through hundreds of them on drill sites I've visited. And it's very, very important that the visitor's induction is done in the right way. Think about what section 5 says. Section 5 says you must identify the hazards, assess the risk, and then you must make sure that people don't get harmed by those hazards. So therefore, the purpose of the visitor's induction is to tell them what hazards are on the drill site and to tell them what controls you've got in place. Very often I go and the guy says, hi, my name's John. I've got 3 kids. I've got a lovely daughter. She's getting married next month. And by the way, don't fall on the drill site. That's not a visitor's induction. You can't just sign a book and say, well done, chum, you're now inducted. It's got to be clear delivered. It's got to be focused. And I find in the work I do, in the safety work I do, the quality of a visitor's induction tells me a great deal about the company. Because if you don't even understand what a visitor's induction is, then what else don't you understand? So it's a really important thing to make sure you get right. And as a project manager, make sure that your contractor has a good visitor's induction. There's nothing more embarrassing than coming along and having a bad visitor's induction. Section 11, very quickly. Section 5 spoke about doing a risk assessment for people, for hazards to which non-employees are exposed. Section 11 is a very long section. I'm not going to go through all of it, but I just want you to understand the gist of it here. Section 11 says, the employer must assess and respond to risk. Every employer must Identify the hazards to which employees may be exposed while they're at work. Assess the risks to which employees may be exposed while they're at work. Record the hazards, and then make those records available for inspection by employees. In other words, what Section 11 now says to us is do a risk assessment on all the hazards to which employees may be exposed. And that's why I group Section 5 and Section 11 together. 5, risk assessment for hazards to which non-employees are exposed. Section 11, risk assessment to which employees are exposed. And these two, guys, as a project manager, from a safety perspective, you have got to manage risk. That is what your job is about. With the greatest respect, very seldom do you find a geo who has the detailed drilling knowledge to really affect what a driller does or how he operates. But what you've got to do is understand risk. And the only way you can do that is through a risk assessment. And if these risk assessments are poorly done, you're dead in the water. You're going to have a big, big problem. And frequently I find I go to sites where there are issues, and it all stems back to the fact that the risk assessment is rubbish. It hasn't identified hazard. It hasn't identified risk. It hasn't identified the right controls. And so you're working with exposed risk. And that is your primary job as a project manager. I would argue Richard did a fantastic presentation this morning on project management, absolutely brilliant. But safety is even more important than that. And if you've worked for any of the major mining companies, you'll know exactly what I mean. I'm not going to spend a long time going through the rest of Section 11, but please, guys, get yourselves a copy of the Mine Health and Safety Act. You can get them from us. You can get them all over the place. Read it. It's very, very important that you do. Section 5 and Section 11 are incredibly important. I'm not going to go through all of this because we just haven't got all the time to go into all of that detail now. I just want to make one point very, very clear here, just to summarize this last little bit. The assessment of risk in terms of Sections 5 and Sections 11 of the Mine Health and Safety Act is a legal requirement. If somebody was harmed because your Section 5 or your Section 11 risk assessment was poor, you have failed in your primary responsibility to look after safety on a drill site. And there's all sorts of penalties for it. In terms of Section 5 and 11, the maximum penalty is R1 million or 5 years in prison. I don't think I would like either of those. So please, that's a really important focus of a project manager's work. Okay, we won't worry about that, little summary there. The next part I want to talk about, if you read all of the sections of the Act, if you read all of these ones here on the left, sections 5, 11, 6, 24, 8, sections 10, for example, all of these place huge responsibility on the employer. If you read it, the employer must do this, the employer must do this, the employer must do this, the employer must do this. All of the responsibility and the duties are placed on the employer. But what makes this health and safety such a beautiful piece of work, such a lovely piece of legislation, is Section 22. Because Section 22 balances the Act. And Section 22 very clearly talks about the employee's duties for health and safety. And again, this is very important for a project geo to understand, because anybody working on your project, whether he's a surveyor, or doing geophysical surveys or whatever he's doing, if it's a consultant or a safety auditor, whatever it happens to be, he's an employee of that company, therefore under your direct control and direct responsibility. If we read Section 22, there are 6 requirements, 6 things, 6 duties of every employee. Take care of yourself. Take care of your body. Take care of your PPE. Report all dangerous activities or any deficiencies in your operation. Cooperate with your employer and the employer's representatives, and follow all procedures. If you read all of that words, all those words on the left, A to F, paraphrased, it gives you what I've summarized there on the right. Very, very simple. And when I do a safety audit and I go to a drill site, very frequently I'm asked, how do you know how good this contractor safety system is? I will ask a supervisor, very seldom will he know this. I'll ask a driller and I'll ask a drilling assistant. Please tell me what your responsibilities are in terms of section 22. If you get a glazed look, you're in trouble. If they can give you 3 out of 6, you're doing very well. You're doing exceptionally well. Give you 6 out of 6, you're doing very, very, very well. But clearly, the employees have to understand what their responsibilities are. They have to understand what their responsibilities are. And so this becomes a basic requirement. The second part I want to talk about here is section 23. And section 23 is what makes our Mine Health and Safety Act stand apart from all other mining legislation. And this is the section, I've just put the first part of it in here. This is the section that gives an employee the right to refuse to work in a dangerous situation. I'm not going to read it because it's not necessary. You can do that yourselves when you get a copy of the Mine Health and Safety Act. But I just want you to bear in mind that the right to refuse to work in a dangerous situation, in dangerous conditions, is entrenched in the Act. It's not only one way, though. Section 23 says in further parts that I haven't put in this slide, further on, section 23 says that if the workplace is then made safe, you must go back to work. So you can't use section 23 as an excuse not to work because you've got a hangover or you just don't feel like working. There's got to be a legitimate reason, and if the condition is made safe, you are obliged to go back to work. You must cooperate with the employer and you must go back to work. So that's section 23. Last 2 little slides in this part, and then I'll move on and talk about some of the regulations very, very quickly. Section 54 is the one that sends cold shivers down our spines. It is what nobody wants to hear on a mine. Section 54 is a stoppage order given by an inspector of mines. So he can come onto a mine or onto a drill site, he can see something that he doesn't like, and he can shut you down. And he'll say, stop working, and you shut the mine down. And it is probably the biggest bugbear in the mining industry. In the drilling industry, we have the same problem. DMR inspectors come on site, they'll see something. In many cases, they don't even know what a drill rig is, but they'll still come along and shut a rig down because a fire extinguisher is in the wrong place or because the first aid box was open. But section 54 is a stoppage order. It's quite interesting. I've put in here section 55, just out of interest. Section 55 gives an inspector of mines the power to order compliance. So he can come to your drill site or to your mine, he can see something wrong, and section 55 says, get this right by next week, Monday, or else I'm going to shut you down. Now, normally in normal work, you would fire a warning shot and then you would shoot. But in terms of the Mine Health and Safety Act, you shoot first and then you give them a warning. So I would like to see 54 and 55 reversed, but that's just a silly point. So those are the sections of the Act that I believe, or a sample of the sections of the Act that apply to us. There's all of those others, and it's really important you understand them. As I said earlier, the Act is in 3 parts. We've got the first part, which is the Act itself. We've then got the regulations of the Mine Health and Safety Act, and then the regulations of the Mines and Works Act. What I want to do now quickly is look at the regulations. Now, guys, this I can just barely touch this because it is such a deep and complex part of the Act to get into. If you look at the Act, the first part in my little book here, this first section, which is the Act itself, is 80 pages long. The second section, which are the regulations, are 235 pages long. And then the last part, which are the regulations of the Mines and Works Act, that's 225 pages long. So the detail of the Act is not in the first part, it's in the regulations. All the first part does, it gives you broad brushstrokes. It gives you broad concepts, broad guidelines, if you like, of what you've got to do. Make sure your mine is safe. The regulations tell you how to do that, and they get very, very detailed. And this is where it becomes difficult, because here you've got to read the regulations, and this is where the interpretation becomes very, very difficult. I want to give you just one example of it. Before I go on to that, I want to just quickly explain to you, why are there two sets of regulations? Why do we have regulations of the Mine Health and Safety Act and regulations of the Mines and Works Act? Well, it's very, very simple. I'll run through this very, very quickly. When they develop legislation, when they repeal an act of parliament, every act of parliament has the act and then regulations. All of them are in two parts. And very often what they do, they'll change parts of the act, but the regulations are still fine. They're still applicable, so why change it? Leave them as it is. And so what they will do is they will leave the regulations of the old act and they'll just refer to them in the new act. And that's exactly what happened here. So when the old Mines and Works Act of 1911, for all those years ago when Sifiso was still at school, from all those years back, some of those regulations are still applicable today. They're still applicable to mining today, so they've left them. And some of them they've rewritten. And those now occur as the regulations to the Mine Health and Safety Act, but the old ones are still there. They still have the same full effect of the Act, the same power through the Act as any of the other regulations. And so it makes it quite complex for us. So we've got to, when we look at regulations, we look at two sets of regulations. And this will, the second part of that will make sense if you join us tomorrow. So in the first set, the regulations of the Mine Health and Safety Act, there are 23 chapters, 23 separate chapters. And again, guys, you've got to go into it, you've got to read them and see what applies to a drilling operation. If you look at it, let's just go through it quickly. Explosives, well, it shouldn't occur on a drill site, but in some drill sites, explosives may be a problem. Offshore installations would not be something that we would be concerned about. Underwater mining is not something that we'd be concerned about. So we would go through this and extract what we think applies to us. And I've got just one example here that I want to show you. We're not going to go into a lot of detail here because we just don't have enough time. Chapter 8 of the regulations talks about machinery and equipment. And regulation 8.5 talks about lifting equipment. Now, a drill rig is a piece of lifting equipment. The hoist rope, the hoist plug we use, the water swivel, the clamps, the chuck, this is all lifting equipment and lifting tackle. So if you read chapter 8.5, regulation 8.5, it is full of regulations, incredibly important regulations that apply to every exploration drill rig in this country. Can't explain it to you now because we're going to run out of time. But I can tell you now that in terms of chapter 8.5, regulation 8.5, every single drill rig operating in South Africa is operating illegally. Let me rephrase that, 95%. 95% of the drill rigs operating in South Africa are operating illegally. Most of the drill rigs sold in South Africa do not comply with the Mine Health and Safety Act. Now, as a project manager, you need to understand that. What you do about it is another question. We'll talk about that some other time. But you need to understand what the implications of this are on your project. We cannot go into all of that detail now, unfortunately, because we just haven't got the time. But you've got to go through all of these regulations, as I say, interpret them, extract them, apply them to your operation. So let's summarize here quickly, and then we maybe have a couple of questions. The main two pieces of legislation you need to be concerned about is OSHA and the Mine Health and Safety Act. OSHA, you can, to all intents and purposes, forget about, because it's the Mine Health and Safety Act is overpowering, if I can use that term. And it's important to understand the purpose. Go back and read that purpose. Understand where that act comes from. If you understand the structure, you'll understand where to find things. That's very, very important. Very important to understand that the Act is not written for drilling operations. It's drilling for mining. It's written for mining operations. So we're going to read it, take out what applies to us, and then work out how we apply that, what that means to us in our day-to-day operations on the rig. And please, guys, please understand, the minimum requirement is 100% compliance, 100%. I get knocked all the time. I get deep debates with contractors who think I wrote the Mine Health and Safety Act and I'm being unreasonable. It's not me. That's what the Act says. That's what the law says. I'm certainly not going to change any law or try and change any law or circumvent any law in South Africa. So the only option you've got is total compliance. Because if you don't have total compliance, the consequences on you, and more importantly, your CEO, could be really, really bad. So please, guys, if you don't know how to do this, give us a buzz. We've got ways of helping you. But please make sure you understand what these requirements are. Okay, thank you very much indeed. I hope you got some value out of that. Should we, no, I don't know if it's Nolene or Sofiso who's going to be
it's me,
looking after it now. Are there any questions or
yes.
comments?
We've got 5 minutes for questions if anyone wants to raise their hand. I know Johan had a question in the comments there. Johan, if you want to just unmute yourself and you can ask Colin yourself.
Hi, Colin. Thank you for your presentation. Colin, I just want to find out from you, if you sit with a situation where you want to do rehabilitation on your past exploration boreholes, where you typically do the cementing over the mineralized zone which you explored for, but the upper section of the hole is open for influence of water, ingress of water. So there's potable aquifers that is behind casing, but it's not been cemented properly. So there is still access of water into the void itself. Now you come along and you do the rehabilitation over the mineralized zone, and you leave the upper section open for access for the landowner to make use of this potable water. The reason why I mention this, sometimes we sit with a situation where we are denied access onto the farms, for instance, if we want to do rehabilitation for the exploration, and then the farmer says, on one condition, if you leave me the water for use. So I would like to know who becomes then the owner of such a borehole. Would a indemnity form suffice by providing, let's call it transfer in inverted commas, to the farm owner for the use of the hole, considering that you have conducted your rehabilitation over the mineralized zone? Or would you still be liable for that borehole, be it for an accident by the farmer or loss of equipment down the hole after he's been using it, etc., etc.? Thank you.
Johan, that's a great question. Thank you. I don't know what the answer is. I would assume that if you had some kind of indemnity agreement, then the liability would transfer to him. I don't believe that would be hard to do. I can certainly try and find out for you. I'm not a lawyer, so I'm not sure. But what I can tell you, Johan, and I see it frequently, where mining companies and project geos, please understand this, where they've drilled exploration boreholes and they pay the contractor to rehabilitate the borehole, to seal and rehabilitate the borehole. Very, very seldom do I find a mining company with a sealing procedure that is satisfactory. And typically what will happen, particularly in the coal fields, and I can tell you there's coal mines mine into open boreholes all the time, and they get flooded. Because all the contractor does is he gives the guy 2 bags of cement. He takes the 1 bag of cement, mixes it up into a slurry, takes the paper of the bag, shoves it down the hole, pours the cement slurry on top. The geo comes along, looks and says, oh, that hole's well sealed and it's got 1.5 meters of cement in it. That's not a sealing procedure. So wherever you're working on, make borehole sealing, particularly if it's going to be an underground mine at some point in time, make sealing of those boreholes a well-defined part of your project. It's going to cost you money to do it properly, but make sure it's done properly. Johan, it doesn't answer your question, but it maybe addresses another important point that I didn't mention earlier.
Thanks very much for that, Colin. Kohatso has his hand up again, her hand up, sorry. I don't know if you kept raising and putting it down there. I don't know if you have a question to quickly ask Colin?
Yes, I do have a question. Thanks for that. And the name is Khotatso. Thanks, Colin, for a very, very informative presentation. I think you've really encompassed the MHSA quite well. I just want to ask, this is not technically on the legal aspect, but more on how can we make mine health and safety more accessible in the area of small scale mining, for example, where we want to kind of inform and bring awareness to health and safety, because there have been some challenges in that regard with that field. How can we make it more applicable and more useful and more understandable to the small scale mining sector? Thank you.
Gee, Kakatsa, what a lovely question. Yeah, look, I guess the only way is through education. You know, many times I come across guys in the exploration industry who are scared of the Mine Health and Safety Act. Believe me, I was a little bit flippant earlier when I said I read it in bed at night. I do, I promise you. But it's not hard to read. And if you understand the gist of it, then you're okay. And, you know, a small scale miner, what we need to understand with a small scale miner is what are the risks that he's exposed to? What are the risks that he's going to expose other people to? And what are the, mainly, what are the environmental risks that flow from what he's doing? And that's very simple to do. We can do that. I'd love to see if I could help you do that. You could do that, and you can then develop some sort of education program to try and make them aware of that and what they've got to do to keep on the right side of the law. You know, if you consider an artisanal miner or a small scale miner versus Mponeng or Mogalakwena mine, they're two completely different situations. And so all you've got to do really is identify the risk and make sure you mitigate that risk in the right way. So if I can help you, give me a shout. I'd love to see if I can get involved there and help you guys.
Thank you very much, Colin. I will talk to you privately. Thanks.
Cool. That's fantastic.
Okay. Unfortunately, that's all the time we have for you at the moment, Colin.
No probs.
But thank you so much for your presentation there. And I'm sure I wanted to just tell you, Christo Lowe has written quite some interesting comments in the comments if you want to go through them, and you can chat about them afterwards. But yeah, so if we can get Ken's presentation.
Thanks, Natalie.
Sure. Ken, are you with us?
Yes, I am, Natalie. Sorry, I'm just
Perfect.
getting myself sorted out.
No problem. Okay, just to introduce Ken here. Yeah, we've got your the
presentation. You got the wrong way around.
Yes. That's all right. Well, while we sort that out, our next speaker is Ken Lomberg. He is the director of Pivot Mining Consultants, but he is also the chairman of the SAMREC committee and CRISCO. So he's going to hopefully give us some insights here around SAMREC and the project management side of things. So once the presentation's up and running, it's all over to you.
There we go.
There we go. Perfect. Thanks so much, Ken.
Right, yeah. Good afternoon, everybody. Great to be here. I'm going to tell you a bit about the SAMREC code and where it comes from. Let me just get myself. There we go. Okay, so I won't introduce myself any further. Natalie has done that adequately, I believe. So the SAMREC code, this is the top part of the front page of the SAMREC code. It's the South African code for the reporting of exploration results, mineral resources, and mineral reserves. As I'll tell you a bit later, or we'll discuss a bit later, it's a requirement of mining companies that are
listed on the Johannesburg Stock Exchange and is used extensively by mining companies and companies that are developing mining projects. The important aspect being that the ability to demonstrate what is in the ground so that investors can put their money in so the projects can be developed. So this is from the CRISCO website, and it summarizes why the codes are effectively important. So the mining industry is a vital contributor to the economies both nationally and globally. It's an international business where the trust and confidence of the investors and other stakeholders is required for its financial and operational well-being. So if we don't have people prepared to put their money into mining projects and into mines, we won't have mines and we won't have the products, the metals that are produced by the mines. But unlike other industries, we have a depleting asset base. So as we mine, we get less and less. And the other flip side to that is that we know the least about what we're looking at the beginning. At the end, it's obviously mined out and there's much better understanding. And we need to communicate that to the investment community. So transparency is important and a level of trust is required so that people would understand what is in the ground. This is the typical life cycle of a mine or a project, starting with discovery, moving through the different stages of scoping studies or PEAs, feasibility studies, eventually being developed. And once it's finished, then it has to be rehabilitated. Most of what we look at is here in the first part, where it's a project and where it's a mine, and helping the client or helping the investor and also the mine to understand what's in the ground. So SAMRAC, which is one of the SAM codes, is also one of the 14 codes that form CRISCO, which is the Committee for Mineral Reserve International Reporting Standards. And their mandate is to promote the international best practice of the reporting of mineral exploration results, mineral resources, and mineral reserves. And in some ways, it's very similar to the way in which the accounting systems work. So you have the accounting systems that are internationally recognized, and each country has their own, but they all have very similar aspects that are similar, which means that accounts in different countries can be read. In the same way with the reporting of mineral resources and reserves, is that the way it's reported in other countries and other parts of the world is very similar to the way we would report it, and therefore people can make comparisons, which is important so that they can make an informed decision. So why did they develop? Well, fundamentally, it's all about good governance, and we'll talk a little bit about that in a moment. But it's also important that there's the technical excellence, both scientific and engineering, so those principles are brought into the reporting. So we need to make sure that the best science and the best engineering is used, and the international codes are considered as minimum standards or minimum requirements. If you look through the codes, you might be surprised to see what is regarded as minimum standards. But if you see a report or a declaration without those, you just realize how important those things are. And fundamentally, it's right in the bottom left, the reporting needs to be reliable. So the financial sector, people who are doing valuations, they need to be able to rely on what has been declared as a resource or as a reserve. This is the background to, excuse me, why the codes are so important. You would have heard of BRIEX, but you may not have heard of the Poseidon nickel bust and boom, which was about 30 years before that in South Australia. Very similar situation. Deposit existed, people looked at it,
they decided that it could become a mine, and then by doing their public announcements, they pushed the share price up and up and up, and eventually it was way beyond the actual value. And then the share price collapsed, which is exactly what happened on Bre-X. There was some gold showing, but they kept on declaring more and more ounces of gold, and people put more and more money into it, and it changed from a few Canadian cents to about $400 per share. And at that point, somebody went in and said, there's not enough gold here to support your claims, and it all fell apart. So these are the events that have triggered the reporting codes. So because of that, because of the one in South Australia, the Australians started to put together a reporting code in 1971 that was first published in 1989 as the JORC code, and formed the basis of all of the codes that have been reported or have been developed since then. And so there are 13 others currently, of which South Africa is one. And South Africa was one of the first 5. So we were one of the formative codes. And these codes are then used to make sure that we don't get one of these Bre-X situations again. So these are the 14 countries that are involved. I think it's in alphabetical order. Now this one's actually not in alphabetical order, but it's important that we've got countries in Latin America, we've got countries in North America, Europe is involved, there's a number of Asian countries, and South Africa is the only country on the African continent. That's what the distribution looks like. And each one of these codes is very similar to SAMRAC, but we're not going to look at those. We're going to focus on SAMRAC. So important aspects, as I mentioned earlier, it's a minimum standard for public reporting. And when I say public reporting, it's when people put information out into the public domain. I did say it's a requirement of the JSE, and that would then be self-evident, but many projects are privately funded and privately run, and if they public report, they would try to publicize what they're doing and try to attract investors, and they would then put in public domain, and so then it would fall under the auspices of the code. It is only to do with solid minerals, so we exclude oil and gas and water, so it's none of the liquids. And it's important it's there to help investors and advisors and will satisfy regulatory requirements such as the Johannesburg Stock Exchange. One of the critical aspects is the competent person, the CP, and the code also gives guidance to the competent person. So it's not there only to be used in the public reporting, but also assists the competent person. 3 principles that are entrenched in the code are materiality, transparency, and competency. I think that's fairly self-evident what those are. It's also not a set of rules. So they are not a set of rules for every situation that's possible. Considering the number that we're talking about solid minerals in numerous geological settings, I think that is very unlikely to be the situation. It's also not a stick to punish competent persons. Although the competent person must take responsibility and can be held accountable, it's not there to punish them. It's there to assist the development of the project and to promote the project development and obviously mines. There's a vast jurisdiction, as I indicated a moment ago, a huge number of commodities. So we're looking at base metals, precious metals, coal, uranium, gemstones, bulk commodities like iron ore, bauxite, etc. Different mineralization styles. Even within the precious metals, you'll have sedimentary deposits. You might have magmatic deposits. All of those would be covered, and in all sorts of geographies. Part of the important aspect there is that there's a big emphasis on integrity of the data that's used. And that, in the context of project management, is something I'll mention towards the end. So it's a minimum standard.
I keep repeating it so that I hope you don't forget it. And it's all about public reporting for solid minerals. Importance of public reporting is that it provides governance. It also demands the application of good practice. I mentioned earlier science and engineering, the practice of good science and engineering, but it also makes sure that it's done by responsible and experienced people. So the code requires that the competent person is registered with various organizations and has at least 5 years of relevant experience. This is one of the extracts from the code. The section in gold is one of the definitions. The gray is an interpretation, is the code itself, and what's not highlighted is guidance to help discuss what's there. It's also in italics. So public reporting is there for informing investors, and it's all forms of public reporting, whether it's in print media or presentations or whatever. But it's covered, and I said earlier, it's covered important aspect. It's JC and their announcements are important there. Materiality, competency, and transparency, these are the aspects. So it must have all the relevant information, whatever's material, and important here is what might be excluded. The situation is that we don't want someone who's drilled 30 holes and they've got one really good intersection, and it's the only one that they report, making out as though this one intersection is uniform. They need to report all of them. So balanced judgment, all the details should be provided. It needs to be done by competent persons, competent or qualified and experienced persons. And one of the aspects is that they are registered with different organizations. Geologists would be under either the Geological Society or, as we need to do in South Africa, we registered with SACNASP, and there's an enforceable code of ethics. So there's a code of ethics and there's a disciplinary code. So if somebody has done something wrong, it could be reported there and they could be asked to explain. The transparency is there to make sure that what is presented is not unambiguous and is not misleading. So why is it important? Well, it's best practice. I've emphasized a few times the common language. So if somebody says that this is a measured mineral resource of gold here, and you compare it, the investor can compare it to a measured coal resource somewhere else, they've got some understanding of what's there. And that helps them to understand the risks involved. So the concepts are common. They allow the comparison of projects and mines, and they are there to help non-technical professionals understand it. Also, the codes form the basis of valuation. The codes themselves provide the CP with guidance, but it's self-regulated. So the competent person will say, I am competent, and will then do the work. There's no exam in order to, or any other entry mechanism. Being a member of an organization and calling competence on yourself is what the code is about. But the competent person will be accountable, and allows also that there's a risk mitigation strategy if required. The SAMRAC code is relevant to South Africa or Southern Africa, and particularly important here is that a number of aspects that are in parallel. In South Africa, we have the coal guidelines are in the Bureau of Standards, and that is reference from the SAMRAC code. We also were the first to put together some guidance on diamonds, and we said by diamonds we mean diamonds and other gemstones. So the code is important to be practiced in South Africa, and is different to the way the other codes are mandated. For instance, coal, the way it is done in Australia is very different to South Africa because the coal fields are different. so the requirements would be different. So this is just a cartoon trying to emphasize the importance of being able to speak the same language. That's important, that investors can understand that what we are talking about without necessarily understanding all the technical details. And being important that we are relevant and we're not trying to be a square peg in a round hole. So these are the aspects that are all interlinked: the public report, the competent person, and the code. So without these three, we don't have a complete whole. So what it's meant to be. So the public reporting is meant to be signed off by a competent person who takes responsibility for it. It must be based on reasonable assumptions that can be clearly explained. It must be consistent, consistently used standard terms and definitions. Should be unbiased and identify potential risks and uncertainties. It must be balanced and not misleading. It must be in a format that allows the comparison of similar projects. It must be understandable to be reasonably informed investors. What it's not. Using the code is not the guarantee of good work. It's also not a cookbook or a recipe for undertaking mineral resource, mineral reserve estimation. That requires a lot of other expertise. And what is reported is the result of that. And being reported under the SAMRAC code doesn't necessarily mean the project is good. There are many projects that are marginal that are reported under the code. As I said, we strongly linked to the Johannesburg Stock Exchange, and all the listed companies have at some stage presented SAMRAC compliant resource estimates. And where transactions happen with listed companies, they're required to submit competent persons reports, or CPRs, which are then read by the readers panel to ensure compliance. So that's a process that the Johannesburg Stock Exchange has put in place, which is very good to make sure that the public is properly informed. So within the Johannesburg Stock Exchange listing requirements, Section 12 deals with mining companies, and there's a whole lot of aspects that are there, including a section about using the code and reporting of mineral resources and reserves, both for new projects or new mines and on an ongoing basis. So the Johannesburg Stock Exchange also requires that annual reports by the listed companies are reviewed, and where they are considered that they don't completely satisfy the requirements of the JSE, questions are asked and these are improved. So the reporting has got better and better because of this process. So this is what it looks like, the front page of Section 12. So this is just some of the aspects. The important aspect, important here is that the readers panel is there to determine whether a declaration or a public report is compliant with the code. It's not there to determine whether the project is viable or to consider whether the project is a good investment. So it's a compliance audit, not a viability approval or viability audit. So the competent person, competent person's report must comply with the code, must be less than 6 months old, and depending upon whether it's a new listing or a Category 1 transaction, in other words, a company being bought in, different aspects would be required. The competent person's report also requires a valuation section, which would fall under SAMVAL, which I'm not going to discuss, but without having a resource and reserve, it's much more difficult to undertake a valuation. So the readers panel is employed by the JSE. They're anonymous. There's a chairman, and I think there are about 20 odd individuals, each with different expertise, different minerals, different commodities,
and whether it's exploration or mines or geology or mining engineering, they all have different aspects, and they then review some of these documents. It's mandated by the Assam Code Standards Committee, which is the patrons of the Geological Society and the Southern African Institute of Mining and Metallurgy. So there's a whole support system behind all of that to make sure that this is a good process to be undertaken. So going back to the code is this diagram, which is called Figure 1, is fundamental to the the code. And we start with exploration results, which is the lowest form of reporting. And that can be simply a type of intersection that is being intersected. It's 5 meters with a gold grade of 1.5 or whatever that happens to be. And remembering that the requirement is that all intersections should be reported, not just the juicy ones. We have the mineral resources on the one side, and the mineral resources are the in situ estimates of grade and tonnage. So this is 2 million tons at a grade of 3 grams per ton PGE. That's the in situ value. And we categorize it depending upon the level of geoscientific knowledge. So from the lowest, which would be inferred, to the highest being measured, and depending upon how the competent person sees it would be dependent upon that. And there's sophisticated ways to do it, and I'm not going to go into those, but importance is that as you get more knowledge about the situation, you want to classify it at a higher and higher category. Then we have mineral reserves, and those are reported as what is mineable. So that would include dilution aspects, so whatever is added by dilution and what is left behind in a mine, such as pillars underground. And is the transition from resources to reserves is as a result of the application of the modifying factors, which are mining, metallurgical, infrastructure, economic, marketing, legal, environmental, social, and governmental factors. There are others, I'm sure, but these are the broad categories, and that takes it from a resource to reserve. And importantly, a resource, you have to demonstrate reasonable prospects of eventual economic extraction, whereas a reserve, you need to demonstrate viability as of the date of the work that has been done. So it is important, and it is divided into probable and proved. So proved is a higher category than probable. And depending upon what the resource is and how the modifying factors are applied, depends on where we come out in our reserve declaration. So this is once again emphasizing that it's a huge number of mineral commodities which can be reported under the SAMRAC code. The core definitions, there are 15 of them. So these are what is uniform between all the codes. So all the CRISCO codes have the same definitions. The CRISCO published a new template which has one additional definition from previously, but and that will slowly but surely get into all the codes. So these are the definitions that are standard to all of the different international reporting codes. Importantly, the degree of confidence is important, and that's where geologists would come in and consider all the geoscientific elements, such as the way in which the work was done, assays, all of those sort of things, the geological interpretation. And I've mentioned the competent person numerous times. That's one of the other pillars of the code. Competent person must be registered in this country with SACNASP. All geologists, all scientists practicing in South Africa have to be registered with SACNASP. EXA, which is the Engineering Council of South Africa. SAGC, which is the South African Geomatics Council. So those are all statutory.
or be members or fellows of the Southern African Institute of Mining Metallurgy, or of the Geological Society, or of the Mine Surveyors Institute, or Institute of Mine Surveyors of South Africa, or of a recognized professional organization. And there are 31 others from other countries. So people who work in Canada or Australia or Europe or Chile can use our code to report, but they have to be a member of an organization that we vetted before. So that list is published on the website. But the important one is what's in the second block. The competent person must have a minimum of 5 years experience relevant to the style of mineralization and deposit, type of deposit under consideration, and to the activity he or she is undertaking. It's not good enough to have 5 years broad experience. The experience has to be relevant to what is being undertaken. And they are put in at the bottom there. The code requires that a competent person must be satisfied in their own mind that they can face their peers and demonstrate competence in the activity that they've undertaken. So if you're going to be using the code to make a declaration, it's important that you are able to defend yourself to your peers, that you've used a well-recognized approach, and that you're not doing something that's unusual, or if it is unusual, you can demonstrate why it's applicable. So the important aspects there are the accreditation, which I've discussed. These organizations are self-regulatory, so each one has their own code of ethics and disciplinary powers, and those are important because if we're going to hold people accountable, there must be a way to hold them accountable. The other one is the experience, a minimum of 5 years relevant experience. And that can be quite difficult. As I've discussed, these are the different organizations that one can be a member of in this country, and there are a number of others from other countries. These are the recognized professionals from other countries. There are numerous from Canada, few from Australia, Geological Society of London, etc. But they are all been vetted by the SAM Code Standard Committee of people that we can trust. So the competent person, I think I've discussed that importantly, but I'll re-emphasize, you must be able to face your peers and demonstrate competence. Now, one of the questions that gets asked regularly is how do you get 5 years relevant experience if you move from one commodity to another, or you change to look into different deposit? The competent person, we know, has got a basic qualification, and from a geological aspect, we consider that to be a degree with the relevant experience. They need to be registered, and they would need to have the regular training. Now, the analogy is with the aviation industry, where a commercial pilot has got a lot of tickets behind his name. So he becomes a private pilot to start with. He gets in various qualifications, night ratings, multiple engine ratings, instrument ratings, and he gets rated for different aircraft. And he gets checked regularly to see whether he's still able to fly. But if he decides that he's going to be, instead of flying 737s, he wants to fly 747s, there's a process of changing his competency. It doesn't mean he has to go and learn to fly again. It means that he has to take some steps to make sure that he can fly the other aeroplane. And the same with us as competent persons. We would make sure that we have got the basic skills. And if you're going to go from looking at a precious commodity, precious metal, and then you're going to go and look at a base metal, there'd be some things that you would need to understand about the base metal that you might not have understood about the precious metal. So then you would gain that extra experience and then be able to consider yourself as a competent person. So it's important to understand where
responsibility and accountability come in. So the work we do, we can be held accountable for that. But the public report remains the responsibility of the board of directors, because they would publish probably aspects of what we've presented into the public domain, and they need to make sure that that's firstly, that whatever is regulatory is required. So if it's a Johannesburg Stock Exchange, they need to provide the JSE what's required, but it must also fairly respect the work, represent the work that we've undertaken. It's advisable that whenever information is published, that you as a competent person get to provide approval, so that you make sure that the content and context is correct, covering these principles of transparency and materiality, so that things that are not, that shouldn't be left out, aren't left out. And so the JSE requires that on all of their aspects, all of their declarations, and I would suggest that if you ever do a declaration, you do exactly that. So the competent person is personally visible and liable, so we can be held accountable, but the accountability doesn't necessarily mean being punished to the nth degree. The situation may be that we've erred and neglected something, and we're asked to review the reporting and correct some obvious mistakes. That would be a form of making sure that things are done properly. There may well be some retraining required. We hope that there's not a situation where a person's membership of that organization is terminated or suspended, because that has very severe consequences. Where it's happened in the past, people's reputation has been damaged virtually for their entire working career. So the buck stops there, stops here. So we need to be sure that we can take on that responsibility. What happens if we make a mistake? Well, we're probably going to be embarrassed. We might be asked to correct it or redo the work. We might be asked to undertake some training or be mentored. We might be suspended, but hopefully we wouldn't have our registration revoked. But the reputational damage may be much more severe than we would like it to be. We wouldn't want to be in this situation where we stand on the street corner looking for more work. Now, typically when we report a reserve, we are considering a number of people with different disciplines, different expertise. It's unlikely that somebody who has all the expertise, unlikely that a geologist has sufficient experience and training to be a mine engineer or a metallurgist or environmental scientist. So a lead competent person brings all of these people together and they form a team. And so then you have what we call a lead competent person who then reviews the information to make sure that it is reasonable. The code of ethics is important and must be enforceable. We've spoken about recognized professional organizations and the reciprocity that we have, and they have disciplinary powers just like we have disciplinary powers. There is a complaints procedure which goes through the SSC before, so they look at it, consider whether it's reasonable, and then it goes to whichever organization that person has used as their the organization from which they declare. The important thing is that complaints have to be filed. They have to be filed in writing, and the complainant has to provide all the details before that review can happen. It doesn't happen very often, so it's taken really seriously when it does happen. The question that we might want to ask is, am I competent? And one has to judge it for oneself. Generally, there's a lot of common sense, but importantly, we must be able to face our peers in the situation. Here are some examples of what I've seen, the goods and the bads. Going on a site visit is important, but it's useless just to be standing outside a core shed and looking inside. We don't want to be in courtyard or the boxes that look like this. This is probably much nicer.
core boxes like this, wooden core boxes, they work, but they might not last very, very long. These are some markers that I've seen in the field. Some of the core can get damaged with time. We don't want to be in situations like this where the core boxes are rotting. Similar here, core boxes that have been dropped all over the place. There you can see where cutting down the center of the core hasn't transmitted from one core to the next. These cores aren't the same size. These ones are completely juxtaposed. We've got some grinding. These are things that you would then use to decide how valuable the data is. So as a CP, we would supervise what's there. We'd be prepared to be challenged. We would need to be named so that we can take accountable. And where there's public reporting, we would want to approve it. But importantly, we must be in the process from the beginning to the end. Here are some examples of way in which reporting was done. So this is a reporting where there were some changes to the way in which it was done, and suddenly the share price dropped because of the way in which it was done and the way it was publicly put together. Here is Nick Holland from Goldfields. He discusses how they present their resources and reserves. This is from 2015, so it's not necessarily completely appropriate now, but he's saying that they use different metal prices for resources as compared to reserves. This is a case of Keaton Energy where they put together a mineral reserve, and they'd used a scoping study or a concept study to make the declaration. According to the code, the requirement is a pre-feasibility study or a better. So they had to publicly admit to it, which is very embarrassing for them. That was the document that came out. Sometimes these things happen which shouldn't be happening. Senko Gold was, I would say, attacked is probably, or sabotaged perhaps, by a company called Muddy Waters, who tried to tell them that what they were doing was wrong. There may well have been things that weren't perfectly correct, but Muddy Waters was also trying to drop the share price so that they could buy it and wait for it to recover and make some money. So one has to be careful about people's motives from that perspective. Technical studies, as I've said, the important one for us is the pre-feasibility study, and that's for a project. For a mine, you would consider life of mine, but importantly, it has a similar level of technical inputs. These are some of the definitions that we have. Scoping study is only an order of magnitude. A pre-feasibility study is a little bit more comprehensive, and various options are considered. And we consider this the minimum requirement for determining or declaring a mineral reserve. Importantly, when you're dealing with economic factors, you're going to have it timed because you want, or dated, because you want to make sure that your commodity prices are fixed and also your other costs are fixed. Feasibility study was even more comprehensive than a pre-feasibility study, and generally looking at only one option. The codes, what we've put into the codes are a number of tables at the back to help the competent person to be able to demonstrate what's important or how they've got to there. So what is a scoping study, feasibility study, what the basis of that is, what the levels of cost or engineering inputs are. Typically when somebody wants to know about a study, they normally only want to know about the costing, but it's important that the amount of engineering is considered, the way it's approached, the things like the tolerances on the accuracy ranges, as well as the contingencies. So all of this is in the back of the code. The code's freely available on the SAMcode's website. And the same with CapEx and OpEx, similar approach, giving it more than just one or two aspects in order for you to decide what's important. going back to why the code is important, this is the life cycle from discovery to project commissioning. Here we've got the different types of reporting: inferred, indicated, measured, mineral resources, proved and probable. And here in blue is the way in which it is related to valuations. So valuations where you've got reserves, DCF, discounted cash flows, and market comparisons, where it's a little less information is available, market comparisons, and multiples of expenditure. So risk and reward, obviously, the further down the path it is, the more advanced it is. So there is more value and the risk has been reduced. And in some ways, as we go up this curve, which is where we would go from resource to reserve, we would reduce the risks and help the investor understand that. So that's at the level of engineering that would be undertaken at the different levels. But coming back to what this seminar is about, is public project management. And so what I've done is a very simple cartoon: project initiation, project planning, execution, and then the closure, and what aspects are relevant. So it's important to know what the key objectives are and develop a strategy. So as far as public reporting is concerned, is this a maiden resource estimation or reserve estimation, or is this only what the exploration results are being reported? So importantly, defining what that is. So the competent person or the company needs to decide what those are, define the course of action required, make sure that you've decided what detail is required, get the necessary resources, personnel and funding in order to execute it, and monitor the progress, and if necessary, manage the exceptions and the variances to that plan. And then obviously to complete the project, to make sure that you've met the requirements that you set out in the beginning. So the role of the competent person is primarily as a technical expert. However, in many cases, the competent person is also used as the project manager. So then that person would develop and achieve, to make sure that you can achieve all the milestones, whatever those happen to be, making sure all activities are aligned with industry requirements and standards. And that's where SAMRAC would come in. You can see what the requirements are, you can develop your plan accordingly. The salient procedures need to be properly put together to meet the objectives. And remember, I said right at the beginning, data collection. So project management, a big part of it is making sure the data collected is consistent, that the same methods are used throughout, that the results will be accurate, and where assay information is being used, that there's a level of accuracy and precision to that data. So managing the data collection to ensure that it meets the required standards, a very important part of managing a project. But it's not generally going to require us alone. We would collaborate with various professionals, but as the competent person, we're in all likelihood going to coordinate all of these activities. And we will then need to communicate those to our principals to make sure that we meet our milestones, the progress, and obviously to make sure that we are able to finalize the work that we have set out to do. I think that's all for me at the moment. Are there perhaps any questions?
Thanks so much for that, Ken. It was very informative. We did have some questions going on in the chat. I see Christo Lowe had a question for you, Ken. Christo, do you want to unmute yourself and ask Ken? Yes, no? I can ask on his behalf then, maybe, if he's having issues. He asks, can these reports be made available to the public, to the public, academic institutions and persons working for the state who are currently studying or working on a project, but the client didn't submit all the relevant information to that institution? In essence, how confidential or private are these technical reports submitted to SAM codes?
Okay, no report is submitted to SAM Codes. So SAM Codes doesn't have a library of all of these reports. It only provides the guidelines upon which the reports are published or are prepared. The public reports, many of them are available through the internet. There is an aspect that we have put into the code where somebody would like more information. They are at liberty to approach the company and request that information. They might have to motivate it, but they are, the code does say that they are allowed to approach the company, and it must be provided in a reasonable time. As in, you can't ask this year and get it in 2 years' time. So there is that aspect, but many companies would like to have the information available in the public, and so freely provide that, even if you have to request it directly from them.
All right, thanks so much, Ken. Hopefully that answered Christo's question. We have another question in the chat from Johan, and then we'll come back to Thomas with his hand up. Johan, would you like to ask Ken your question?
Hi, Ken. My question pertains more to the SAM mock code, but there is a little bit of relevance to what you also mentioned here for the SAM codes. If you make use of a competent person from overseas consultancy, for instance, and they are affiliated with some association, what you've listed, which is almost the equivalent to the South African associations, would they be allowed to do a competent person's report on a SA resource being overseas, and considering they are not registered with either GSSA or SACNASP, etc. in South Africa? If you could please comment on that, please.
Okay, Johan, the situation is that all those recognized professional organizations are equivalent according to SAMRAC to SACNASP or GSSA or SIMM or EXA. So they would be considered equivalent. So somebody who was registered with OzIMM or with one of the Canadians would be allowed to report, use the SAMRAC code to report on mineral resources or reserves in South Africa, but they would have to make sure that they obviously followed the SAMRAC guidelines. Where they were working in the country, they would obviously have to be have got work permits and the like to make sure that they are legally working in the country.
No, they're not working in the country. They would be data sent to the other side, if I can call it that way, and then compile the competent person's report. Would that be allowed?
That's allowed according to SAMRAC, yes.
Thank you very much, Ken.
Pleasure.
All right, thanks for that, Johan. Thomas, you had a question?
Yes, Ken, and maybe to the other team members as well. With my new role now of doing consulting, you sometimes with this project, you meet investors that really do not know anything about the work that you need to perform. If you advise a client on, I mean, with the just a desktop work, that the place that you are referring to is not holding, or the minerals are deep, it will be too much expensive to undertake the project, and the client insists that we carry on. Can the client hold me liable if the project is not completed due to some those I mean the identified risks that we have already said in advance, or should I simply recuse myself from taking that project?
I think, Thomas, you're asking one of the really tough questions about being a consultant. Consultants tend to be quite conservative and don't want, maybe risk averse. There have been, in my career, I have done work on projects which I was convinced would never see the light of day. They are mines today. So because we think it won't work, doesn't mean it won't. I think one has to allow the client to decide what they want to do. I suspect that that they can't, in a legal sense, I don't think you could be held responsible as long as they are providing instruction.
Thanks very much.
Pleasure.
Thanks for your question there, Thomas. Are there any further questions for Ken while we still have him? I think you're off the hook, Ken.
Wow.
Thanks again so much for your presentation there. It was very, very informative. And you're welcome to stick around and listen to our last presenter for the day.
Thanks very much.
Sure. Graham, are you around?
I'm here, I'm with you.
Perfect. How's it?
Very well, thank you.
Would you like to share your screen while I introduce you so long?
Yeah.
Okay, so our last speaker for the day is going to give us a bit of insight on remote project management. This is Graham Duncan from Minerum Consulting. He's a senior geologist. And that's about all I know about Graham, because I don't think we've ever met in this small community. But yes, when you're ready, Graham, it's over to you.
Awesome stuff, thanks. I'm just using PowerPoint and it's sort of just taken over my screen. Can you guys all see the presentation?
Yes, we've got you.
Awesome stuff. Okay, thanks very much, Natty. I appreciate it, and I'm grateful that I could have the opportunity to speak to everybody today. I obviously work for Minerum Consulting. We are an exploration company, do exploration work throughout Africa. And I just wanted to put together this presentation and share with everybody some of the principles and things that we've found in general in remote management of projects. I think one thing, as opposed to other industries, when we speak about remote project management, we already have a bit of an advantage as geologists and consultants, because we are automatically, part of our job involves doing that. So I think everyone develops these skills in a way, but it's a case of develop them sooner rather than later is always beneficial. So we actually like to call these type of projects where you completely remote operate things as Xbox projects, because if you're on the receiving end of being remote managed, it feels a lot like you're a little person in a computer game getting told what to do. And obviously that's not what you want. So let's try and have a look at some of the things that you would want. So as a basics, I know there has been some good talks earlier just defining a lot about project management itself, but I just have a brief introduction to that. So what is project management in general? So obviously it's where we want to identify the requirements of a project. We want to be able to define the strategy, the goals, the requirements of that project, and really just set those battery limits for what we're going to do, because a project obviously is supposed to have a definite start and a definite end and deliverables within that range. So part of that would then be addressing the needs of that project, whatever the expectations are, the deliverables, what's supposed to happen, and who's going to be involved in that process. And of course, then you have to, your job as a project manager of that specific project would be to integrate and communicate between all the people that are involved. The PBOK, Project Management Body of Knowledge, tends to speak about stakeholders, which obviously it's not your investors or your clients, it's anybody who has a stake in that project. So that's all involved personnel. And so obviously you need to coordinate all of that, and communication is really a big key, especially in the context, and we'll look at it now, of remote projects. And you want to do that in order to achieve the objectives, whatever it is you need to, whatever deliverables there are for that project, that's what we're working towards. And so to do that, it's a continual task of trying to manage the different components, the scope, the quality, the schedule, the budget, the resources, the risks. We need to continually balance and manage those constraints in order to achieve the end goal. So what are the type of questions that we would then ask on a project? Well, you'd say, where are we currently? Where do we want to be? How's the best way of getting there? how are we able to monitor our progress along the way. And as they always say, if it can be measured, it can be managed. I found it quite interesting that Julius Malema has a height of 1.6 meters, but good luck managing someone like that. So the aim is to manage things. Not everything can be managed. But in terms of being able to manage the process, we obviously need to start at the top in our high level view. And that's what the little images there are just showing. Got a nice little step progress, how you need to go through the different steps, your vision, your goal, your strategies, and working through those and developing those before you start a project. Obviously that will help for the project to be successful. And for each one of those attributes there, the vision, the goal, the strategy, these need to be defined in, as the other graph there shows, specifically. They must have measurable outcomes, must be realistic, must be able to achieve these things. And of course, there's always a time component when we're dealing with projects. So the strategy and the vision and the goals, these define how we're going to take the project forward. So just give us a breakdown of that. I gave us an example here. So when we talk about a vision, that's where we want to be. That's where the project, we want that project to be. So being fortunate enough to stay down in the Cape, I used a Cape example. So here we have Table Mountain. You want to be on the top of Table Mountain. That's our vision. The goal, well, that's a primary outcome that you want to get from this project. So for instance, you can view that as our GPS. It's the thing that keeps us on track to being able to achieve our vision. The strategy can be developed in different stages or phases, but essentially it is the map, the roadmap that allows us, tells us we've decided how we are going to get to achieving the goals and the vision that we want. And then obviously you need to put that into action, and that's our action plan. But in a mining context, we can equate that to someone wanting to, for instance, produce a manganese mine in South Africa. They then want to establish it. That's their goal. They need to have some mine in order to be a producer. So that's the goal. And the strategy would be developing the project. So you go from exploration and you develop the different stages through the exploration program. We've had several talks detailing those quite nicely for us, but all those different stages would form part of your strategy. And then of course, you need to implement that strategy. And that's generally where our project management plays a more active role. Obviously, your project management will involve all of these things, but actively, one would work in the implementation phase as well. People often spend a lot of time on the action part or the implementation and not a lot of time on the other three components. And although that gets you started quickly, it's often very short-sighted, and projects can fail just because we haven't had that foresight of where we want to be and how we want to get there. So in linking the strategies and the goals that we've come to for the project, how do we link that to the actual project itself? So obviously, the size and the scale of the project depends on what we've decided. Are we going straight for a feasibility study or whatever it may be? It depends. But important in a mining context is what is the objective we're trying to go to? For instance, you could be looking at an exploration project, but are we doing exploration because we're trying to get funding on the stock exchange, or is it private funding? And that will dictate the route that you're going to take with this project, from the high level overview all the way down to the very individual choices that a project would have. We then have another alternative. Maybe the exploration project is not going to require funding. Maybe it's supposed to go directly to mining. That's the objective. That's the vision. So in that case, you would make slightly different decisions along the way. And typically, and why I mention it now is a geologist, the typical geologist starting out in industry or working in the industry, and they won't always be involved on the very high level project management side of an entire project. But they could still have project management principles that they need to apply at the level that they operate. So you can have this nested structure of project management or project managers, each person managing a specific aspect. And so from a geological perspective, what you would encompass in your project management field would then be typically the drilling, the sampling, modeling, estimation, that type of thing would fall within the project range. But it's always important to keep in mind the overall objectives. And that will come out quite strongly, I think, as we go through it. Sorry, I just put up that thing there about classifying our projects. Depending on how we've got our strategy, we would then need to dictate, well, that would dictate what would happen on the other aspects, the scope. If it's a big scope, a small scope, simple, complex, how long, how short the timeframes are for that particular project. Costs can vary, obviously, depending on the specifics. But what you want to avoid is running into a situation, as the cartoon illustrates for us, where there's no beginning and end to this project. It hasn't been clearly defined, and that can come from whether either your strategy wasn't clearly defined, any one of those higher level elements, or it can be as specific as your scope or a specific aspect, and it just allows for this very open-ended type of project, which is actually detrimental towards achieving the outcomes. It means something is not right along the way. So in short, obviously I wasn't going to go into too much detail, but our objective in project management as a geologist would typically be, you need some kind of plan. And so that project management plan would consist of, and these are the typical elements that one would have in a project management plan. You would start out with your background. What are we going to do? As we discussed, these even fall in line with developing your strategy and your visions and your objectives. So what are we going to do? What should we do? And what is included and excluded from this particular project? And that's your scope. And what you want to get out of those type of questions is your work breakdown structure. You want to be able to say, these are the things we're going to do. These are the tasks we're going to look at. And it's always beneficial to at least have a list of what is not included. And you should have reasons for why something is not included. Then, of course, your scheduling. Once you know the task that you're going to do, we work on the schedule, get together a management plan for the timeframes that are associated with the project. And so you would typically say, okay, when are we going to do this? What is the duration of each project? Is there a sequence to the different tasks involved in this project? That's the type of thing that you would look at in the schedule, and you'd like to get at an actual plan for the project. You can have it in detail on the work breakdown structure level. You can also have it in a more simplistic version. Often that's more beneficial when communicating that schedule with people. Of course, that leads you then to the cost component. You now know what you're going to do, when you're going to do it, how much is it going to cost us to do that. And obviously we want to cost each of the elements appropriately. That gives you your budget for the task, for the project. Then we look at the quality. Now, all of the first, say, three, scope, schedule, and cost, are what people normally focus on when they think of project management. But it's quite often that the ones that follow now, quality, resource, communications, risk, procurement, and our stakeholder management plans, are neglected. And that's really to the detriment of a project. It is more work up front, as in it's all project management and planning, but it ultimately leads to a better executed project. So in terms of the quality, when we talk about a quality management plan, what is that? Well, that's what are we going to do and to what level? How high a level of accuracy or whatever it may be, what's the standard that we want to work against? In a mining context, we at least have prescribed standards, but you need to know, are you working on an exploration program that's at a scoping level? Is this going through to feasibility? What is the planned levels that we're going to do? You're not going to be doing exceptional amount of work. I recall in the first talk we're speaking about all the different plans, whether you're going to do the hydro study at this phase or at another phase. Depending on what the scope of the project is, depends on the quality and the level of work that you're going to work towards. So that all forms part of our quality management plan. Then resources, not to be confused with other resources in geology. Now, in this particular project management context, we're looking at people and equipment. What type of resources does the project require? Who are they? What positions or roles are they going to fill? And whether it's equipment or not, you need to have a good idea of what's required for the project. Then the communications management plan, and this really is a big focus of remote operations. This is where you would then typically ask who needs information, who needs it to be communicated to them, when, how often, what type of information. And it is very beneficial to have all this information laid out, the plan of how you're going to communicate beforehand, because that enables you to have those systems and structures in place. Because often what happens is you take that aspect for granted. You think, okay, well, here's my client, so-and-so will communicate with them and they'll give them the information that they need when they ask for it. But that really doesn't build towards a collaborative project. And that's really what you want. You want everyone who needs some information to have it easily accessible to them, and there's a system in place or a communication strategy in place that allows them to get that information. Might take it for granted, but it's very valuable to lay it out. Of course, then we have our risks. I know Colin took us through a lot of the risks, and that is a key aspect of any project management plan, especially in a remote context. What can go wrong? Plan for that. Plan for how we're going to manage the things that can go wrong and prevent potential risks. Procurement plan, where we're going to get things, how we're going to get them, what quality are we going to get, do we need to outsource certain things or not, lay that plan out. And then our stakeholders, which is of course anybody involved in the project, what are their needs, what influence do they have over the project, how are we going to manage the interaction between the different entities. So that's general project management. How do we apply that to a remote project? Well, you can have a look at what is a remote project. Now, there's obviously different types. So just as definition phase, remote project is any application of normal project management skills through to a situation where you have team members or equipment or whatever split spatially, so in different locations. There are different types, of course, of remote projects and with remote teams. You can have a team, fully remote team, a hybrid team, or a flex team, as they've termed it. And obviously, a fully remote team is, as the name says, that's where people, equipment, and everything involved in the project is just split all over the place. Typically, different places, different countries, even, which makes things challenging, but as long as you have a handle on it, it can still be a successful project. You can have hybrid teams. Hybrid teams are obviously where you have some people in one location, maybe in a central facility, an office, for instance, and another set of people, another team maybe in the field. Typically, as a geologist, you would deal with that type of setup. You have your office-based operations and your field-based operations. And then you also get, which is probably the best type of remote team, if it's possible, is your flex team, your flexible team, where you have people who can be both in one place and then go to another place. So they can be in the office and they can go and visit the field. And why we say that that's generally the best, if possible, is because you would want to be able to take the knowledge or take the skills from one location and transfer them to another. And the best way to do that is a face-to-face or with the person. And one of the biggest things you would find in a remote project is trying to get, say, senior skills or a competent person, for instance, who needs to check certain things, get that information down to the site team so that they are applying what needs to be done. And the best way is in person. The best way is there, checking, seeing, making sure. But where that's not possible, we look at a hybrid type situation and then a remote project that we are managing. And of course, when doing that, there's lots of factors we need to take into account. Typically, you would look at maybe a language difference if it's in another country, different time zones to what you're dealing with, the jurisdiction or the legal side of things can vary, the culture in the place that you're working with, and all of these things you want to have factored in to your plan beforehand as best as you can. But of course, we can't account for everything. And so that's where some kind of flexibility comes into play. And really, there's many project management styles. I saw one of the other presentations, I think it's tomorrow, broke these down quite well. So I just focused on the one that tends to work very well for a remote project, and that is what they call the agile project management strategy or system. So typically this setup is applied for like a software engineering company or code or script writers, and it's designed around the concept that you have obviously a big overall objective. You break things down into smaller tasks, but specifically not just a breakdown, but specific tasks that can come to a conclusion. So this task, I finished this one thing, it has a specific set of objectives, and it can be checked against a standard. So the small tasks work all together to produce the final thing. So you're not having big operations happening at a time. You're having little, small, confined, easily manageable tasks. And this approach allows for, as they call it, bug fixing, but in a geological context, it would be our checks and our verifications on making sure that the quality that we want from the project, be it a drilling program or whatever it is being achieved. Typically, give an example there, I'd say you have a normal work breakdown structure. Let's say that we've got a drilling program and it takes this amount of time. But in the agile project management setup, you break that down a little bit more. You say in the drilling program, we have the physical drilling, we have the logging. Maybe you even break down components of each of those and say, how long is it going to take to do the alteration logging, the lithological logging, the structural and geotech side, the mineralization, and you break that component down. In the sampling, you also break that down again. You say maybe sample marking, core cutting, whatever the components may be. It's not always necessary to go into that level of detail, because the aim is not to just split everything down into the most infinite number of tasks that you can think of, because then you run the risk of micromanaging a project. But the aim is to have tasks that can be easily checked, because that allows for your flexibility. For instance, if you have a drill hole and it's getting logged, an alteration log, when does that normally get checked in a typical exploration program? Well, most likely the junior geologist logs it at site. He has his log, he scans it in or does it on a software, on a tablet, and it gets sent through to the office. And the senior geologist who's responsible for that quality control probably only looks at it halfway through the program or near the end of the program. So you've now, if there's a problem, you have very little time to fix it. And that really cuts into your flexibility or your agility in the project management scale. So what you would want is you'd want to be able to have those checks done on smaller components. And that's really a key factor when dealing with a remote project. You want to be able to adjust the program as the situation develops, because physically you are not there, you're not able to deal with it yourself or make decisions there. You want your project team to have been set up in a way that they are able to adjust or move around, adapt to the changing circumstances. So really, we want to focus on this approach. It has its own advantages and disadvantages. Obviously, it's highly flexible, as we said. It works well in a remote setting, and that's just really if you allow that communication plan that we spoke about earlier to flow, so that people know what they're supposed to be doing, the tasks are clearly defined, and they're easily able to be checked. It works well when you have split teams, as we said. You have people in the office or people in the field, or no physical connection between the two. It actually allows for less meetings. I know meetings can be a massive time waster, especially in the corporate environment. But when you have smaller tasks, specific things that you need to work on, project meetings are specific to that. So it's more a case of feedback, direct inputs, move on. Saves you a bit of time there. It allows for very good quality control. That's the objective. It wants to do that. And it empowers your team in the sense that they don't necessarily have to be micromanaged. It's more like the project manager is the conductor of the orchestra, and each person is doing their own thing. They know what they're supposed to do. They've got their musical notes in front of them. They know what needs to be played, and they're left to do that task. And they only need to check in at defined little intervals when they finished something. So that's all good and well. It's called Agile Project Management Plan, and that's why, because you can dodge little obstacles fairly easily with very little change to the original plan. The disadvantage is that doesn't always work out. You can have major mess ups when you're dealing with trying to get people to coordinate their efforts if you've given them all little tasks. So the disadvantage is, if not done properly, it can take a lot of time. It can take a dedicated person to be able to coordinate all of this stuff. If the tasks and things aren't well defined, you can have mess ups, as the image clearly shows. And then it also, of course, runs the risk of being micromanaged if it's not managed very well. So the aim of this type of strategy is not to be a policeman, it's to be the coordinator. Okay, so with that in mind, we previously spoke about all the different aspects of project management. So I'm just going to go through them again with just some added notes about how that applies specifically to a remote project. So in the scoping phase, obviously you have all your normal elements of scoping, but emphasis should be placed on what are the objectives we're trying to achieve. Because if you clearly have those as they're small components we spoke about, it's easier for you to juggle around with them. We often speak of in drilling, you can't just have your old school style of 50-meter grid. We're just drilling holes on that and that's it. Stick to the plan, and at the end of the program we check how well we did. You want to have a dynamic plan. You want that flexibility involved in your project, especially if you're not there, because you want to be able to change the plan according to the information you got or the environmental constraints. With the drilling program, you drill a hole, you get certain results from it. You want to be able to adapt your plan. So you need to build that into your project management. When you're planning everything, you need to have that, consider that as an aspect. Consider the changing local conditions and whatever local limitations there are. So that should be included in the scope. Then on the scheduling side, again, obviously all your normal project management components apply, but generally, and it's just a case of the system that you're working with. You're working with people that are remotely connected to you. Things can take longer. You're dealing across borders. You will have some jurisdictional issues, maybe delays. These things should just be taken into consideration, and in general, you would allow a little bit of extra time for these unforeseen issues that may arise. On the costing side, costing, quality, and resources. Costing obviously is directly related to what you've scoped. So just need to allow a little bit of flexibility maybe on the costing. Maybe you're dealing in different country, different currencies, that type of thing should be considered. On the quality side, obviously in geology, we're very focused on the quality, and that's good, but it needs to be balanced against what is achievable. What are the objectives and what is achievable? So, you would typically use systems or whatever to ensure that you have quality. We often, especially with core drilling, we use graphic systems. I'll show you in examples I've got coming up, how useful that can be, especially in a remote context. Visuals play a big role in how we work. And also express a lot more than you can write in an SOP. So it really helps to have some visual components as well along the quality side. And then, as we spoke about, the general structure of an agile project management system is designed around getting quality out and checking it along the way, so you get those checks earlier rather than later in the program. Then on the resources side, obviously we're talking specifically about people and equipment, but on the people side, because that's a more challenging component in a remote project, you would want to coordinate the efforts and make sure that you know exactly what's happening at what time, because you're not physically there. Typically, if you're on a drilling program, it's very easy to get that type of information, schedule when this is going to happen, the surveyor is going to come, and this drill rig's moving here. But when you're not there, it's an added component that you need to consider. And related to that is, who are you using at site to do those tasks for you? Because, you know, around with all the influence that Corona has had on exploration projects over the past few months, a lot of times people couldn't get to site, so they had to use someone else to do the work there, a local entity, a local person. And you need, we're speaking about reciprocity between organizations. Not every person is now qualified to be able to do that particular site visit or whatever it may be on your behalf, because you're not there. So always something to take into account. And that all falls under our resource plan. And having it known up front, who we're going to use and what we're going to do, really does help with the development of the plan. So communications, as we said, this is definitely one of the key aspects of remote projects and how we deal with them. It really forms that backbone to how the system is set up and implemented. And really the success of the project can hinge on how well things are communicated. One thing that should always come out clearly is what you are trying to achieve. So when communicating the ideas or the task that needs to be done, you need to be as specific as possible about what needs to be done. And so we say that you have a communications plan, and that really answers the questions of who's going to do the project, what is going to be done on the project, what does that person need, information do they need in order to get that job done, how are they going to get that information, how often are they going to do it, and really what do they need for that task, and how, as I say, how is it going to be communicated to them? I mean, we think, oh, I'll pick up the phone, I'll call the person, but is that the best communication strategy? Is the clearest way? Normally it's a combination. You need to have structured layouts of how things are going to be, what needs to be done, talk, and it really helps engage them in the process. One needs to make sure that there's regular communication. It's not just all ad hoc. Obviously, ad hoc communication has its place, things happen, but you need to have some setup. Verbal communication is followed up with written. And the reason we say that is you can explain something to someone very clearly. You think it's all clear because you have it clear in your mind, but that written follow-up just allows for that extra layer of clarity on what needs to be done. And of course, when writing anything, be as concise as possible. What else do we have here? Okay, yes, the single set of instructions rather than multiple. We often fall into this trap. Something comes up, I want to tell the person about this, so send an instruction. Oh, and then also this, and we send an instruction. Oh, and they should also consider, and we send an instruction. That makes it very difficult for a person in a remote context to put together. They either need to spend twice as much time putting together all the little requirements than they would normally, or some get lost along the way and they don't know exactly what task they were supposed to do, or they left something out, and so it can just create a bit of confusion. So a typical rule for communications should be a single set of concise, clearly laid out instructions instead of multiple emails or phone calls or whatever it may be at different times. Moving on to our risks and procurement plans. So when developing our risk plan, often like to say that the risks plan, especially in a remote context, it has both pros and cons. Not everything about it is good. So typically in a remote project, you might think, okay, I have lower risks because there's less travel. I'm using local people, they know the environment well, they are aware of the issues there. Maybe you're working middle of Central Africa. The people you're using there are local Congolese or whatever country it is, skilled, they're knowledgeable, they know about the environment, they know about the snakes or whatever it may be there. So less chance of the injury from that aspect, yes, but at the same side, you are not aware of all their level of safety or their understanding of the check requirements, that they have in their own mind. So you are reliant on the fact that that person has got that training. They know exactly what's happening. And I mean, for instance, if you have someone who's gone on, Colin offers a very comprehensive course on safety, and really you don't know if the person that you're using has gone through something like that, or has been working on a mine in a South African context where they've entrenched in them this idea of exactly what needs to be looked after, the different aspects of safety, the risk assessments, the toolbox talks, PPE, checklist, contractor files. You know, you don't know how much of that they know. So it's very important that you have those structures put in place beforehand, put in place for your site team. So you would have to have them away. We often use a cloud-based system where you can, all your toolbox talks, your risk assessments, all of that is easily uploaded, because the objective is to ensure safety. It's not to add to the tasks that the person needs to look at. You don't want to have a case where you've got so much bureaucratic paperwork that your site team needs to do that they just fumble through it, ignore it, just put up the minimum requirements, because that's often what happens with safety. People just ignore it because it's cumbersome. So the idea would be to allow for safety and a way of monitoring the safety through your risk assessments or whatever it may be. You want to allow that to be as user-friendly in essence as possible. Another negative side of risks or in a project, in a remote project, is that you're probably having different people, and you always run the risk that your data or your reporting lacks that continuity flowing through it. The project manager, or at least the geologist in charge, or the project geologist, should be the person who's ensuring that. And you should at least have that idea, that thought built into your plan of how the project was going to progress. Someone needs to ensure continuity. The second last aspect was the procurement. Obviously, you can get your equipment or whatever geological requirements you have, sample bags or whatever it is, locally. That can be advantageous. It's easy. You get a local company, might even be cheaper, but always need to be aware of the quality, because you are not physically able to be there and check the stuff. It's always good to have standards in place that you can measure things again, a standard thickness for a sample bag, standard way of joining it, things like that. Just have that information available and given to your site team so that they can check that quality on your behalf. Last one is the state. As we said, that's anyone involved in the project. And so really the most important aspect is collaboration. In our project management strategy, in everything that we're developing, collaboration really is the key. And when you're working with a remote project, you are collaborating with people and you are not there. So you need to make sure that everybody has the same understanding of the vision of the project, the goals that went into it, the specific strategy, and that data and that information is shared amongst all their people, because we don't want to have a situation where you have people working in little isolated groups. That doesn't lead to a successful project. So you need to allow, obviously within a reasonable degree, I mean, not everyone needs access to all the financials of the project, but you need to make sure that the general concepts, the aims, what we're trying to achieve, how we are going about it, is communicated to the essential people. And that needs to be done verbally to explain, but of course also in a written context is much easier and people can refer back to it. Let's see if I missed anything there. No, I think that's really about it. The advantage, of course, when you're using like an agile project management strategy is that you have smaller tasks, and therefore it's easier to communicate what is required for that task, and it's easy to show how that links to the bigger picture. So that is, of course, just why that's preferred method for some kind of remote project management. Don't allow people to forget about that bigger picture, even if they're on that smaller task. And one thing we often tend to forget when dealing with a remote team is that of culture. And we're not specifically talking about the cultural differences maybe between countries, but that you are using people who maybe haven't gone through your company's culture. When someone joins in an office, they are just by association drawn into that company's culture, way of doing things, the ethics, the just overall structure of how people do things and the attitude that they do it with. And because you're not in direct association with your remote team, it's important to both appreciate that they have something to offer, excuse me, and that you want to include them in your way of doing things, especially when it comes down to the ethical side of things or the standard ways in which your company does something. So you need to make sure that that still gets expressed, even though you're not there to let it happen naturally or sort of via osmosis. And so to do that, you need to have maybe some kind of communication platforms. Often found that just adding in a little bit of personal interest really helps people to be able to absorb that. Communicating with people, not necessarily always about just the task, just the work, really does help with that. Another thing to take into account would obviously be record keeping. You may have just a standard way of doing things, but now you're working with a team in another place and you don't know how they would normally structure things. So it's always good to have that discussion, see how things are going to be structured beforehand. If you're working in an Arabic country, for instance, you know, they write from left to right and not right to left, or other way around. Yeah. You know, things like that, you take it completely for granted, but it can have an impact on maybe numbers, maybe a date in which the way in which something was reported. And so that can have a knock-on effect, always something to keep in mind. Other countries also have completely different cultural setups. The style of communication between people is different. Some countries don't work on weekends, as we consider a weekend, Saturday, Sunday. Friday is a day off. I know in many of the Arabic countries, Friday is their off day completely. Sunday, they're working full time. So these cultural differences can play a big role in a remote project, and it's worth considering them beforehand and looking into them. The last point there, keep uniformity and personalization in balance. That's really what you want to achieve. You want to be able to have the uniformity of what you're trying to achieve, your standards. You want that in the project work, but there is a degree of personalization that's involved. How would they log the call? What would they do in this situation? And try and balance the two. You don't want to be running into a situation where you're basically taking a person who's skilled and knowledgeable, perhaps a senior geologist at site, and you're trying to retrain them as if they were a junior, just because it's in your company or your way of doing things or a South African context. So really striking that balance between taking the knowledge and skills that they have, the cultural differences, and balance it with what you are trying to implement for the program. That brings us to the method in which we communicate. So typically we would have video conferences, and I just put up some standards of understanding the limitations of these type of calls. Obviously, only one person can talk at a time. I must say on this particular platform, I think all the participants have been really good. They're all practicing excellent video conferencing hygiene, as they've termed it. But it's always good to keep in mind the limitations. So obviously, you don't want to run into a situation where you're having people sitting at the office like this. And the reason is because you want to engage with the people. You want to engage with them in a serious level. So we always advocate that you would keep your cameras on. People can see you. That way you have more of an engagement with who you're dealing with. I know there's been several studies that have shown how because we have no non-verbal, because we communicate so much non-verbally, when you're over a conference call and you don't get to see the person, you actually spend so much more effort trying to figure out a lot about them. And you're not even aware of this. You're trying to understand what they're saying, and your brain uses much more energy trying to pick up on those non-verbal cues. And it's often why we feel so tired after a day of video conferencing. So yeah, just some points to keep in mind. So now a practical example. A recent project that we managed up in Saudi Arabia. I wanted to take it from the top down. So basically, we had a detailed work breakdown structure, there's all different softwares. I know there's a tool that deals with that, but there's all sorts of different softwares available. But in essence, you want your detail. You would like to communicate. Your communication strategy needs to be simple that everyone can follow. So some kind of simplified project plan really does help everyone understand where they are and what needs to be done. So starting at a high level, never underestimate the importance of having an overview, understanding what's there. So drones can be a fantastic way of getting that overview of a project. For instance, this is just a drone image of the area. You can both see where the mining operation was in progress and where the exploration drill rig is. Anybody having a look at this can get a good idea of what the site looks like, where things were happening when we talk about them. I'll show you a quick video now just of that particular project. I'll chat about it afterwards. Hear the sound. Really, it's just music. So other than this, that didn't really have too much to do with project management, but at least it told you what you can get, overview using a drone. But obviously, that's not the technical information you'd want. You'd want the topographical survey, and that's actually really why you probably use that. So get a nice topographical survey. Obviously, that can then be used by your site team. They now know exactly where things are, elevations of boreholes, all that type of stuff. So then monitoring the team at site. I just put up this series of pictures here just to illustrate some of the points, our health and safety with the guy there, setting everything up, making sure no one's at site till everything's set up. Sample bags, remember we spoke about quality control, obviously you want to check that. When you're dealing with heavy equipment for road building or moving rigs around, you obviously want to have your safety and check procedures well in place. But then also be aware of differences. For instance, generally in African context, drillers don't, they dig a sump. They don't use those inflatable bladder type sumps. Things can work differently in different countries. And in line with that, I mean, you see some of those pictures there of the drill rig. It's very hazy. That's not actually haze. That's a sandstorm blowing by. So always be aware of the limitations of your site, whether it's in the middle of a African bush on a mountainside, doing a day-night drilling operation, in areas where the weather plays a big role, or actually on an active mine. These things always need to be kept into account of what's actually practical at site. And that really brings us to that flexibility aspect where, remember, every project will have some problems. Some have a hell of a lot of problems, but the key to being a good project manager or project managing your remote site well is being able to adapt and minimize the impact of that, that challenge or problem that came up. And so a flexibility matrix there really helps with that. It should be defined at the beginning of a program and allows you to say what's most important, whether the timing of things are more important to the project or for the project objectives, or whether the cost is most important or the quality is the most important. Typically, as a geologist, we would focus on the quality, and rightly so, but being able to balance some of these things allows you to manage your project well when challenges come up. There's a video here, but I'm running low on time, so I'm just going to skip over it. But essentially, that video was just showing the difference of when something comes up, we had to replace some diamond holes with RC holes, but it wasn't an issue because the plan had allowed us. It was flexible enough. We had our systems in place. It could carry on. Another aspect where you need to be flexible, but also really have things set up and structured well, is obviously your logging and your sampling. This is just an example of some templates. Need to have them in place, and never underestimate the value of having photos or something to illustrate what you're trying to say. So in this instance, that's an example of where some of the sampling would happen, and notes as to why that was the sampling methodology we wanted. It went along with the SOP, it went along with the sampling protocol for the project, but just having a visual thing really does help with understanding. And I can tell you now, a few things came out on this project where without the picture, they would have misunderstood. So it really helps your site teams know exactly what's going on. But this is also just a brief video to show you the value of some of the technology that's available in remote projects. So you can use photographs of the core. It's well known that there's a few softwares that do this, but you can use photographs of the core to enable you to log and do your geotechnical work directly on the photos, but then you tie it in with what you're physically logging at site. So it can be all logged either on a tablet, and that really helps with your quality control, and it really helps with the standardization when you're using different people. It also, software like this that we're using, it really helps us to be able to control things and check things, specifically like in this example here, you have core loss, core gain. Where is that core loss and core gain happening? How much is happening in that location? And that obviously allows you to sample better. So getting this all done up front allows you, of course, to sample more accurately. In pictures of what's happening at site, obviously that's a key, but don't forget that videos are
This is how we're doing sampling. This is the logging of RC samples to the. This is the start. We organize this.
Doing it. Don't underestimate the value of a video, and especially sitting on a video call. I spent a lot of time with the site geologist actually on a video call. At least there was good enough reception in that area that I could sit with them digitally and go through the logs and go through the things we were seeing in the call. Helped me also understand the requirements of the project, the limitations, and helps them understand what we're trying to implement. Pictures are obviously a key in all stages of the process, and really what does that bring us to? Well, as the final points that we wanted to bring out was really that agile project management works quite well. That style works well for remote projects. Balance that unification and personalization to get the most out of your site team. Never underestimate the value of the face-to-face or videos when you're not there. It says a lot more sometimes than just a picture or a call. And then, as we mentioned throughout, just sharing information. Make it a habit to share information. We often tend to think you know, this is what I did and I want to keep it for myself. But sharing information allows for your project team to do a much better job because they have that bigger picture. Also focusing on creative solutions but in addition to getting things done. We often just say, I just want to get into that task, but sometimes due to the local situation, your site team might have a more creative solution, and it's always good to encourage that. And then importantly, because we often forget this, is you're not there in person. So that lack of a personal presence means that there's a disconnect from you and the person that you're working with. So you need to build that relationship again, and to do so, you would want to add in some kind of humor, personal interest, of course, praise and motivation. Those things really enable you to connect with your site team. So that's always something to keep in mind. And then just to be aware, what were our biggest stumbling blocks in a remote project? Well, you're not there, so you have to rely on someone else's safety, training, and experience. And safety is, of course, a key aspect of the success of any project. You can't have a successful project if there was a major safety fail. Then don't let people operate in isolation. We said we need to split things up into smaller, manageable tasks with clearly defined objectives that can be monitored. But you don't want people operating in their one little bubble and that's it. You want to give them the overview. You want to let them know what's happening next. And that communication is really key. And then, of course, planning is probably the biggest one. If we haven't planned a remote project properly, you're never going to be able to implement it properly. So project management focuses, as I said, we often focus on the budget, the cost, and the time frame, but we don't look at the other aspects, and that forms part of our good planning on a project. Is this all just now over COVID? No, of course not. Project management, and especially remote projects, have been on the cards for a long time and have been in operation for a long time. As we know in the mining industry, we do a lot of work remotely. But interestingly, that even studies before Corona really knocked us and forced us into this remote world we're in at the moment. Studies showed that most people expected to go virtual in the next few years, and 25 to 30% of the workforce is projected to at least be working a few days at home or remotely by the end of next year. So that's the projections from the world and the markets. Obviously, that's across all sorts of different fields. And we really see that in the applications that are available. We see that, and there's just a list of all the different video conference and email, different types, all of which have different benefits. So I'm not going to look at that in particular. But the last thing is obviously just that we need to focus on training ourselves and people that we work with in order to get used to the functioning in a remote environment. We normally use a good structure. We've been working this way for a while in our company. We've been working with people remotely for a long time, and obviously the best is always when you have that level of personal interaction, site visits, spending a bit of time, a good amount of time at site with people, but having in place those structures and systems and protocols, your SOPs, your reporting systems, the cloud-based systems that we're all moving towards, having them in place beforehand really helps on a remote project. Yeah, and I think that just being able to focus on communication in the project really makes the difference between a successful remote project and a failed one. And with that, I will allow everyone to have lunch, although they're probably already having lunch while watching, but I'll leave it there.
Great, thank you so much, Graham. That was a really cool talk with your videos in there also. I was just monitoring the chat here, and we've got a lot of comments that yes, they agree communication is key to most remote project management. So I think you hit the nail on the head with that one. We do have a question from Zama also about the name of the software you were sharing there. Can they have that?
Yeah, sure. So we use a software called Stereo Core. So it's just very useful because it allows us to obviously, as I say, log and sample and really have all that information beforehand in a useful forum. Takes a bit of training, but yeah, you can work quite well with it, and it also works very well. We use it in the field. It's not necessarily logging everything from photos. It's working in conjunction with the field logging. It's not a replacement, but it works with the field logging, and logging things on tablets is really it's worked really well for us. I would say it's one of those future techs where people are moving towards.
For sure. Okay, thanks so much. Are there any more questions for Graham while we have him on the line? You can just raise your hand. Anyone?
Lunchtime, hands are full.
Yeah, I think it's, being the last talk of the day, everyone's falling asleep here, virtually with their pants down and stuff. So,
indeed.
Yeah, I don't see any further hands there. Thank you so much, Graham, for your talk, and thanks to all the speakers that oh wait, we have a question. You can unmute yourself and ask.
Hi, Graham. Thank you very much for that enlightening presentation. Your company, how are you managing the culture difference, especially not the culture of the community, but on the professional side of things, whereby geologists on site and the geologists off site have to agree on probably the methodology or the result of certain, let's say, logging, for instance, or interpretation. How do you manage that? Because from my experience, I've realized that a lot of time there is that professional conflict between site geologists and off-site geologists in terms of the quality or even the way things are done.
Absolutely, it's definitely something that can be a problem and can be a very big problem. But we found that the best way to manage it is this: no one likes being told exactly what they must be doing, and this is the right way, and there's no explanation for it. Just do it that way. So instead of being descriptive in what we're going to be more prescriptive and say that you involve the person in the decision. And have that line of communication open. I mean, we've stressed it a lot, but really what I found on projects is when you say, okay, look, I had the benefit of at least having been able to go to several of these projects. There's been very few projects I've worked on where I haven't actually gone to the project and met with the people who are going to be involved. Or at least seen the site itself. So I have a physical idea myself of it, but in general, just having that line of communication open where you say, this is what we are seeing, what are you seeing? Instead of saying, this is it and you need to see the same thing as I. That really helps people buy in. You get their buy-in on the decisions that are being made. And then I think we all incline that way, that as long as you've had your say, it's been considered, maybe they've changed the plan slightly to accommodate you, you feel your voice has been heard, you feel that your thoughts or whatever it is you had on the logging have been incorporated, and you're much more willing to go along with that. And it really irons out any of those tension situations you can run into.
All right, no, thanks.
No problem.
Thanks
I hope
for
that
that.
answered your question.
Cool, thanks very much. We have a question from Alexandra in the comment. Well, we have a question from Alexandra. She can't raise her hand. Can you please ask a question?
Yes, hi. So I work with agile project management in data science, so in more of a tech environment. And one of the things that I've seen is that sometimes you'd have bottlenecks when things don't work and your problem for the day was not solved. So everyone would stay and look around. And yes, one of the cons of this is to you need like a really dedicated project manager, and you need to have all the tasks lined up in such a way that you require some movement. Is this also the case in geological or geosciences agile project management, and how do you deal with the times when you have such big setbacks that it's sort of the same kind of timeline with like a normal analog project management.
Yeah, you hit the nail on the head there. That is one of the biggest problems or cons of a flexible, agile project management style. You really need to have all the tasks clearly laid out, and you really need to have someone, as you say, a coordinator or the project manager himself, whoever it is, just linking all those little boxes together. Those people who are working on a task by themselves, they need to be linked up with other people, and you need that person to do it, and they very easily become a bottleneck. In a geological context, in the field management side, I would say you avoid that by making sure that at the outset of the project, you very clearly laid out those tasks that need to be done and how. Having that discussion up front enables your site team, because remember, I spoke about how you need to empower your site team. It's not about micromanaging them, it's empowering them to do the task and make decisions within the task that they've been given. So that helps with the bottlenecking side. They can make decisions because they've been given that overall picture of how what they're doing ties into the rest of the project. Their decisions on, for instance, alteration log, what they're calling this, what implication that will have in the geological modeling side. So as long as they understand that, you can kind of remove that aspect of a potential bottleneck.
Okay,
Thanks.
thank you very much.
Thanks, Alexandra, and thanks, Graham. Fiona had a question or comment, and then we'll come to Thomas, who has his hand raised.
Sure.
Hi, Natalie, thanks very much. Just a general comment, thanks to all the speakers. It's been a great day. I've really enjoyed it. One of the aspects I think that hasn't been covered a lot is also change management in the process. And so we can sort of differentiate a project from ongoing mining because a project will have a specific aim. And if we go back to Richard's presentation as well, with a certain milestones, and I think Graham, you've mentioned that as well. So I just wanted to bring up as a comment that change management is really important in the process. I think that's what you've been alluding to, but it's important for us to realize that these things change over time. And that was a question I had for Richard then, with the modifying factors that go into a project, such as community negotiations, permitting, contracts with suppliers like drilling contractors and so on. These situations can change during the course of your project. And I think it's important to sort of add in there the change management aspect of that. But my question really is, what is the most recurring reason for project failure? And so if we're sort of saying that these modifying factors are going into the project management of exploration, at what point in your milestones of the journey does it mostly fail? And then how many projects are successfully brought through to feasibility? Like what sort of percentage of projects actually make it through to feasibility? I think we didn't really discuss that either. Just some questions.
Yeah, I agree. As you say, I sort of alluded to that. I didn't go into it in much detail at all. Obviously, any kind of change in any part, in any stage, in any part of your plan can be a major issue. And you obviously need to have your strategy on how you're going to change and how it's going to affect the other aspects. But in terms of remote or just general mining projects, I'd say, most projects that fail, they will fail. It's almost like what was mentioned earlier. You just have compound errors. You have poor decisions or poor products being from the beginning phase. Maybe it's from the drill core itself, and that just compounds on the way up. And by the time you get to the end of the scoping phase, for instance, you've got a project, but it actually really can't go anywhere because either some of the work has to be redone, and that just makes no one's interested in that project because of that reason, or it's not going to take a step further. I would say a small percentage. I'm sure there is some statistics on what goes through, but a small percentage of projects goes through past scoping phase. It's generally quite limited.
Okay, thanks, Graham. That was a bit unfair because I was actually thanking all the presenters, and that question was aimed at Richard Montjoy's talk from this morning. But yeah, but thanks for answering it as well.
A limited answer, be it that.
Thanks for that, Fiona.
Okay.
Thomas, last quick question for Graham.
Thank you very much, Mayor, and Graham, thanks for the presentation as well as with the other presenters. My question is, Graham, when you start a project, do you first have to go to the site to know the team that you'll be working with, or you do everything remotely?
So obviously, if you can get to site, you should get to site, especially in terms of competency. You are required, if you're signing off on a project, you're required to go to site. It always helps. That doesn't mean that you can't. There's a few projects I've worked on. They're small little projects. They're not feasibility level or anything, but you don't necessarily have to meet the person, but then video and talking to them and developing that relationship becomes much more important. If you've met the person, you've gone to site, you require limited interaction to get that level of confidence. But if you don't get that, you really need to build that relationship, and video is definitely the way to do it.
Thanks.
Cool. All right. Thanks for the questions, everyone, and for interacting there. I just want to once again thank all our sponsors, our annual sponsors, as well as specifically Colin Rice for this particular course. So thanks again to him for presenting and for sponsoring there. So again, thanks to all our speakers for today. Hopefully we'll see a lot of our attendees tomorrow also. We'll be starting, the meeting will be open from about 7:45, then we'll admit everyone and get started by 8. So thank you very much, everyone. We'll see you tomorrow.
Thanks, everyone.
Cheers all.
Thanks a lot.
Cheers.
Cheers.
Thank
Bye.
you. Right.
Bye.
Thank you. Bye. Bye.
Bye.
Yes, thanks.
Thank you.